No, that's okay.
Okay, it's okay like this?
Yeah.
You don't have two dark slides.
It's always, they're always that.
Działaj tu?
Dobra, a to sprawdź, czy cokolwiek słychać, bo to jest druga trudność.
Aria fredda?
No. Shall we have air conditioning?
Yeah, yes, because we will send some.
Un pochino.
Ok, dopo se qualcosa
possiamo...
on off... ok.
Sì, 29 gradi.
Allora scendiamo un po' dove ripartiamo.
26, va.
Ok. Ok, we're from North. A dopo.
Grazie. In caso di qualcosa la troviamo in giro?
Fai in giro.
Vabbè, c'è
Qualsiasi cosa.
Grazie.
So the camera is here.
Okay. Okay. So we also have the YouTube.
There is live streaming, but it's only one direction.
Yes.
So we say
can
hello to
take
people
questions,
online.
But there are people connected. You can see who's connected, or the.
No, Zoom is different, but we can do see. There are a couple of people connected.
Okay. Okay. I think we should start.
Okay. Come on in and welcome. Let in. It's 9:02. This is Italy, so we're gonna be relaxed here. We're not gonna keep the schedule very tight, but that's why we have allocated the entire day for this, right? So let's begin. Valerio here is a local organizer, and Paolo here. They helped us arrange all this. So thank you guys, but some introductory words?
Yeah. So welcome to Salerno, welcome to Vieti sul Mare. Vieti sul Mare is just this small town close to Salerno, and probably you will have an opportunity to walk down to Vieti sul Mare, which is just 200 meters from the hotel. And I encourage you to explore this. This is the first city in the Amalfi Coast, the famous Amalfi Coast, which is a worldwide place for tourists. Anyway, apart from tourism, we are also organizers from the Salerno University. So the University of Salerno, which is not in downtown Salerno, it's just 10 kilometers in the north in a place called Fisciano with a huge campus, is now a very big university with with almost 40,000 students coming from all the Campania region and the neighbor regions. And the University of Salerno actually is not very old in the sense that it was founded just in the middle of the 20th century, but actually the roots of Salerno University date back to the Middle Ages. Probably you have heard about the Salerno Medical School, Scuola Medica Salernitana, which was an institution in the Middle Ages dating back to the 11th century, and which predated even the earliest university in the world, which was the University of Bologna in the north of Italy. So it was an institution with a typical academic organization with physicians, medics from all over Europe and the Arab countries coming to Salerno and learn about medicine. And that's why, so there is a very long tradition about academics in Italy. So I hope you will enjoy your stay here in Salerno and Vieti sul Mare. Just a few technical information. So you see that the Wi-Fi is free, so you just have to connect to Lloyd's Baia without any password, and we tested it, it works quite fine. So we're happy about that. The coffee breaks will be just the opposite direction where there is a bar. So if you walk the corridor up to the very end and you pass the elevators and you find the bar, and so there is a terrace on the other side. There we will have our coffee breaks. And of course we have to keep the schedule because of course they will prepare the coffee breaks and everything for us.
The first coffee break is at 10:30, right?
I don't remember. So you can see the program, you can check the program there.
So this is the only schedule we need to keep.
Yes.
Coffees and food, yes.
Also for lunch, we have a quite short break, only 1 hour. Our lunch will be at the bar. There are stairs. We'll go one floor downstairs, and there will be a quite abundant lunch there. So she just told me how many things you can find them for all possible tastes. So it's you will find everything you like. And somebody asked me about the restrooms. The restrooms are not very visible because they have not attached any signal for the restroom, but you can find the restroom. Have you seen the registration area of the other conference? There is a big conference which is a conference about medicine, of course, just before our conference. There is the registration area, and there are the restrooms, so you can ask if you don't find them, because there is no signal. But anyway, this is the information we have to give. And I don't think we have anything else. No, okay. Just attach your computer to the sockets you find everywhere below your feet, and wherever you find them. And enjoy this very nice workshop.
Thank you very much, Valeria. Okay, so I think before we begin, I think we are a fairly small group, so we can afford going a very quick round table and just to introduce ourselves, to know who we are, right? So I'm Łukasz Wyrzykowski. You can call me Lucas if you struggle with my name pronunciation. Yes, I've been doing this for 20 years. Can we go here?
Hi, I'm Szejk Mikołajczyk.
Don't stand up,
Part
sit down.
of Łukasz's team, and I will be speaking to you today about data processing. So I'm the person responsible for handling all the fixed files and photometric reduction in our team.
Okay, I'm Krzysztof Kotysz. I'm new addition to the BHTOM team, and I'm responsible for the software development for BHTOM and also the categorization of that. Do you have any questions about how the BHTOM works behind the code? The person about.
Castro, I'm a representative for the Rapid Eye Mount telescope at Isola-Silla. This is an optical infrared telescope, and it produces images in a quite automatic way. Somebody calls this telescope robotic, even if sometimes they are not really robotic, but in most of the cases. So I will probably be speaking about if somebody will ask me how the data are managed, because I'm responsible for all the data management of the telescope.
Okay. I'm Paweł Zieliński, hello. I work in Institute of Astronomy in Toruń, Nicolas Copernicus University. And thanks to Łukasz, I'm involved in BHTOM for the rest of my life.
Okay, we'll see.
Hi everyone, I'm Jarosław Metz. I currently work actually in ESO, but also at the Astronomy Institute of 15.April. My research focuses on semantic values, so I use BHTOM data, but I also observe for BHTOM for microlensing needs.
Hi, I'm Ben Dryer. I'm from Yale University, but if you don't have heard of it, it's the largest university in the UK. Our students are distance learning. I'm not an astronomer. I work on cameras, CCTV, CMOS with radiation damage for space observatories. But I'm interested in how we can integrate BHTOM into our curriculum for our students.
Morning, my name is Dave Ross. I'm from Warsaw, Georgia. Nice to meet you. First time here. Thank you.
So hello everyone, I'm Anya Petruszewska. I work at the University of Nova Gorica in Slovenia. So I'm interested in supernovae and other transients as well. I've been using quite a lot BHTOM for my different science cases, and our university also has this 40 centimeter robotic telescope which is part of the BHTOM as well. Even how to use BHTOM as well.
I am Pavel Rec, I come from Greece, despite the name. I'm the representative of the Skill-Catch Observatory, where we currently have one telescope, but by the end of the year we have another one, and in 2 years' time we have a third telescope of the 1 meter class. So it will be interesting to know how to have a target observation manager for our observatory.
Hello, I'm Paolo Rota from University of Salerno. thanks to Luca for organizing this workshop. I'm working on microlensing, and I will work on BHTOM with the new upcoming telescope at the University of Salerno.
Hi, I'm Damian Reporta. I'm from Silesian Planetarium Science Center. Just last December, we opened the 70 centimeter plane wave telescope, so I'd like to use it for PhD.
I'm Greg Stokowski from the University of Krakow. Personally, I work on variable stars, types, but I also support our 2 50 centimeter telescopes, which we have. And we use BHTOM a little bit, but we also use it more effectively as well.
Hello, I'm Jessica, and I'm here as a student of astronomy at the University, and I use my lab inside light and I'm also produced at the University, and I'm doing something.
Hello, my name is Ricardo Sanchez. We have a robotic telescope 8 centimeters density. The work as we go back. This is the first time I'm using this talk, so I will do it.
Good everyone, I'm Alessia Garofalo from Bologna, Italy. I'm here because I'm involved in the Gaia Science Alert with the Loyang telescope, that is a 1 meter and a half telescope close to Bologna.
Everybody, so I work with Daniel, I'm Subtashwa. I have no clue about BHTOM, so I mostly work on gamma rays, which is formula data and artificial intelligence. So I got interested in the time series. So now I want to learn how to get and download the data.
I'm here also I have practiced for many years. Now we continue to study these modern objects with using the data measured in 2016, 2020.
Hi, my name is Papa Garfield. I'm a student from Warsaw University in Dublin, and I observed the 60 centimeter and 90 centimeter telescope. I'm Jana from the University of Warsaw. I'm a student. I work on writing and software and
Hi, I'm Paul. I'm a student at the University of Warsaw, and I study micrology in defense, actually.
So I work with microlensing. Basically, I develop software for the computation and modeling of microlensing events. And I also work on black hole gravitational lensing for observation of transiting exoplanets. And we are going to rebuild our observatory at Salerno University. That's why I'm also very interested in joining BHTOM.
I'm Justyna Olszewska from Poznań, from Astronomical Institute there, and I am observing the SAR consortium and 3D telescopes. Where I am at Arizona, and I am the full Tom to search targets for
Good, and also we should remember to take a group picture at some point, either at the coffee break or lunch break. Probably outside, yes, if it doesn't rain. So let's remember about this, okay? Okay, so I think now it's time to properly begin. Just 15 minutes later, doesn't matter. So I will just do the boring introduction, just to recap, so that everyone is on the same page. I hope you can all see the screen, more or less. I hope people online can also see that. So it doesn't work. Wait. Okay, so this is just to give you an idea of people involved. So Przemek and Krzysztof here, they are probably the only people formally employed and involved in this problem at the Warsaw University. There is also Paweł, who's involved in this system, which is all sponsored by ORP grant. I will mention in a moment. But there is a bunch of collaborators, of course, students. Juliana and Cornel are here. Some of my former students already now, Chris and Katarzyna, they're still involved there in different places doing their postdocs. Nada, she's about to finish her PhD, but is also active in this very system. We used to have Mariusz and Milena, but employed, but now they are just our friends, and they provide in-kind contributions, let's say. Friends. But also, you see, okay, at least a couple of former collaborators and contributors like Maja Jabłońska, Piotr Szczękowski, Kasia Siborski, people who at some point were involved in the project, contributed significantly. And you see, I posted some logos of institutes and projects we collaborate with. It's a big team. Of course, there's Gaia is a very important factor. You will find out soon why. And then we get some funding from Polish sources and European sources. So speaking about sponsors, so let's spend some time about the sponsor. So you're here because of OPTICON-RadioNET pilot grant. This is the website. You should all visit and give some hits to the webpage, right? So it's visible. This is a consortium of, I don't know how many, like 30 institutes, and it's a 15 million euro program from Horizon 2020, and it's about to finish actually in 2025 in February. So this is one of the very last occasions we can use this pot of money for activities like this. But there is many activities within the proposal, of course, within the grant. The main one is the transnational access to optical and radio telescopes and excellence centers. But there's also some emphasis on schools and workshops like this one, improvement of observing services and data access. So this is where we come in. So we, as a BHTOM, we are a research infrastructure, and we are like a virtual observatory, and we provide. Given the European money, we can give for free to everyone in the world. We can give this possibility to use all these telescopes we are encompassing. There is also some work on harmonization of observing requests and then virtual access to facilities, especially the time domain. This is us. This is the Black Hole TOM. So Black Hole TOM actually started under not such a nice name already in 2013, where it used to be just Opticon without radio. And the idea was that there are hundreds of small telescopes, 0.3 to 2 meters around the world. They're owned by universities, research institutes, outreach institutes, and sometimes private. They're easy and cheap to buy sometimes, but hard to operate and use efficiently. So we've gathered about 100 telescopes so far, and they have donated their observing time to our system for time domain observations, primarily for Gaia microlensing events, because this is my personal scientific case. Why not? This is something what I can provide scientific output from, right? So that's why we started from this, but we're not limited to this. We're not limited to Gaia, we're not limited to microlensing anymore. So I emphasize this because people still associate us with Gaia and microlensing, which is not the case anymore. That's why we're trying to spread to different science cases we'll talk about. And BHTOM, the name actually appeared for the first time in 2020, we built BHTOM based on Las Cumbres Observatory's open source TOM toolkit. I will spend some time later about this. But this is where the TOM comes from because of the original TOM. And TOM stands for Target Observational Manager. And we just added a sexy name to it so that everyone remembers that this is Black Hole. So this is an example of like a plot showing what we are doing here. So this is Gaia observations in blue. You see Gaia is sparsing the light curve very sparsely. And then if not the small telescopes, then we would never be able to trace the behavior of this phenomena. So this is a case of microlensing, which is exciting and can lead us to detections of black holes, hence the original name. But you can think of any science case that this applies to as well. I have a nice map here created by Chris and Przemek, where we see the total cloud cover over the globe, on average, of course. And we see that the telescopes, depending on their size, are scattered mostly around Europe and nearby, but also we have telescopes involved from around the globe. This is because Gaia is the whole sky survey, so we needed telescopes everywhere, and also we needed longitudinal coverage for short time events. This is a zoom in on Europe. So this is actually the main motivation to create this. Europe used to be a place where astronomy was taking place, something like 100 years ago. Now it's not the best for it, but still there is many leftover telescopes which are just lying there and sometimes have not much to do or are underused, right? Very often they are used for training, but they could be, when integrated into a network, they can be used more efficiently. And even places, with not such a great weather, like Poland or Lithuania or even Norway, can contribute to such a network because we have a redundancy. We have a number of telescopes which then they can replace. Sometimes it can be cloudy in Spain and it can be clear skies in Warsaw. We've seen cases like this. So we need telescopes everywhere, every time. Okay, this is our showcase, the first event, Gaia Alert, we observed extensively with the network in 2016. So this was Gaia 16 AYE. So the black dot shows Gaia data points, and then there was an alert. And from the alert, we covered the event with 20,000 observations over a period of 2 years. So I just show this here that there is a huge potential of these small telescopes and the network itself that we can do science, otherwise impossible. You would never get any observing time if you requested observations like this with any time allocation committee, because no one would give you continuously guaranteed 2 years of time on telescopes. Hello? Wrong conference? Right. And we've been organizing workshops. Some of them were funded by ORP, the last 3 ones, previously by Opticon. Opticon was lasting actually 2 seasons, let's say, before that. We actually started in 2010 in Cambridge, even before Gaia Alerts were launched. And the main theme for all these were Gaia Alerts, but also we then expanded to time domain in general. And I will advertise here very briefly that the next one is coming in September this year in Crete, so you're all invited. This is actually going to be the very last Gaia Alerts meeting because Gaia Alerts finish this year, December 2024. This is the end of the mission. So there will be no more Gaia Alerts, but it doesn't mean we will not continue. We'll have still plenty of data to analyze. So this will be like an anniversary, 15th anniversary of the very first workshop. So please mark these dates and do come. Okay, now I'll show my classic slides with some stories. And as hearing you introducing yourselves, I can tell that there are different approaches to this is why we meet here. We meet in one place, but we come from different angles. So I try to summarize it here to show that we can encompass multiple circumstances. So let's take this as an example. This is our observatory near Warsaw. It's a 60-centimeter telescope founded in 1973. Fairly old one, covered in trees, in not such a good place at all. But anyway, so we can. Come on, why is it not working? Okay. So let's say I'm managing this telescope, which I'm not, but let's pretend. So my question is, what can I use my telescope for, right? I only have 30 clear nights, to be honest, a year. It's better close it and sell the forest, right? I can go observing any time because it's very near. It's just half an hour drive from Warsaw. But sometimes I don't know what to observe. Sometimes I don't even know if this night is going to be clear. If the night is clear, suddenly I can go there and suddenly I need targets for observations. But I've been using this telescope since my research childhood, so I know how to process the data in automated fashion. Also, my students, they use this telescope for training, but also they lack ideas, right? They don't really care, they don't have the well-defined science cases, but they can observe whatever because they have fun just by the fact that they are observing. But also, this is important, I need to justify the existence so that then we don't close the telescope, right? I want this telescope to survive. So we need some publications, right, coming out of this telescope to show to the chancellor, rector, and so on, that this telescope is still active and is being used. This is the same telescope, but now we have a user who is interested in supernovae, right? So there is a supernova in M101, and the user wants to observe it, and they came across our telescope. So the question they ask, so how do I access this telescope? Is there a way to apply for time? But the proposal page is all in Polish, right? How do I understand this? And it has horrible weather pattern. Why should I bother at all with this telescope? Do I have to go observing there myself? I don't have time for this at all. And then horrible nightmare, how do I process its data, right? And if this person is actually looking for some other telescopes as well, so that this problem multiplies. So essentially, this person feels discouraged by seeing this telescope, just directly accessing it. And now let's imagine another story. There was a microlensing event somewhere here. You see Gaia microlensing events here, by the way. So there was one event in Gaia 20 FNR, and someone wants to have this observed for 1 year. So I need a long-term multi-wavelength time domain data for my target. I don't have access to any southern telescopes. This is a southern target, but this person is located in the north, let's say. And no one is going to give me observing time for one target for 1 year, right? And I don't have time to process thousands of images, which I need to collect from different telescopes. But this person is an expert in this kind of targets, and this person is going to write a paper about this, right? So you see, these stories, they give different angles. So this is where we decided to act and create, that's why BHTOM was created. And this is just a quick screenshot of about BHTOM-1, which started in 2020. So we had 200 users registered, 87 observatories. We processed about 100,000 images, and we have 1.4 million data points, including archival data. There were 300 targets, and about 10 papers were published using that data. There is at least 5, more or less, in preparation, still based on that old data. So kind of summarizing what BHTOM is, it's a tool for coordination of the network for time domain observations. We process the raw data from heterogeneous units. So there is a possibility of automation of data requests and imaging data processing. We also query time domain archives, so you don't have to do that. And the data is available to all registered users, and we can observe any target you give us. And here is the logo of the original TOM toolkit built by Las Cumbres Observatory. Las Cumbres Observatory, they've been doing this kind of stuff already for like last 20 years. So Las Cumbres is a very interesting place. It was founded by Wayne Rosing, who used to work for Apple and Google, and when he retired with his nice retirement funds, so he decided to fund an astronomical company with all his also computer knowledge, right? So he employed both astronomers and software engineers, which is a unique case in terms of, well, in the entire astronomical landscape. So they're still building telescopes. They have telescopes around the globe, and they robotize them. They work like a uniform observatory. But also people there are very helpful to the community, and they provide the solutions they came up with. They make them publicly open. So then they devised the TOM, which is the system for coordinating of the telescopes. So I was fortunate to visit them at the time the TOM was created. So I learned directly from them, and that's how the BHTOM was born. And now we still very closely collaborate with them on the development of our system. I have to mention Acon Lab company, which is Polish company, software company, which is behind the kind of, let's say, the hardware and the kind of management setup of the BHTOM. So they run the web pages. We can say BHTOM runs in a cloud. There is no computer we host and we have to take care of. So this is all thanks to Acon Lab. And these guys are doing a great job helping us expanding, making it running. Right, I have another diagram just to recap how it all works. This is in the context of the alerts, which is also one of many contexts we can use BHTOM for, right? So just bear that in mind. So we imagine there is this growing number of surveys like Gaia, but then also apart from Gaia, there's ZTF, Ogle, Assassin, LSST is going to be launched someday. And then these surveys, they provide alerts, right? And this is already a huge job for them to do that. So people came up with brokers. Brokers are places where you can go and say, okay, I'm only interested in supernovae, and I define my filters. So my brokers are giving me the targets of interest I'm interested in. So this is where users are sitting, and they're looking, swifting through this flow of alerts. With Gaia, it's easy because you can potentially eyeball it, everything, because it's like a couple a day. With LSST, there's going to be millions every day, so you'll never be able to eyeball it. So you need some kind of a filtering system, clever filtering system to weed out the interesting ones for you. So anyway, so these are the users who can provide the use cases. And one of these use cases, as I showed you, that's a different supernova. So someone wants to have the supernova observed, or this person wants to have the microlensing event observed, right? They can take this from the alerts, they can take it from anything. If they're interested in a variable star, they can also provide it here. So this is what they provide to BHTOM, and we call it an observing request. It's essentially creating a target in BHTOM is an equivalent of an observing request. So they create the target, and then they, in that way, they request this target to be observed. Then what BHTOM does, it connects to this network of telescopes. So you see, users, they don't have to directly go to this network of telescopes anymore. Moreover, the data from these telescopes is flowing to BHTOM, and this is what BHTOM is doing. It's also querying all the archives as well on behalf of the users. And then the BHTOM is producing science-ready data products. So far, it's just photometry, but we are, of course, thinking about spectroscopy, astrometry, polarimetry, these kind of all time domain measurements we can think of. Someday they will be there, maybe. But let's focus on photometry so far. So the data from the telescopes is being processed from BHTOM, combined with the archives, and this is what the users get. So you see, the users, they don't have to at all communicate with the network of telescopes. They don't need to write any proposals. They don't need to make sure this telescope works, this one doesn't, or this one has clouds today, this one does not. So this is all taken care of by this network here. And then the data is directly being fed to users who are actually interested in the data, right? Very often these users are scientists, and they do want to write the publications papers, and the bottleneck of this is taken care of by them. Of course, when we say users, this might be confusing. So when we say user, this is a case of an astronomer or a researcher who is interested in a particular science case. However, of course, users in terms of the BHTOM substructure are also the telescope contributors, right? So if you are one of the network members, you're also a user, right? So it means you both take part in this loop here, but also you can feel free to become a user like this. You can add your own targets, right? You can add your telescope to observe your own targets, right? We don't mind. You can take requests from other people, or you can process your own requests, right? So you can use us just to do your science with your own telescope, just to skip all this processing here. Or you can, if you don't have any particular science interests, then you can just listen to whatever people are interested in, and then these users here, we expect them to publish papers at the end. This is another view of it. We replace users with bots, right? So this is what the system is also capable of. And ideally, someday, we will be just sitting in Amalfi Coast drinking our limoncello, and the bots will do all the job here, right? So they will be listening to the alerts, submitting requests, data will be processed, and then papers will be written, right? Someday. Okay, I have some slides about science cases, but I will leave it to Paweł soon to talk about this. These are just the publications, and to show you that we have already a growing number of them. It takes time, of course, to write a paper. So this is also what we're trying to facilitate through BHTOM. So for example, you can download the data in the LaTeX form already, right? So you can copy paste it into the paper, something what is really tedious, and no one should be bothered with it at all. And you see, the main thing is that the author lists are very long. And this is our goal here, is that we acknowledge every person contributing to the observations. For example, in this one here, guy 16 AYE, we had even some high school kids who used their observatory in school to observe this target. It was a very bright target, easy to observe, they had fun, and they ended up as co-authors of the research paper. So this is what is, I think we realize it's important. To be honest, it doesn't cost us any money, right? So this is the only currency we have. We can pay back to all people who contributed to the observations with publications. But then in the end, if you end up on a paper like this, then you can go to your funding agency and say, look, our telescope has contributed to this paper. Give us funds to make this telescope running again, because we show this is useful. So in the end, this publication, they might turn into some gold in the end. Right. Paweł, you want to take over?
Can I ask?
Sure.
Yeah, astronomy can be a very competitive business sometimes. So without proprietary rights or protection, because if I set an alert, I want to observe this for 1 year. After 10 months, someone takes up the data, I don't have the rights for it.
Okay, I will repeat the question so that people can hear. So Paweł is asking about the competition here, right? And the rights. Yeah, this is a very delicate issue, and we don't really know how to solve this. We trust people that they are not that nasty to each other. Maybe I'm wrong. Maybe I'm too naive.
You are optimistic.
Yes. It didn't happen yet in our case, right? Maybe we're still a little bit on the niche side, but maybe someday. Okay, the system has a possibility for this. There is a way to hide and make groups. As I said, I was trying to avoid this, but if it turns out important, we might introduce this, that that the target is being visible only for a certain group of users. But then, you lose the yeah. But then, how do you let people know, if you want every telescope to observe it, then how do you let them know, right? So then people know what you're observing. It's very delicate. I would be happy to chat about your experience. What would be your recommendation, how to solve this in this complex environment? Because I don't really know. So for me, for now, the simplest was just make it all open, right?
Can you just disable downloading data? So the observer will see if that's some kind of high priority target, competitive or something like that, then only certain people will be allowed to download the data, but everyone will see the lighter, like the figure, but...
Well, now we are getting into technicalities, right? So in principle, you can hack it very simply.
Well, actually, we had that question from the beginning. How to manage your science with BHTOM and not show everybody what you're doing. So everybody asked about that, and it's been years, and we still didn't implement it. It's going to be a huge task for us. It's very important that we actually provide you that opportunity, because people want to use it, but are afraid that they will show very interesting events, very interesting projects to other people, right? So we should do this. We should have done this way back.
Because, for example, you mentioned that you can use the BHTOM to process your own data for your own science.
Yes.
So maybe then you don't basically need people to observe your target. So you don't need to show them the target.
True.
You just should have some private target which is available for you, and you can then use the system. So the system will be used, but the people will not be afraid to put their data.
Yes, it's the virtual observatory case. That you will use BHTOM just to keep your targets in one place and have all the archival data downloaded for you. You just don't want
not only to keep it in one place, but to process, because
exactly. But
after the update, the system is super powerful for that. So why then you would do that on your own computer when BHTOM can do that better?
Teraz może iść. Mam już wyciszony. Czekaj, włączymy cię. Ja się wyciszę. To jest gada. O właśnie.
Sorry.
Bardzo dobrze, ja ci muszę ustawić jeszcze, żeby ci wzmocnić. Maxa. Może będzie wtedy słychać. Dobra, to weź full screena sobie. Powinno być ok. Kamerę może też sobie włączę. Włączę kamerę na siebie.
Okay, so I will continue with some examples of usage.
Stay close to the microphone.
Here, okay. With some examples of usage, just to show you what kind of data we have in Blackhole TOM. Łukasz mentioned that mostly we have photometric data, and that's true. But sometimes for some targets, we have also spectroscopic data. It is possible to upload ASCII file with some wavelength and fluxes like a spectrum, simply. So let's start with the fact that always we can observe something interesting. So there is always some interesting transient alert on the sky that can be observed by us. Only Gaia delivers 25,000 alerts in total, but we have also other. Surveys like Assassin for the bright events, ZTF, and future Vera Rubin Observatory with large survey of space and time, which would be possible to monitor targets up to 25 magnitudes. So it would be really challenging to do some follow-up, especially in terms of spectroscopy. So how to deal with time domain astronomy? How to do it properly? So at first we need to have a target of interest selected from the published alerts, like Gaia Science Alerts page, for example. Then the observations are triggered thanks to the time allocation committee. or so proposals, or just thanks to the volunteers, like in Black Hole TOM network. Then the observations are made and the data are collected, ideally as dense as possible. And then we have a bottleneck of this process. The huge amount of data must be processed. And this is really painful. That's why we have developed Black Hole TOM, because it can help you with automatic data reduction and calibration, automatic data processing, to get a science-ready products. So, and these science-ready products can be analyzed by the users, by the astronomers interested in specific targets. And I will show you some examples of the light curves published in Black Hole TOM, thanks to the work and observations done by the users of Black Hole TOM, our observers, involved in the Black Hole TOM network, follow-up network. So I will focus only on few cases. There are much more targets, much more science cases in Black Hole TOM. This is just my subjective choice. Let's start with the microlensing events, because we are focusing on that. I'm also a member of the team of WUKASZ. So we are searching of the events with the dark compact remnants as lenses, ideally black holes. So we are looking for black holes that, so now you know the reason of the name of Black Hole TOM. And this tool was developed to gather and to process the data for microlensing events at the beginning. And this is one of the examples, Gaia 18 AJZ, published recently by Cornell, Hovil, who leading the analysis of this nice light curve. So here we have Gaia data, but to do modeling of such an event, microlensing event, we need to have as dense as we can, as possible, intensive monitoring, intensive follow-up. So here we have some follow-up data from ZTF. These data points are from ZTF. These are from other observations that are calibrated to the synthetic photometry Gaia bands presented here. So here you see Johnson Gaia synthetic photometry, Sloan R Gaia synthetic photometry, and so on, so on. So that's the names of the filter bands. And this is a nice example because it seems that it's a candidate for a black hole lens. It should be 6 solar masses or 12 solar masses, depending on the model. So there is a big discrepancy in masses, but it would be located at 1 more or less kiloparsec. So not so far, one of the closest single black hole in the universe, in our neighborhood. So yeah, we are waiting for the Gaia astrometry, epoch astrometry, astrometric time series, published in, which will be published in year 4, to prove that this is really a black hole, to prove the mass, to determine the mass independently, and to prove it that it's really a black hole. So this is one of the case. The second one is a microlensing event with a planetary anomaly, Gaia 22 DKV. The paper is after referee report, should be published in this year. So this is the light curve from Black Hole TOM, Gaia data in black, and very nice coverage of the light curve, thanks to the observations from the users from our network. You can see very nicely the coverage of the peak, which is very important in proper modeling the microlensing event. And the planetary anomaly is here. Maybe you cannot see it, so we have a zoom here. That's this bump is caused by the planet orbiting around the lens. So this is one of the very first planets detected by in microlensing events alerted by Gaia. Another example is a young stellar object, and we have Gaia 18 CJB, published also very recently by Eleonora Fiorellino from Hungary. This is the light curve of this young stellar object. So you can see the Gaia data, some follow-up, also some infrared data and archival pan-stars data. And this is a nice, a very interesting case because it's a hybrid of FU Orioni type star, type variable, based on the photometry, but based on the spectroscopy and the accretion rates, it looks like the EX-Lupi type variable. So it's something in between. I'm not an expert in young stellar objects, so if you want to read more about that, just please check the paper. The next example is the symbiotic stars. And this work is leading by Jaro Merz, which is sitting here with us. So he was leading the paper published in 2020 with the first symbiotic star alerted by Gaia, with nice coverage of this light curve. Also, Gaia reveals a very nice signal and this brightness changes for this event. We have also some flares in quasars like this one, Bowen fluorescent flares. Flare is a new class of events. Several such targets are known already. And the paper is in preparation, so you can see very fast brightness change in optical, but also in infrared. These are data from WISE survey. So it's also visible here, but it's delayed in time comparing to the optical data. And here, for this case, you can see that we have also radio data. This is the data point from LOFAR survey, low frequency array survey. So this is the axis for the radio data in millijanskis. The flux in millijanskis is shown where this, it's detectable in radio for sure. So it's also possible to grab additional info for your targets of interest, creating the target in black hole TOM and checking the archival data. And here we have the spectra collected for this target. So this is the old SDSS spectrum, and we see the change in the spectrum obtained by NOT telescope, if I could remember. So we see some changes in the flux continuum level and so on. Now we have a nice example for very long-term monitoring. So we have also several targets like AGNs and quasars where we look for some long-term variability. And this is one of the targets. So we have 20 years long data stream from Catalina survey, from Gaia G, BP, and RP. And here we have Atlas data. And finally, recently, we have collected some data from our, by using our network. So thanks to you, actually. And AGNs and quasars are very nice for the observations, because especially for the observing sites like in Europe, because you don't have to be stressed because of the weather conditions at the specific night. Simply just wait for the good night for you, good seeing conditions, and then you can grab some scientific data, which will be valuable for some people. For example, yeah, Professor Bożena Czerny from Warsaw who is dealing with these targets. We have nice examples of few supernovae. This one is great. It is very bright supernovae in M101. So we have a lot of nice data in different filter bands. If you are interested in supernovae, just download the data and do something with that. Cataclysmic variables are also very suitable to be monitored, follow up by our community. So this is the example of AM Hercules. And we see nice and big changes in the optical bands. Also, there is some change in WISE data, in infrared data. And this is a nice case in terms of joint optical and radio observations. So my colleagues from Toruń University, Karolina Bąkowska, Marcin Gawroński, were awarded of EVN time. EVN is a European VLBI network, so it's a network of the radio antennas in Europe, and they can observe together this target. The run is planned in June 2024. And in the same time, we would like to follow up this target simultaneously in optical wavelength as well. So stay tuned, there will be some announcement about that very soon. B stars, we have a lot of B stars. Actually, these are the most contaminants of microlensing events. At the beginning of the light curve, here, they are very similar, like microlensing events. And to be sure that we are looking at the genuine microlensing event that we are interested in, very often we did spectroscopy at this time, at the time of alert, or soon after. So we have a lot of spectroscopic data, like for this Gaia 2280P. This is from the SOLT telescope, the emitter telescope in South Africa, with a low resolution RSS instrument with H-alpha in emission and very reddening continuum shape. So yeah, we just we divide our targets onto groups: microlensing events, candidates, and everything else. And this is the second group. And in this everything else group, BE stars are dominant. So if you are interested in BE stars, and I know that Pablo is interested in that case, you are welcome to download the data and do some analysis of these stars. So we have both spectroscopy and photometry for many of such targets. And they are usually very bright. This is a faint example, but we have a lot of targets bright as, I don't know, 12, 11 magnitudes in optical bands. So now at the end, I will show you a nice example of light curve and worse example of light curve. These are two better examples, which are useful for modeling, because when you look at the Gaia light curve, you see that the cadence of Gaia is not enough. It's more or less 1 point per month. So for proper modeling of microlensing events, we need to have follow-up, dense follow-up. And thanks to this data, especially at the peak, this dense coverage at the peak in different bands, we were able to model this properly and solve the orbital microlensing parameters of this event. So this is good example because of the good coverage of light curve, especially at the peak and dense cadence. And this example is also nice because it's important to have the data not only at the peak, but also at the baseline. So these data actually are very crucial here to set the level of the changes and to proper calibrate the data in different bands to some specific band like I or R, and then you can model the microlensing event. The worst example, which is not very useful, is, for example, this one. So we have Gaia data, but only sparse follow-up data. So with this, we cannot do anything, and probably we could lose some planetary anomaly signal or something like that because Gaia is not dense enough. And with this data, we cannot say anything more about this event. So the observations do not cover the peak and the baseline, and this is actually example, very complicated example, because the data are good and very useful, but only some of them, like these triangles here and here, are problematic and are not useful. These are limits, which means that the quality of image done by the observers is poor. It's not enough to identify the targets or to match the target with the catalog data to do proper astrometry and then proper PSF photometry. So that's why we get such a triangles, such a limits. But also, in many cases, bad calibration is a reason of such a behavior. So please be aware of proper calibration of your data. So please do flat fields, among others, every night, every possible night. Except these triangles, the rest of the data are useful. So actually, this is not as bad as it can be with the other examples. Just to summarize the most important thing, we need follow-up. So if you are here, so you are interested in working with us and in working with Black Hole Tom, so it's good. You can help us gathering some data important for us, but also you can create your own targets and just wait for the data from the other users, right? This is also, it works also in the opposite direction. What is important? If you observe some targets, please continue observing until the brightness baseline. As I said, this is very important to have the data not only at the peak of the event, I mean the microlensing events, but also the baseline data are very important to model properly the event. So it is always better to observe one target 10 times than 10 targets only once, right? So with one data point, we cannot do anything, actually. It's better to observe one target 100 times. Dense cadence around the peak is also very useful. So I hope that I showed you a variety of scientific cases in Black Hole Tom. And also spectra are available. Not all of the spectra are published in Black Hole Tom, but it will be fixed. We have much more data on spectroscopic data than it is published already. And I hope that I prove that Black Hole Tom is a new automatic tool for time domain astronomy. That's all. Thank you.
Questions, comments?
Valerio.
In the HTOM plots, all data in the same filter show the same plot. I mean, there are processes in the same way, right? Even if they come from different telescopes, if they have the same filter, if they have the same longer filter, say B in Johnson filter, they are put all together. Is that correct?
Yeah.
However, well, we know that there are differences sometimes at the level of even of 0.1 magnitudes if we miss one data altogether. But in my experience with modeling microlensing events and taking data from each town, then it's really a mess understanding what's going on, what is data coming from different telescopes, even if they are the same frequency, so I have to be careful of batting of data. Okay, I understand the all information is there, so in principle I can do my work there, but I would like to see people also to have more homogeneous data, if anything possible, because otherwise we will have a lot of data from different types of things, and most of them will have to be removed from there. So not the very long data sets will be very stable like this, we go to the end of the full events. So that's something good.
Yeah, thank you. Good point. I forgot to mention that.
Raise the question.
Yeah, the problem pointed by Alerio is about the non-homogeneous calibration process. Well, the calibration process is homogeneous, but the data are not.
It's not homogeneous.
Yeah, so that's why we get some differences, systematic shifts between the data coming from different observatories, right? And that's true. We are aware of that. And it can cause some problems. Well, we have the info of the origin of the data. So we know from which camera, which instrument, which telescope the data are obtained. So during the analysis, final analysis of the, for example, my transit events, we can sort the data out and choose only the best quality data, and usually we do the analysis like that, in this way, because not all of them are perfect and they cause a lot of problems. But well, guys, do you have any ideas how to solve it?
I think we can add here that basically there are two reasons for this non-homogeneity. First is the bad quality data, and the second is the calibration process, the standardization. We kind of have an idea how to make it better. Color the calibration should be able to kill a little bit the differences between different filter beds that were used to do the observations. So adding the color band will be the first step. And then probably doing different photometry style for some observatories. Some observatories are providing good, very valuable observations, like for example, Rail Observatory. But we can do a better photometry by not using PSF photometry, by doing the difference imaging and so on. That would be great for the future, especially in the dense fields, and we mostly observe them. So that would be good one to make it much better.
But also, yeah, we try to overcome the problem of different filters by, we use the whole field with all stars in the area, right? So we hope that the 0 point is actually taking care of that. Well, not fully. There's no color tab included. So for very reddish or very bluish targets, it still might be an issue. We still need to figure out how to solve this problem. We're happy to take your contributions to this, to make this it has to be quick and robust, right? The standardization process, but also we would like to make it as robust as possible. We did some tests, right, on some targets.
That's probably not an easy task to do in real time, in real time. We will probably have to stay with the same standardization that we have now. In the background, there is a process looking for the best stars to contribute to the color tab, and then the whole thing could be recalculated again. So basically, to the already calculated standardized data, there should be at the color tab, which is recalculated in the background. That way it can work quickly and efficiently for all the stars. There's still a long way to go.
The good thing is that we store all the instrumental observations. So we can always, if we come up with better algorithm, we can go back and we can reprocess years worth of data in short time.
Even in minutes.
We don't store the images, however, we do store the instrumental photometry, right? So this is what we can still keep improving. This is what we actually done. All the data we collected from 2013 onwards, we have recalibrated it. So now it's of better quality and it's included in BHTOM-2 after recalibration with new method, right?
What is important, we have a data not only for our targets created in BHTOM, but also for the other targets identified in the images.
Oh yeah, that's another thing. As a side product, we also have observations of all the other targets, which soon hopefully will also make this database open. So all the stars you're observing apart from our target are also going to be published. So you can actually use it for science.
I have a question.
Yeah.
Well, there were a lot of use cases, but no exoplanet follow-up observations. So, not yet.
Not yet.
Very, very good. Because recently I was processing test data, and I have noticed that there are actually exoplanet candidates, but you have only one event. It seems that if this candidate is exoplanet, it's a long period exoplanet. So very important to have a follow-up photometry to have a second or even third event. So I think this will be very valuable for us.
Yes, this is a very good science case.
Yeah. I have a couple of such targets, and I would publish, for example, if this is possible.
Of course.
If you don't mind to publish, then yeah, sure. Because
as a target.
Yeah, many times we hear from the community that the problem is that we don't have a private groups and the data are published for everyone, right? So
very good.
But if you don't mind, you can follow up.
Is it possible to have a private target?
That's the question that arises every time. We should add this functionality quick.
It is possible in theory.
I hate this.
Feature,
Yes,
but we don't.
it's unavoidable.
Yeah.
No, I'm just asking. I'm not saying that you should do it.
Yeah, it's not easy to use it, just by switching on the feature from the DOM because of the issues here raised by Łukasz.
Can I please mention, there are cases like where you have a lot of data that are already public, nobody's taking care. So it's possible just to push into the database, giving, for example, a URL of a drive anyway.
Sure, that's what me and Chris are doing right now. So we are dockerizing the reduction software for everybody to use for free, just to install in your own machine, or you can use one of our instances, which will be available in the future. BHTOM will be where it is now, the processing software, but we will also have some nodes around the world, which will be able to process data. That's fine for the RAN data as well. Just to download it all, which has not been published, which is already published, which is the proprietary period has ended. Just to process it, generate the light curves, and give it for free to everybody to use.
Yeah, you can do it right now.
Yeah,
Right?
you can do it just to set up your. Actually, we are processing RAN data automatically each day.
Yeah, but there are, as I was saying, filling programs.
And they are scattered everywhere, yes.
There is one filling program that is following the pointing of Swift. And so whenever it's being Swift, it's being pointed when there is no specific target. So this was filling it. That one I was telling this morning is the red dots program that still is still active. So there's 3-4 red objects, now 6, 8, other engineers, and there's still long-term data.
It is a little bit, because in BHTOM was designed the way that everything is kind of per target, right? So if there is no target specified, it's getting complex,
in fact,
right?
these are two cases, two different. One on the red dots, you have
in principle,
in the other
doable.
case, we have just a spot in the sky.
And
the other thing I was saying, but I would like to understand about the photometry, that's why. Do you don't have any reference spectra for some, let's say, stable or anyway, slowly changing objects? If you take a spectra of this object, then you can calibrate, of course, the bandpass of the filters, but you have to take at various epochs if it's quickly varying the object, so that you can calibrate the bands. if you have some good telescopes or not.
That's true. Yeah, we don't think about that actually.
Well, sometime soon we'll have Gaia DR4, which will give us SEDs of all stars in the sky.
SEDs will be the...
So in a way, Gaia synthetic photometry,
well,
so Gaia synthetic photometry is like a step forward, right? That's why we decided to use Gaia synthetic photometry, because this is actually based on Gaia BPRP spectra, and it's uniform, it's one instrument, it's all over the sky. Some people remember in the previous days we were using, what was the name of it? We were using DCAPs, PanStars, APAS, and then the photometry was jumping back and forth. It was a nightmare. So once we discovered that there's Gaia synthetic photometry, we recalibrated everything. And I think that sorted many issues.
Yeah, that's okay.
So it will be even better with Gaia.
Stable object, that's right. But if for varying the object, you need to take snapshots of the source.
Then that would be the only way to do this. Just to have the spectra. But for sure, the spectra would have to be in the wide wavelength range, because not having the UV or ER.
I think 90-something% you take an infrared and optical spectrum, you already done it.
That's good.
Greg, you have it.
Yeah, so going back to the earlier question about bad data, good data. Is there a process for feedback to telescope operators for how they could improve their data collection?
That's why we have this workshop.
Aside from the workshop, just for from the sort of current running data, let's maybe able to do something differently in telescope to improve.
Well,
that's what we show today as well.
This is one person task, right? Well,
for now, I am the feedback.
So if he has resources to give you feedback, Przemek can give you feedback.
I am the feedback, but we are working on the automatic method, which we will, the beginning of it, we will show you today, which is already prepared for you to have all these parameters for each file. So if you take a exposure and then there's some kind of error, you will know exactly what you did wrong. Because, for example, there were clouds or the exposure time was not long enough, or maybe there was some movement with the telescope, so the astrometry failed. We will give you that feedback. And the process is already in place, and now the dockerization of the reduction software will complete it, and you will have all you need to even have the error code, which will exactly tell you what went wrong or right, for that matter, during the reduction process.
I would say this is very important to have the feedback for humans, as we now operate this. But in the the goal here is that we actually feedback to the robots running our telescopes, right? This is the goal. So we want the robots to adjust the exposure time, right? We want the robots to make sure there are no glitches in this. So we need to make it automated, the feedback loop, and then on your side, on your telescope side, you have to have a receiver saying, okay, this is the feedback I get, I improve my observations. So this is still ahead of us, but that's the goal, and it's very useful to have feedback. I agree. Very good. Right, you ready for some action?
Coffee break?
No. Still have time. Right. So I hope everyone is now connected to Wi-Fi and has logged into your BHTOM account, right? Has everyone succeeded in logging into BHTOM account? Okay, I don't see any problems here. Good. So the page you went through looked like this, the registration page, right? And this is where you specify your username, your name, and so on, your email, your password, and then these things. We'll focus on these things. The LaTeX name, address, okay, I doubled it, and then about me and ORCID. Why we ask this at the registration? This is because of this. I showed you the front page of the paper where we have all the authors, and some of them, including my own first name, requires a special character, right? So that's why we ask for a LaTeX version of your name. So if you have any funny non-standard letters in your surname or your name, this is the place you should take care of this. If you don't do this here, you will end up having it incorrectly put in the paper. And then, of course, the affiliation and address is something where it goes to the paper as well. And so if you don't provide it, then you're addressless, right? So your institute might not recognize that you come from that. This paper, you're co-authoring, it will not be assigned to your institute. When your director finds out, they will be very unhappy. And then the ORCID as well, it's very common these days to ask to have the ORCID link as well. So we also provide this here. At least this is old paper, so it doesn't have ORCID links yet, but the new ones, they do. Yes, so just to recap, so once you hit the registration, this requires a human confirmation. This is just to weed out robots, and we do get spurious registrations very often, like crazy letters. It seems like these are humans just playing fun, but they don't make much sense, so we just have to decline them. But there is an automated email sent to one of us, so we try to react very quickly. So typically, at least within 1 day, up to 1 day, you will have your account approved. And that's why it's quite important to write anything in About Me, right? Because if you specify your username and so on, and you don't say, and we don't know you, which can happen sometimes, then we don't know if we should trust you or approve you or not.
Recently we have a lot of
bots, something like this, yes.
Registered.
But even if you're a student of someone, then I've noticed recently students were registering and they did that. They did that correctly, but I will rephrase that. So if you're a student of Ben, say, for example, in Open University, right? So this is the place where you should say, I'm an undergrad student of Open University, I work with this and this person. We know Ben, right? We now know Ben. So we approve this person without any hesitation. If you leave it blank, then we might need to write you an email. Who are you? Are you really interested in this, or you're just playing fun, or something like this? So this is what I emphasize to new people. I'm saying this is to you, not to people here, because people are here already registered. However, this is the first action, and I will not be pointing people directly with my finger. But in some recent registration of people in this very room, you missed some of the fields. So now I ask you to log into BHTOM, then go to your profile and double check whether all the information is provided there. I mean your LaTeX name, your affiliation, and by affiliation I mean the full name of your institute, the correct way you want this to appear on the paper. You think about the future publication which is going to be there. And then the address as well. It has to be full address as it appears in your papers. And then also you can edit the thing about me. And if you have ORCID, then add it here. If you don't, I strongly suggest you create one. Under more details, there is a link. Because if we don't have these details, you might miss a publication. You never know when someone is actually going to prepare a publication using your data, and you might be not included in that paper, which would be really a pity. So starting from page 1, like the login page, it's already we're thinking about the end product, the publication. So take your time now to look into and correct this. Or?
It's not necessary to have all students registered to BHTOM, so some as well. We will have some students contributing to something, some students contributing to something else. So I will just tell you what basic individuals so this where
sure.
Is an allocation of contribution.
Okay, so there might be two cases you're talking about. So in terms of BHTOM, we don't mind. If you have a group of students who are going to use BHTOM for some of the observations, let them create individual accounts. I don't mind, really. I just was telling Ben as well. We don't mind having 15 students registered and they'll just be using this for 1 year. We'll just have more clicking on our side, approving this, but that's fine. The thing is that they will have their name associated to their data points. And I think this is what students like. On the other hand, if you then write a paper, of course, at the moment of publication, we send the paper to all people who we have data for, right? So if your students wrote a paper, contributed to that object, they will also receive an email. If you forgot about someone who was observing as well, then you, of course, there is always a place to add, I don't know, your director, if he wants to be on the paper and he's not in BHTOM, right? That's okay. That's a different problem, adding co-authors to papers. Of course, you can add people later. But in general, the kind of zero level approach, we take all people who are registered in BHTOM and who contributed to data collection, right? And as I said, we don't care about, we like that large numbers. We go to European Commission and we say, okay, look, we have this many students registered, and we don't care, it doesn't cost us anything, and it's good for them as well. So. Okay. Let's see how it goes. So, okay, to click update, don't forget. I'm ready. Very good. So, great. Second affiliation. Right. Yeah. You can't response. No, it will not. Later you want to have it automated.
All right. So basically, there should be a button add another affiliation.
Yes.
So we should have somebody who writes down all the feedback. Christina is finishing her LaTeX, and then you will be writing the feedback points from people, right?
Button for
another affiliation.
Add affiliation.
You have two affiliations?
Yeah, but we don't have this. We haven't thought about this, see? Only until today.
Yeah. Some of us do.
Yeah. So, well, for now you can add it after a semicolon or something like this, right? But we have to, we have to modify this in the system. Because ideally what we don't want to interfere. I'm trying to minimize stupid monkey job people have to do when they write a paper. I've been writing many papers and working on that author list there. This here was a nightmare. It took me like 2 days. Why? It is such trivial to generate automatically. Come on, it's 21st century, almost half of it. So we shouldn't be spending time on this.
There are no
we have
words.
better things to do.
Ja miałbym jeden feedback.
No zapisuj.
Jeden feedback, żeby się można było na BHTOM-ie logować. Też opcji też, jak to się zarejestruje.
To był mój pierwszy pomysł.
Żeby się
A wiesz, że dziady chcą kasę za to?
Kto?
Orcy.
Trzeba im zapłacić.
Skąd?
Z grantu?
To by załatwił sprawę. Chcesz wodę? Nie. Okay, are we ready to move on? Good. Now, let's go to the target list. So this is the kind of the second page. When you first open BHTOM, of course, you have the welcome page. There is a link to documentation already at the very first page. The documentation is also linked in the About Us. But then if you click the target list, then this is what you get. And the first thing I wanted to note, you to notice, is that there is already a default filter applied, right? So don't get discouraged if you don't see your target immediately in the very list. This is an idea of mine that we apply this filter just to have a short list at the very beginning. But there is a warning saying default filter applied, showing filters with importance greater than 0, right? I can spend a lot of time discussing the importance. This is the parameter of a target, which is very subjective, right? And it's very hard to specify. But typically, if the importance is 0, it means this target is not for observations, right? This is what we typically say. So if you're interested, like, for example, I've seen Tanya has been interested in this, to see what this object has been doing in the past. If you're only interested in the archival data, then you create the target and you give it importance 0. The cadence doesn't matter at that point. So if you say 0, it will not appear on that very list. You will be able to access it. You will be able to go to that target. But people who will be looking for targets for observations, they will not see it, so that they do not waste time observing target which is not for observations. Importance 1 typically means it's like extremely low level, right?
Great comment.
Yeah, well, what can I say, right? As I said, it's very subjective, so this is my subjective sounds associated, special effects. Yeah, and then if we say 10, this is the maximum importance. So it means it's urgent, you want to have it observed all the time. So if you create your targets, make sure you give this importance, well, as I said, you can specify it according to your own feelings. If you love your targets, you can always give 10. Note, we can revise it ourselves. We can go there and shrink it down a little bit, right? It's also very good to but I'll get there in a second. You can change it anytime. And also, you should make sure your target, if it's important for just 1 week and then it's not, then to go there and update it down, right? Because if it stays high, people will keep observing it and maybe there's no need for this anymore. So this is a responsibility of people requesting targets to make sure they keep updating their importances.
Well, if I can add a little bit, for now it's just for the target list, but you can query the target list with KPI and select those targets which have higher set importance that you require. So in the future, for the robotic telescopes, it will be the information which targets to observe more often. So if you don't go down with the importance, the target will be observed and will take up the observing time, which should be lowered.
Yeah, so the importance, it's for the creation, but I'll be there in a second. Just to talk about the target list. So there is this map, which is interactive, you can play with it. So by default, we plot the Mellinger map, which is kind of low resolution, but it's the whole sky, so it gives a very nice impression, I think. So you see where the targets are, these are probably mostly microlensing events associated with the galactic plane, but you see targets everywhere. And this is clickable, you can click on this, you see last magnitude, classification, and then this is an active link, you can click and then go to the target. You can switch from equatorial to galactic, it's here. If you click the J2000, you can switch there. So this is a Aladdin plugin, anyway. I hope you know Aladdin. So, so we have to rely on Aladdin. If they improve, they provide new version, we will also update it. But I think this one is fairly good. Sometimes it's fairly slow because it's an external service. So if you're on slower internet, just keep it in mind. That's why we also applied a filter straight on, so that this does not get swamped too much. You can click here on this grid to plot the grid if you want. You can change the projection. This is ITOF, but you can change projection to anything what you like. So this is, well, it's quite fun feature. There is also current moon location shown, and the sun. I don't know where sun is here on this diagram. So you can very quickly see which targets are not visible because they're close to the sun. One nice thing you can do with this map, because this is Aladdin, you can switch to other wavelengths. If you click these layers here, you can display different layers, different surveys which are there. And there's plenty, of course. Many of them are the whole sky, but some of them are very limited to some fractions of the sky. So here I show an example of XMM color image. I switched on to XMM, and then I looked for targets which are associated with some X-ray sources. And there is this nice supernova. I think this one was actually created for fun by one of our users, but this clearly shows that there were targeted observations of XMM of that very supernova. So straight on, you can already do multi-wavelength observations, multi-wavelength research, just using this map. And then you can click on this target, of course, and then continue. Okay, so going to the list. So the list is, I don't really remember what's the default sorting. So I will not cheat. I guess this is sorted by creation. So you can sort by creation. If you can click here, you can sort by priority. Note, priority is different than importance. Importance is 0 to 10, always 0 to 10. So how important the target is. Priority is a dynamical value which is computed using importance, the cadence you requested, and when was it last time observed. So if a target has been observed, is very important, and it was observed just an hour ago, it will drop the list. It will go down on the list. As opposed to a target which has an importance 10 and was observed like a year ago, but we requested it's being observed every day, right? So this one has a higher priority. So you can sort by priority for targets which are which are both important and also needs to be observed now. You can sort by sun distance. Sun means it's the distance from the sun just measured, just along the sky. So this is telling you about the visibility of the target.
It's angular distance.
It's an angular distance to the sun, right? We don't give the visibility per telescope because we're trying to be universal here, right? So this is here we're speaking about the whole sphere. You can of course then sort by class. You can sort by magnitude, by declination, right, ascension, whatever. All these are clickable. You can then display more. You can show more per page. This is just to emphasize these sortable columns. There you can add or remove to groups. You can click some targets and add them to your group if you're interested in them. You can also add to groups within the targets. There is another useful, I find it useful. There is also a list which is called visual list. Visual list. Visual list which displays these smaller footprints, like smaller images of light curves. But there you have to first, if you click the visual list, then first you need to define your filter because it takes some time to generate. But sometimes it's very nice to have all targets of your class, for example, to go swift through them quickly, right? Some of us like eyeballing, right, for hundreds of light curves. They take some time because they're not being generated dynamically. That's the thing we came up here. So they are generated. The light curves are regenerated every time there is a change in the database related to that light curve. So if you add your point, the point is being added to the database, then it's a trigger for our Kafka stream to regenerate the plot, and then the plot is stored as a whole in the database. As a JSON actually. So this is actually displaying all the JSONs. So it's pretty fast, but still it takes some time to plot. And also these figures are interactive. So you can click and then go to a target. Yeah, so filtering, as I said, this is an example for filtering. So you can filter for declination, for example. We want just northern targets, so we say declination, minimum declination to 0. And then the importance above 4. And actually, I think this is actually, it's a mistake here. So that should be more equal to 4. If you say 4, it means it includes 4, okay? So typically, above 4, it means the target is really worth observing, right? Below 4, it's typically, this is at least my personal feeling towards the importance. Sun separation, typically we say 60 or 70 degrees. This is a kind of like a handy number if you want to specify something what is visible. Then, of course, you need to go for the list and use some other external tools to see if this target is really visible from your side. But typically, this is a good indicator the target is currently visible. And then you can specify the last magnitude. Here, this last magnitude is a roughly G magnitude, roughly. I'm doing very quick conversion from whatever we have. Because sometimes we do have Gaia magnitudes, sometimes we don't. Sometimes we have some weird magnitudes from different filters. So I'm trying to make it as close to G as possible so that this is comparable, this is sortable. Sometimes it does the job, sometimes not. It's just indicative how bright the target is. So if we say that maximum 18, it means we don't want targets which are fainter than 18. So keep in mind these magnitudes, so inverted, of course, right? We all know that. Okay. Okay, of course, feel free to interrupt me anytime you want. I'll be going through this. Yeah.
I find that the filters that are available are quite limited for the choice that observers might do for a given night. So I want to open my observatory tonight. I would like to see which targets are above the horizon, sorting them perhaps by altitude, sorting them by setting time, rising time, because perhaps I have a good weather in the first part of the night, and so I have to choose the targets properly, otherwise they will. And so some targets need to be observed the whole night, for example, if you want to follow an anomaly. And so you want to say, to have all this information, which is quite easy to extract. And once, since you have the observatory latitudes and longitudes, so you can keep the setting time and rising time for each target very easy. So I'm quite surprised that we don't find this information available.
Well, but setting time and rise time and the altitude is very observatory specific.
Exactly.
But you know, some people have more than one observatory. And so, based on principle, it's not associated to any location. This is kind of, at the moment at least, this is the job you have to do yourself. You can grab the list from us of targets we're interested, and then you have to adjust it to your own telescope. But saying that, I will show you later a script which we wrote, which like a notebook, which can help you do that. To design your observing night.
Yeah, but I can tell you, for example, the test follow-up group in which I have, so this information is available for each target. And so it's the first thing I see when I want to select a target.
Yes, yeah, of course. It would be useful to help scheduling the individual schedulers, yes. But on the other hand, we do have users who have built their own schedulers anyway for previous research, and they just grab a list from us, they throw it into their machinery, and it's done, right? So we don't need to do that. So, you know, it depends on...
If you want to attract more people to BHTOM, you have to.
Sure. Yeah, I see that, and I think about that. I have that in mind to remember to include to help this to schedule each night. Yeah, it's doable, of course. Yeah. No, you cannot. It's hidden for the regular users so far. But we'll make it visible, yeah. Yes,
I have suggestions maybe. If you go to the data field, then there is a filter, your files. Okay? It's just an archive of the observations of some user. Okay? So it will be, I think, very useful to have creation data here to filter by the date or interval of time, and to have some sorting by the columns. So just to adjust more, it's an archive of the follow-up for some users. So maybe we will have some more useful things. This will be very useful, I think. Just a suggestion.
Okay. Shamek, yes, write down this suggestion that the data tab should be sortable. Yes, also should have creation data. That's good.
Just to know when we observe this.
Sure.
Which intervals.
Yes, basically adding new columns. So yes, sorting. Okay, sure.
So this will be.
Yeah, for now you can only see this when you click details.
Yeah.
Okay, sure.
Okay.
Yeah, all these are doable at the API level, right? So if there's a notebook, and then you can download the data, and then I will show you a notebook like this, and then you can do whatever with it. There's more you can do with API than there is GUI, right?
Well, actually, we have our archives also, offline archives. If you're using this will be
sure. Okay, target creation, right? We talked a little bit about this. So you can create target in 3 ways. Create it manually. So you just essentially go to targets, create target, and you need to specify first. Okay, one caveat here. TOM was designed to cope with sidereal targets and non-sidereal targets, right? So static targets and moving targets. In BHTOM, we haven't had cases for moving targets, and also the way we operate in terms of data processing, we kind of limited ourselves to static targets. We keep getting interest from moving targets communities, but that will require a little bit of tweaking with the entire system of data processing. So even though in principle you can add a non-sidereal target, it's not advisable to do so, right? Get in touch with us. If you're interested in moving targets, we can, well, it is doable, but we will not be able to process the images the way we do at the moment, because the way we historically were designed. So let's focus on sidereal targets. So far, you have to give it a unique name. It can be anything. It can be, my favorite target or my secret target, right? Typically, we give it a name of, there are some conventions. But this is the name. It's going to appear in the BHTOM database. And then, of course, write extension declination, and then the epoch for that. Classification here is the list. It's an enum. So you list it, and if you know what kind of target it is, please add it. Sometimes we don't know. We don't know if it's a new alert, and we just say unknown. But if you know it's a supernova, then it's better to mark it as a supernova, for example, or a quasar or a galaxy. If you think we should add more target types here, let us know, but we had a discussion about this. For example, we just have one entry for supernova. We don't want to go into subtypes of supernovae, right? So sorry, supernova people, but I know you don't agree within yourselves about the typing, so that's why we'd rather call it a supernova. And some supernovae might turn out to TDEs, actually. So the classification, that's my discovery. Classification is very dangerous thing. Labeling things is very dangerous in astronomy. People used to like things being segregated, but classes overlap. They are not, so there are no obvious divisions. But anyway, this is helpful if people want to observe some targets of particular type.
One class can be added already, exoplanetary transits.
Yeah. Yeah, Przemek? Yes. Exoplanetary transit.
Sure.
Okay, and the description here, it's also a very useful field because this is, of course, all these can be edited and updated later. But here, if you can say, you can give some indication of this target, not very long, unfortunately. For example, I say this is a candidate microlensing event, right? This is the most common description we give here. You can use either the description to say a little bit more about the target, or I don't know, a possible supernova which will last for like next 2 years, something like this, or a candidate for TDE in a nuclear galaxy. There is also a comment underneath every target, and I do strongly encourage people adding comments per target, which specify if you want to give people some ideas how to observe it in a more kind of human readable form. But I'll get that in a second.
May I comment one thing? Because there was a question from Pablo about that. What is the difference between classification and description? Classification is rather a formal official classification. So if the event is known as a supernova or whatever, then you can provide this.
These are predefined classes.
Yeah, the
right?
description can be provided by you by hand. So it's
just text.
It's up to you what you want to add.
So for example, when I add a candidate from Gaia, which looks like microlensing event, but I'm not sure yet, I would rather leave classification unknown, and they say candidate microlensing event, right? So then...
Or BE.
Or BE, yeah. I can say both classification if I don't know, right?
That's the most common.
And then you can, of course, filter through that. You can search for word microlensing, and then you'll find things which have microlensing in the description. Or you can search for things which are classified as microlensing, but very often these are just candidates, so they are marked as unknown. Okay.
You skip the B block. It could be that you use it for fast-moving objects for a proper motion. Because then people simply ignore it. For example, if you would use my red dots, you will never find the object because it's completely off the catalog. So unless you use the proper motion information, that's fine. If you don't use it, that's not good. Then you will not find it. And people simply skip that information.
Sure.
So Equinox is obvious. Equinox 2000, you should put a note, Equinox 2000.
Yes.
But Epoch, put a big question and exclamation mark.
That's a very good point, yes, about the epoch. And we've been discussing it. We've had some problems because Epoch 2000 is already old, right? We're a quarter of a century away from it. But the problem, what we find sometimes, is that even though we trust Gaia, we love Gaia, don't get me wrong, but some of the proper motions there are still not trustworthy. And that might be a very misleading problem.
Yeah, in fact, that's not an issue. We haven't speaking about the tensor markings. I'm speaking about the very fast
If you're talking about the very fast ones, yes.
That's horrible. That one, no problem. If it's within 1 arcsecond, you will just...
Sure.
In many cases, few arcseconds.
No, but even, like tens of milliarcseconds, if you multiply it by 25, it's already a non-negligible number. Yes.
But that will not do us wrong with the calculations.
True.
Yeah, that's what that's Vizier did. They just calculated for the other epoch.
Okay, if you do it properly, I don't care. But if you just trust people that continue to use NoB or 2MAS, and they trust that position blindly, that's really ridiculous. But if you take care of the proper motion, you take care of it, that's fine.
Well, at some point, I think after Gaia DR4, we will probably include it properly, because that will be even more reliable, and it will cover the whole sky, will be complete. Yeah, it's a very good point. That's why we try to stay with not very fast-moving objects, just to be on the safe side, right? But that's a very good point, yeah. Radio. Where were we? Come on. Yes. So then there comes this importance. So this is relative importance to other targets, right? So if you don't know what importance to put, then have a look at what people said on other targets. But as I say, if you give it 0, it means do not observe. If it's more than 0, do observe, right? If you give it 10, observe it now. That's more or less the scale here. And all the gray zone in between. And then cadence is the optimal observing cadence in days. It also depends on the nature of your target, right? If it's a GRB, then you'd probably give the importance like 100, right? Because you want it straight away. We've never observed GRBs anyway. I'm just giving it as like an extreme example. And then cadence in days should be, like 1/3600, right? Because you want to have it observed every second or so. But mostly the system was designed and it's most optimal for fairly slowly evolving targets. Slowly, I mean on timescales of maybe hours, maybe days, right? So this limits us to some science cases, of course, but it still encompasses most of the science cases. Microlensing events, CVs, supernovae, galactic nuclei, and stuff like this. If you think this is not optimal, then let us know. We will think about it, right? But in principle, this is how it works. And also, the cadence is used for computing the priority. If the cadence is set to very low value, it means we want very dense observation. But previous observation was taken like a week ago, the priority goes up, right? The last thing here is the aliases. Yeah.
Why do we have to put in here?
How often you want this in days, you want to have this observed?
Once a month, so 30 days.
30 days, yeah. Yeah, and there are cases like this. There are like quasars we want to have observed every week, let's say, we say 7. So this is the most optimal cadence, so that people know that this target can be observed on a very relaxed way.
And you can update it later during evolution of the data.
Yeah, you can make it very small for some period of time, and then so it will go up in the.
Not you will discuss later, but in the importance feel that there should be some sort of feedback. I mean, if you are a reliable or let's say a trustable user, the number stays as it, otherwise it will automatically be decreased.
Well, as I said,
some artificial intelligence in the system is necessary.
Well,
feedback.
So far we have wet intelligence behind it, and we are looking for it. If there is too many targets at high importance, then we revise it. We look into the light curve. We sometimes contact people saying, "Are you sure this is such a high priority target?" And then we can revise it, discuss it, right? Because we don't want, in principle, we don't want too many targets of very high importance, because then the system gets overwhelmed and does nothing. And then we do light curves like Pavel has shown, right? We have 1 point per target because so many targets are there.
Yes, some sort of reputation mark.
Scoring system, very tempting, very tempting to do so. Okay, and then the aliases is something what is still kind of work in progress, but these are the other names. In every community, there are different conventions for different naming systems and so on. Even within microlensing community, if something is found by Gaia, it has Gaia name, like Gaia 16AYE. But at the same time, other surveys were also observing the same part of the sky, and they have their own name. Also, maybe later on, someone gives it an IAU, TNS name, right? So one target can have multiple names, and people might not be even aware of the other name existing. They might be working on, they thought they are two different targets, but actually this is the same target, but under different names. So this is what we're trying to sort out here. When you can add the name if you know it, you can add it automatically by yourself here. So you can scroll the source name, and then you see that this, the ZTF name, for example. Okay, you know it, then you add it. What else is there?
Gaia DR3.
Gaia DR3, yes, or KMTNet name. But the best way to do it is to leave it alone. Just don't fill it. We will try to work it out ourselves automatically. Because if you give us the coordinates, we can query it. So we go to Assassin webpage, we go to TNS, we go to ZTF, even the AFSO. So we check all possible sources of names at this coordinate, and we give it here. So this is probably the best way to approach it. Once you create your target, you create it, and then you leave the system run for like it's typically no more than 10 minutes after we query all possible servers, and then we fill the name. Then you can look it up later on and see if this is correct. Sometimes we might get it wrong, so you might want to fix it. But in principle, it does the job. So the TNS names, we check, and all the others as well. So you don't have to do it yourself. Yes? No. Yes, that's another caveat of this design here, right? So we try to focus on targets. It's good you mentioned because I have to emphasize this. We try to focus on targets which are well specified on the sky, right? So that's why we don't like the moving targets. We don't like the large error bars, because then where is your target? So typically, we encourage people adding targets if you know that it's coordinate up to arc seconds, right? So this is typically for like ground-based observations. If your error bar in the position is more than that, then it might lead to many problems, because if your error bar, if your coordinate is off like by 20 arc seconds, then we might find a different name of a different target. We'll start grabbing archival data for wrong target, and the light curve will look like a mess. So 1-2 arc seconds, this is the desired accuracy of the coordinates when provided. Of course, this is another limiting factor for the targets. If you want to search for GW counterparts, this is not the place. Okay, this is the place in a way, but you cannot add your target like GW event with huge error bar. You can query our target list for your GLP counterparts. You can do it yourselves in your script, right? This is the place to look at. But okay. Yes, so another way of adding more targets than one is just to do an automated import. So you can define a CSV file, and there are a couple of examples and what fields you can add. You don't have to add all fields. The most important one is the name, type, array and deck. Probably these well, name, array and deck, these are the most important ones. The minimum required, unless we are talking about Gaia, then you can just specify the BHTOM name and then Gaia alerts name. This could be actually the same, and then it will create a Gaia something, and it will grab all the information from Gaia. You can add the cadence, the importance as well in the import file. And then it will do the job all in the background. Right. The most convenient way, however, for adding individual targets apart from import is using the catalog search. So here you specify the name of your target, and you use the service Gaia alerts, and it will pre-fill the form for target creation with all the details it has grabbed from Gaia alerts webpage. It does the same job with TNS, Antares, Simbat, NET, JPL Horizons, no. So I think it's actually removed already. So if you type in the TNS name, it will search for the target. It will pre-fill also the classification, the description, the discovery name, discovery date will go there. The importance and cadence you have to set up yourself. So this is the most common way of adding targets, in a manual way, of course, and most efficient. Right. So I think we reached the coffee break. So this is actually where I stop. I'll just show, after you click create, it will generate a blank page. Don't worry, don't panic. Go for coffee. Okay? So let's go for coffee, and then after coffee we'll start creating our own targets, okay? What time do we come back? In half an hour. 11:30, okay. Or you can ask me, yeah, here. I'll just stop here the audio, but I will not stop the stream. We're about to resume.
A był Łukasz, funkcjonalnie, zapisujecie z tym daje tak samo jest taki student, rozwijane pole, tu bierze student, musi podać superwajzora, który cały czas komunikował. Dobra, to już wysyłam, a ja do Ciebie mam z kolei funkcjonalność, do tego Twojego myślenia. Oprócz tego, co podajesz, na dole każdego, po wszystkich tych obserwatoriach, które wysłałeś mi, robisz this week's total number of files. To jest taka pierdoła, ale...
Okay, are we all here? Not yet. So for people already present here, I suggest we do a small exercise. We create a target. And I will not be suggesting any targets here, because then I will leave it to you to come up from your different areas and fields you come from, to come up with a target of interest. Like you can add an exosolar transit, or you can add a supernova from TNS, you can add an AGN you are interested in, anything you can think of from your field of interest. If you're a student, then you might ask advice from a more senior person. Paweł, you can advise some students.
Yes, sure.
No, bring the light back. Yeah, it was good. Really? Okay. But I don't see people very well. Right. So things you might encounter when you create a target, it might tell you that the target already exists, right? If you go to the create form. So it will tell you here in a small red sentence that the target already exists. Another thing is that you create a target with a different name. So it will check for the name, right? But if you create a target with a very different name, but you give the coordinates of a target which already exists but under a different name, it will also yell at you, right? So you will not be able to create a target with a different name if it already exists at these coordinates, right? This is just to make sure we don't multiply same target. That's why we use aliases for it.
May I ask you something about strange signs in the names, like classes? Is it still problematic? Because
Przemek, yes. I think we sorted it out, is that we can use spaces in the names, right?
We sorted it out. We can use spaces in BHTOM, but still this wasn't added to the processing pipeline.
So it's better to avoid spaces in names.
To avoid spaces. But in general, there is, in the future will be, whatever you can, whatever we want to put in the name.
Plus.
And plus is already solved, both in the processing pipeline and in BHTOM.
So pluses, minuses you can use, spaces, try avoiding, and yeah.
so we got never creating a target because it exists.
If you don't know what to create, you can go to Gaia Alerts webpage, for example. Just Google Gaia Science Alerts and take the random alert from last couple of days. It's probably not in BHTOM. Just create it just for the sake of training. You might then delete the task.
So searching for coordinates, how far from the coordinates is searching?
No, I just have now, I'm thinking, for example, there are two stars which are quite close to each other. Both are interesting.
Both are interesting.
For some reason, I don't know, I just came up with that. It might be.
Yeah.
But you're asking me the case that you put the target name in, you add the coordinates, right?
Yeah, okay, that's a star which has a super stupid name, I don't know, I just...
Sure, but you don't want to put the name in.
But it's, I will put the coordinates of one.
Yeah.
So I create a target. And then there is just next to that one, which is super close. It can be resolved on the exchange, but let's say it's super close.
Okay, so in case of the subsequent calculations, you have to put it just close, just right enough for us to distinguish which stars you want to observe. Because
yes, but I'm asking just because now it will yell at me that the target is the same. So because
There is a predefined set radius where we check.
But it's probably
guessing it's something like 3 seconds.
It's even it's less.
No.
And they are only, Lucas can ask, they only have 55 targets now in BHTOM.
No, there is 155 targets with importance model.
Yes, this is
What if I
So this is
want to
the one.
look
I just wonder, because that is when you put the coordinate, okay, I will just end the diagram, or it is very precise. But if then
we go to other actions, right? We go to which is not that.
No, for example, then I will try to add object, and I will not have a percentage of coordinates. And then actually there will be objects maybe in the BHTOM, and one of them will be with correct coordinates, and the second one will be because that's what happened with the FB mismatch. They picked the wrong objects. Just because the coordinates were not precise in the original catalog.
You know, we create also neo-1 stage, right? The error bar is.
I really like this thing that
So
you
whichever
can
you put in,
know your
you
target
always
name,
get
you can put just here.
So the problem with this hypothetical combat, it's something we had almost resolved quasi resolved. The first version is like what's the number? Some surveys results. Well, it's an individual case, let's say. And we did fix some session, something reasonable. Very rarely we see problems with that, but that might be.
Probably in both extreme cases. First case is that you have two stars which you want to include, but they will just still be matched somehow together. And then you have one star with not precise enough coordinates.
And then you grab like the very right one and then the fake one, and you put the wrong one. It happened once. I'm not. Well, then double check whatever outcome you get, then let us know if you see any problems.
So the
to jest może 4
So you said when you have the source labels already there, just and you know.
You can go to this target because then it's
Imagine that this target sounds strange. I want to have the difference.
Well, then you go to this website, there's no link here. You can just type in the name here. Instead of create, you can type in the name. I think there's a space.
Yeah.
Like no.
I have sent.
Yeah, there you go. So you can scroll to the very bottom. So here in columns, you create an option. This is the person who, let's say, owns the target. So if you want to get in touch, or let's say in the comment, I think it's more important. You can start the discussion. I forgot to mention this. So every target we create, there is an automated comment generated at the very bottom that you created. This is an indication for other people. Like here, for example, there was a case, she wanted to create a target, which already existed. So we looked into the target and then we found, okay, that it was Fabian creating the target. So we know who already is interested in it. You can get into the discussion in the comment, or you can email the person directly if you want to change something or observe together. So, but we keep track of who added which target, right?
And can it be disabled on this? Not to show them here.
Why?
Because that is not useful. But it's much more useful here to see the scientific discussion.
This is not filtering anything, this is just the last comment.
I know, but then sometimes it was that there was a discussion or someone edited, please observe, no, it wasn't the target which was there. And then, okay, but we will have coordinated information, but then it will just be hidden. Because you have this.
Targets were created.
Yes, because then you have most of the comments, this section for me is very unusable and.
Yeah, I see what you mean.
Usually it's just that someone created the target.
I have a question here, which
create a forum or a mailing list of this used to create.
Shall I make you know? Shall I maybe you can have we have a issue that is also
I don't think it's covered today. It's last observation. For now, it's the last observation. There is no base. There is no. This was created not only for brokers, but for building owners. I guess it's calculated for what we reduce. Yes, but it should be zero. Now, what is the importance? Okay. Can you refresh the
it should be something. I think this is a kind of target related on the start. It's taken probably last mistake the data provided by the users, which is not the case here. So there is no follow-up observation from us. And that's why it's zero. So I will write it down. There is a second way in singular.
But normally, this was over there, only on the
Okay, no, that was ale to tak ja to
No,
daj tam
and yes, it's better to avoid spaces as they said.
Dobra, i teraz wybierz sobie jest. Teraz zmieniasz tutaj nazwę, na to co chcesz. Możesz zostawić oczywiście to. To jest coś, co musimy wybrać.
So you can search it. Okay, now should write that the coordinates are already taken. You can change it here. Now let's click it.
So that's why cadence is zero. It's okay, so the computation process is not finished yet. That's why it's zero. So we can wait. But I will check if maybe okay. Maybe you're right. I will listen. We will check always.
Nie musisz. Nie. To jest absolutnie. Możesz to pisać, że ludzi działasz, ale... Na górze. Znowu jest. A widzisz, to jest takie... Na serwerze. No jest najgorsze jest to, jak było tych generacji, to tworzyć tych gestów. Trzeba później mówić, że coś tam na tej zmiany, co oczek z nas. Nie. To było obsługiwane. Tak. Tak, i los. Mały. Weź sobie tego los. Weź sobie do losu. Zrobisz sobie tutaj splita. Trzymać się oczek. Ale trzeba to wyeliminować.
But I mean that someone did that what means that? Now yes, because we changed the person created the package, but this one is we didn't normally now we have some comment here. That's the target created by but this one is both. So I think there are if you go through this one, you will see what is association with the lab. So it does show the service. So actually, you can even remove this target and create it. 1 second. Just like and you just get the same one second. The only uptime in that. No. That's
Przed zwiodem, no? To jest per obserwator i per target, nie? Napisz. powiedzieć jedyne, co tu jest. Ale to zawsze masz coś z tym kodowaniem, że źle kręci, nie? Ja bym to było, się pić do końca, no to już tego nie wiem, ja wiem, że
Sure, yes, but nobody does it. Actually, web data target we can put in yeah.
On się będzie inaczej nazywał, bo konfiguracja jest budowana, troszkę jest zapis zbudowany, żeby nie widzę się powtarzał.
So that's why we decided to see some data, but not all of them. So
no to nie musisz brać ręcznie obiekt do listy. To jest masa. To jest właśnie to wszystko może zrobić. To jest najgorsze, że to zostało bardzo proste, ale to działa. To działa. Dobrze. To jest częściowo już rozwiązane.
Because I wonder Alessiano created this area, which already exists.
Yeah, there is a lot of this.
I don't know where you found the coordinates.
Jeszcze raz.
How you get it? How you get it?
Taka jak jest to nie ten sposób.
Because she changed the
Jeszcze dokładnie to nazywa się, to też trzeba zrobić rozwiązywana, nie?
Because I just, I just noticed that there is a huge area. Okay, but then if you are off-by for our things, do you search?
No, zawieszenie trochę, tak? Co robiłeś? Jasne. Ja liczę w ogóle, że są twoje pomysły, ale ja nie będzie zrobić. Trochę tego jest, Łukasz. Co czego? No ba.
Like for in the conditions for our things. Okay, but you have not overread the coordinates. You use the catalog search. So you copy the coordinates.
Is this paint stars or is this how?
Teraz jak mi się już udało to dodać, to na tej mapce to się też powinno pojawiać, tak?
Nie, ale zobacz, że jest zaaplikowany standardowo filtr o importancji więcej niż 0. Więc żeby to usunąć, to trzeba tutaj wejść po prostu, zastosować i wtedy na mapce się będzie pojawiało, tak?
Czyli odpal ten, możesz tutaj odpalić coś?
Poczekaj.
Bo mamy baga takiego krytycznego. Widzę na szybkości. Zaraz zrobię issue. Wejdź na ten.
No, co to za gwiazdka?
Łukasz, nie teraz, jest kurde bug mega.
A co chcesz?
No weź, daj target concert, tam gdzie masz concert.
Jaki koncert?
No koncert, taki stożek, szukanie w stożku.
Że tutaj?
Nie, w dodawaniu targetu, tam gdzie masz create target.
Tu? Katalog search?
Create. Cześć, nie, katalog search. Sorry, katalog search. Target, katalog search. No. I wybierz, no wybierz coś, co... I tu mogę tylko, to gdzie jest tam, że masz koncert? Gdzie to jest?
Koncert jest tylko filtr.
No dobra.
Jak tu robisz, to tu wpisujesz po prostu żadnych i on wtedy robi taki mały koncert wokół tego, co...
Okej, to daj to filtrowanie w takim razie, tam gdzie miałeś targety. Gdzie jest ten koncert? Okej, jest faktycznie. Gdzie to jest?
Masz koncert tu. Koncert target.
To tu jest target.
Target name i search radius, widzisz. A tu jest koncert inny. Są dwa różne koncerty.
Dobra, daj tego koncerta i weź wyszukaj.
A to działało, sprawdzałem.
No i pewnie znalazł, że nie działa.
Okay. Ale ja to sprawdzałem kiedyś. Działało. To jest radec-search radius.
No.
Dobra, weź napisz od razu do akontu. Niech nam sprawdzą dlaczego.
Ale robię tego, issuesa. Slack już mnie nie interesuje.
Ale tam Jury siedzi.
Dobrze, no to będzie od razu
nie
ja go przypinam i...
Dobrze. Okay. How are we doing? Well, I'm very glad with this very first task, yes, we found lots of errors and server 500 errors, bugs. So that's the main underlying reason for having this workshop, right? To have users crashing the system and then we get the feedback. It's better to have you here and then we feed you coffee, lunch and so on, so then you can give us, positive feedback. Good. The more errors you find now, the better system will have, of course. And then I hope you appreciate that the errors will appear. Good. I hope everyone created something. We found some interesting problems here and there. Let's move on because we have more things to do. Right. So we created a target, and target appeared. And as I said here already, you can directly access the target once you create it by its name. But here, keep in mind, this is the name which appears here at the very top. So, for example, some people notice that if you use Sinbad is trying to be more clever than you, and it changes the name, right? Which is annoying. We'll fix that. But then, if you want to access the direct page, each target has an ID, which is just a number, or it has a name. So you can directly type it in your browser and get to the target page immediately. So after a while, after you created the target, all the fields here on the left are being filled, the constellation, the discovery date, last magnitude, and so on. Even the observing priority takes time a little bit to recompute. And then the main product here you see is the light curve. All the time domain observations we have for that very target are being grabbed. So for example, here we see just Gaia and NeoEye's data. Right. Yeah, so and then the other names, these are the aliases, which are automatically recognized. So if, for example, if you add a TNS name, it might find that there was a Gaia alert, and you even didn't know that. Or it will give Gaia a free ID as well. Okay, so this is an interactive plot. You can download the data from here. You can download radio data if it exists. And it lists the most recent photometry. Okay, so there are two types of plots.
There are so many issues with us to solve. Either that or that.
There are two plots, two types of plots. The upper one is per filter, where you see this is the entire light curve spanning, you see 25 years. So this is actually 2 months data taken in 2000s. And this is the all possible observations we have time information for. You can zoom in, and then you see there is Gaia data, there is this noisy Atlas data, and then you see some follow-up observations of this very nice microlensing event from different surveys. You can click here, you can, if you double click, then it will show you only the very filter you want to see, or if you click individual ones, you can switch off, switch on some filters. You have the triangles for the limits, but this is something where the data was not measuring anything. Another way of plotting is per facility. So here you have 2 mass, for example, right? So all these filters are now marked with 2 mass. This is all new Ys, this is all Ys, so they all have the same color. Gaia has the same color. And then, let's say, Uliana's data from LCO-SS are marked with blue, and then Uliana data from CDIO are marked with green, right? So you can also click it, you can zoom in, and then see different facilities providing different data in different parts of the light curve. Note that these colors are not assigned. As for the filters, the colors are predefined. If you have a suggestion how to improve this, I'm very happy because it's a manually decided color map. It works so far. The red ones are red, green ones are green, blue are blue, right? More or less. But there is multiple shades of red, multiple shades of green, and so on. Here for the facility, the colors are assigned at random. Every time the picture is regenerated, which is not the refresh of the page, but adding something some change in the data, it forces the regeneration of the plot. So then the colors are completely randomly assigned. We had cases where we had pale yellow color selected as well. So it's very hard to see. But this is something what we don't have influence for, and it's it's actually quite fun. Right. So these are these two ways of plotting. There are also models, but I'll probably skip that because this is very microlensing specific. You can do some analysis of the data already. Just by one click, you can get a clue on some microlensing models. But I will just emphasize here that we are very happy to have your contribution here. If you have any idea on photometric behavior light curves modeling, we can add here. I don't know, RR-Lyry period search, for example, right? We can add it here so that then people can use the BHTOM system to search for periods, right? Fourier transfer, something like this. People have experience with that. So we just need a piece of code from you, and we can plug it in here, and it can do the job. Also, we've been thinking about some simple models like detection of the peak, for example, for some supernovae or TDEs, like parabolic fitting of the light curve. So as you see here, the microlensing model is interactive, so we can play, we can set the initial values, we can change it manually, and then we can optimize and look for some solutions. So we can do exactly the same for any type of photometric data modeling. And this could be very, very specific for your case. And so here your contributions are welcome.
One band from one survey, right?
No, this works on all bands, but you can select which bands to use in the model.
But not simultaneously.
Simultaneously? Yes. Yeah. In microlensing, it doesn't matter, actually. You can combine all bands. In other filters, other science cases, it might be different, right? So you might select, I don't know, just the best band. The best covered band, or something like this.
Yeah, but probably was not clear. You're speaking about one band at a time, not fitting simultaneously.
But in microlensing, we do that. We fit simultaneously all bands.
Altogether.
Yeah. Well, in principle, macrolensing it does not depend on the color.
Yeah, well, that's what I'm saying.
This is a very peculiar case. For all other cases, it probably does matter. So you want to, if you want to search for your period, for example, then you want to search for a period in this band, and then in this band separately, in this band separately. But this is all manageable. If you have ideas, get in touch, and we can come up with something what will be very useful for your case and also for others.
If you have a part of the code doing that, it's even better.
Yeah, exactly.
What language do you use?
Python, Django. Django Rapid Python. Okay, brokers, so we call it brokers, but it's mostly the archives, the time domain, archival data. So you see for different targets, you will get different amount of information. So I just listed here some. So we search for Gaia alerts, of course. We search for DR3 variables, and then ZTF, of course. Catalina is an old survey, we search for data there. There is also linear, very old one. As you see here in this bottom light curve, there is some linear data. These are white, broad filters, so you don't get any filter information, but still you get time domain information. For some quasar studies, I've seen beautiful light curves of quasars varying over time space of decades using this. There is SDSS and Stripe 82 as well. Pan stars, decaps, these are typically single epochs, but still this is some information. Near infrared, all-wise and neo-wise, and also we've added radio. There is first and LOFAR catalogs from radio. Typically one epoch, but still it's an indication that there is some radio information. We're planning on adding, I think Ogle is already there, but ChemTNet, MOA, and Ogle variable stars, this is to be added. There's also DASH, hardware photographic plates, very ancient ones. They have a horrible interface, that's why we haven't added it yet. But this is generally the idea that we might have 100 years long light curves available.
Now, a few weeks ago, there were new data release.
For DASH?
Final data release.
Oh, really?
They finished
of this
Excellent.
photographic plates.
They finished the digitalization.
Excellent, good to know. So maybe they've improved the API.
They did.
Oh, this is so kind of old, very old-fashioned.
They did
So
photographic observations.
So, but this is something what we have to keep in mind. And
They found you in the basement.
okay, yeah. One last thing about archives. So something what we used to call CPCS. So Cambridge Photometric Calibration Server. This was the original name of our system before it became BHTOM system. So some of you involved in the last decade were using CPCS, which was part of BHTOM 1. So we have reprocessed all observations from that decade. We matched it to Gaia synthetic photometry, and it is all there. It is named with your observatory, your name, and it has CPCS added to it, right? So this data, if for that target data was there, we also grab it automatically. You don't need to worry about this. Okay. And then for publication tab, there is this table, photometry statistics. You see what number of observations are there per object, per survey, and then what is the range of times it used. So you can download this photometry table with one click of a button. You have a table ready for copy-pasting in your paper. Right. Upload. I stop here because this is Przemek's and Chris's task to show. Any questions up to this point?
So did I miss SkyMapper?
SkyMapper, they only provide small images. They don't provide photometry.
Just released the year before.
Have they?
With all the
Really?
I just grabbed the full catalog that's in my interface.
But you mean the photometric light?
Yeah, they can also, well, they have multiple measurements. So they have a set of catalogs for multiple. So
excellent,
if you
yeah.
want to check, that's one.
I will add it.
Yes, SkyMapper 4.
SkyMapper.
4. DR4. Yeah.
Yeah.
They have a lot of new catalogs released a few months ago.
It's on the southeast.
Yeah, of course. That's
Oh
why
yeah,
I'm seeing them.
that would be useful. Yeah.
Of course, that's why we use it.
Excellent, excellent.
And the other thing is that probably because it's not relevant, but I miss all the narrow band filters. Well, it's more important for extended source array than single source.
But is there time domain information which is important?
No.
Yes, so we try to focus on time domain,
Piece of additional, let's say, research project that would benefit from.
There is a lot of static information available for targets, and we don't have it. We are thinking about how to do this, how to provide for each target all the static information. Typically, Simbat has a lot of them, but not all of them. I don't know, it's kind of a duplicating of work. We try to focus on time domain, but you're right that
at least let's say H alpha or O2 or yeah.
Yes. Okay. So I stop here. We move to the next part. Now I did. Okay. In the meantime, you can check how your targets are doing. Is there any new data appearing? Jezu, beznadziejne to jest. Gdzie jest Slack? O, tutaj. Jezu, proszę sobie. Łukasz, widzisz tam u siebie? To nieźle. Okay, guys, I will now introduce you to the data reduction. I will not be speaking about the whole processes, the whole body of processes which lay under the web page that you can see. It's not the purpose of this workshop, but in the course of this 45 minutes, I would like all of you who have their own observatories or are in possession of some data to process to set up the new observatories. Okay, some of you I not already did so. I think 3 or 4 observatories were created. But before we go to the main point of my talk, let me just briefly introduce you to the processing pipeline. So Łukasz already said that the main point of our whole operation is to gather data from different places. And the most usable, the most exciting part of this is our proprietary feeds reduction pipeline. So you can see here that the whole communication relies on the BHTOM, which is in the right, and it produces the light curves that you can see here in the bottom. So we are using a variety of different software. Our goal here is to use only free software, to not buy anything. So we basically rely on 3 main set of routines and subroutines, which is SecTractor and SCAMP. With those we use to provide astrometric solutions. And here I just want to mention that we are not trusting your astrometric solutions. If you upload your file to BHTOM and it has a perfect, at least by your standards or by general standards, perfect astrometric solution, we delete it.
we don't want it because even if in 1% of cases it's wrong, this is we'd rather reduce the data for a little bit longer and calculate our own solution than rely on something that we cannot trust. Maybe we can trust LCO, maybe we can trust RAM, maybe we can trust some telescopes, but in general, we do not trust users with their astrometric solutions, which are already in the FITS files. And the DAOFOT software, which is, as you can see, very old, but still very, very fast. This one we use to calculate modified DAOFOT, let's say, to calculate profile photometry. So here it goes. Here it is as it goes in the whole pipeline. So we take the data from you and some set of observations that you give us during the creation of the observatory. Then we are using reference catalogs like Gaia catalog, like URAT catalog. In the past, we use USNO catalogs to find the reference stars and to provide astrometric solutions. Then we do something called astrophotometry, which is basically astrometry plus photometry with SCAMP as a tractor. It's very easy. It's just for the reference to have the whole picture of how bright or how dim are stars in the picture, and to check if the astrometry was done correctly. And then we use DAOFOT to provide us with aperture and profile photometrics. So basically, after the whole process, we have a picture like presented here, and we get a picture with subtracted stars. And the whole idea is to supplement the automatic routine searching for stars in the picture with Gaia catalog. Gaia catalog has perfect positions, so we will always know where are the sources. Yes, so if we have a nice astrometric solutions, we can subtract all the sources that are present in the field of view. So light curves are calculated for all the sources. The light curves results are calculated for all the sources, and the side effect of what we are doing here is will be the catalog of light curves for all the sources in the field of view, because we are only interested in one star, but all the other measurements are written into instrumental photometry file. Then we can build the time series for any object in the field of view. So this will be the side effect, but most probably it will be a huge and a very valuable catalog. So here are some examples which I showed before quite often of how our photometric pipeline deals with different densities, stellar densities in the field of view. As you can see here in the picture in the bottom, after subtracting the sources, you can see the fringing in the image. So the ratio of signal to noise is basically killed. It's only noise visible, and it's in all cases. Here is the bigger picture, only one band bigger picture that you already seen. So of course there are some artifacts for too bright stars, or maybe some saturation. There are some problems around the visible nebula, but this is to be expected. And this is a very prominent example of Gaia 16 AYE, which light curve Łukasz already showed. And here in automatic manner, over 14,000 sources were subtracted without interaction needed from us. So we didn't sit on it. We didn't select the stars for the PSF model. We have some automatic procedures to select the best sources to build a global PSF function, and then using this DAOFOT power, which is a correction table for each pixel for PSF photometry, we can subtract sources very well and produce this residual image. Okay, so what we are doing now with Krzysztof is Dockerizing the reduction pipeline. So the problem with such pipeline is that it consists of many parts. Every single part was produced in different era, let's say. Some even were even in the 80s. So installation of such software in a single PC is a nightmare. So basically, I can do it, Paweł can do it, and Krzysztof can do it, but no one else. So what we want to do is to Dockerize the whole pipeline and give you in a Dockerized version that you can just download from GitHub and run it on your own machine. And this is not the primary objective of ours. The primary objective of ours is to clone our reduction software into many machines and then to tell BHTOM that if one machine is too busy to process your data, send it to another machine, which is also available. We have at times this problem that, let's say, hundreds of files are being processed at the same time. And after, let's say, an hour, I am getting an email, look, I have just uploaded my data and it's been 25 minutes and it still haven't been processed. It hasn't been because we have 150 files in the queue. And we want to kill that problem. We want to have the many machines capability in order to have faster calculations and faster feedback to our users. So in order to do that, we have to make a Docker out of the our processing pipeline. So it's right now being divided into some Dockers, a few Dockers. First one is just the feeds manager, which will correct your feeds headers and maybe repair a file if it's broken. We've seen that sometimes people upload broken files with some missing feeds header words without the proper control sum and so on. We can kind of recover from that. It's also the job of feeds manager. We have the astrometric pipeline, which I already told you about, photometric pipeline. We have Gaia astrometry. And the last product of our calculations is the once again done astrometric solution. But this time we are using the best Gaia catalog available for now. So it's Gaia DO3. Then we prepare the results, which we will show you what they look like in a second. And we also will leave in our Docker versions IRAF and PyRAF functionality. Of course, IRAF and PyRAF are not being supported anymore, and they will die in a decade or so, maybe. But I think IRAF was pronounced dead many times, and people still use it.
It's alive, actually. Yeah, but now there's.
It's I heard that there was some kind of reanimation done to 2.16 plus version, but I'm not sure it will really make a difference. Yeah, I know that, but still Python, the AstroPy routines will in time substitute all IRAF and PyRAF functionalities, yes? And you don't have to install IRAF then, so, but we will leave it just to have it around. Some of our procedures use IRAF, but probably in 2 years' time, we will just disable it. Okay, so that's how it basically works underneath. And here is the main thing that makes this whole mess possible. So standardization of feeds headers. Yeah, I will not really dwell on that thing, but I will show you how the simple single dictionary or mapping looks like. So this is for Go Chile, I guess. So it's for Tanya's instrument. And we know which feeds words are present in the header, which are not, what the values are. And here you can see a very interesting thing, that if you have filter names, that sometimes they are not really readable by us, yes? This is r/HAO3, which is a real entry in the feeds header, but this is in real life, it's just R filter. So if we take this and then we have it in the results, of course we standardize to some kind of filter, so we know what band it is, but still we want to give you feedback what the real filter installed in the observatories. And this is not a problematic one. Sometimes we have a filter position called top 1, bottom 5. Because there are 2 filter wings, right? Or maybe there is no letter, there is a position of the filter wing 5. We don't know what it is. So we have to check, do this, and kind of map it, let's say, for many values. And each observatory has this kind of file in our server. But the Dockerizing of all of this and using the BHTOM API, we want to switch to something like this. So we learned which keywords we don't have to use. So we have a single file for all observatories, CSV file, so we can easily load it, read it, correct it, change it. So basically what we will do in a second, create an observatory, we still have to use this kind of dictionaries, and you have to wait sometimes a week for us to have time to check the feeds files, to check if it works, and then give you feedback that's activated, and you can upload your data. In the future, and close future, we want to give you, we want to have something like this, and test it automatically, activate it automatically, so you just wait, let's say 2 hours, our system will test if it works. If it works, we'll give you a green light and you are set. Okay.
You have against the JSON format related.
Sorry?
Why you have something against the JSON format?
You mean this?
No, yeah, but JSON will be similar but much more readable.
Oh yeah, this is just to tell you that all the different telescopes are put into one file. You have JSON, CSV, it doesn't matter. Because if once we program it, you just have to decide what format it is. Doesn't matter. We will not show you this. It's only for us.
That's why. That's what
yeah, of course, it's much more readable, right? But doesn't matter. You can have some other format. That's much. Okay. So now, please, I will show you. I will swap between the presentation and web page to give you a tour of how to use our observatories, how to create an observatory, how to fill in the form, observatory form, which is fairly easy as some of you did it. So if we go to this BHTOM2 Astrolabs PL or just BHTOM space and go to observatories. So let me, yeah. If you go here to the observatory page, then what you can see in default is favorite observatories list. And these are the observatories that I added to my list. Of course, in my list, there are all observatories because I am the admin of them. I have to activate them. I have to test them out. In your case, it should be empty or nearly empty. If you want to see which observatories are available in BHTOM, then you click on observatories. Okay, this is the full list. This is the full list of observatories.
Sorry?
You
can sort it.
Yeah, you can sort it by observatory, let's say name, all name. You can sort it by comment, by longitude, latitude, observatory name, and so on. And in each observatory case, you can see details. So let's say we look at the newly added APT2. I am not sure who added APT2. Yeah. It was Ricardo. So let's look at the APT2 observatory, and we can see details. Okay, when you click on details, you can see anything which was. Sorry? It's very good. It's very good. For example, I know what you mean. Okay, so here you can see camera name, camera gain, pixel scale, an example file which is not present as Ricardo pointed out the bug. It was your first attempt without the.
One week of
Yeah. Okay. So look at the another one, which we will use today. Hopefully, is ASV 1.4 meter Milankovitch telescope. Okay. This is there are much more details. So longitude, latitude, altitude, limiting magnitude, some filters and comment is the general section for the observatory, right? So it would be the same for any telescope
for any instrument used at that site. And then there is a section for cameras. Of course, sometimes you use 1, 2, or more cameras, so you can add a new camera to the same telescope. If you have 2 foci and you do different instruments, like in case of REM, when there is one telescope, but there are 2 different instruments, which one is ROS2, and the second one is REMIR, which is an infrared camera, then you have 2 different instruments using the same optical system. And of course, we have the example feeds, we have some binning, what is the saturation level, what is the pixel size, and you can easily spot that not all these characteristics are needed for the working of the system. Let's say readout speed or let's say pixel size. These are not needed for the photometry to be done. But in the future, when we want to when we want to make a specific campaign, we want to know how quickly you can read from the camera. Because if you want to measure the very fast changes in a star, if your camera is reading, let's say, for 20 seconds, this telescope is not usable for such a campaign. So as many things as we know, our cameras about our telescope should be put in the form. Okay, so
one thing,
yes,
this is very important what you're saying, and the other thing to add from is the separation, not in electron AU, but in magnitude. So which is the brightest star that you can before you have saturation in the various filters you provided.
Yeah, that actually would be nice to have the limiting magnitude on the brighter side. Yeah. Here in the saturation level, we don't really mean the saturation level. We mean kind of the linearity range of the camera, because this is the digital saturation in terms of to the power of 16 minus 1. It's never the case because you have bias and so on. And if you subtract some numbers, then it's always lower. And it's always lower because of the non-linearity effects. So, but fitting in this form is fairly easy. You just have to check what is your camera specification. So this would be a one single observatory detail page. Okay, and now to add your observatory to your list, you go to the observatories and click on Add New Observatory. Adding new observatory will leave you in such a page when you have a list of observatories already activated in BHTOM. Okay, so here are all the observatories that are active. Okay, so I can, let's say I can use, let's say, Salerno. Okay, so it's already been activated. Somebody set it up today, created an observatory. It's already activated, and the moment it's activated, it's present in this list. I can now add it. There's only one camera available, and it's being filled. This FLI PL230. I can leave a comment just for test purposes. This is what's made by this. I don't like this camera. I love this camera, whatever you want. And then you add it to your list. Okay, so this is basically what you need to do if you want to use any of our instruments already present in BHTOM. And this is the case when you have data from some observatory which has not been reduced. Let's say you observed in Piwnice for 2 weeks, and then you want to upload data that you gathered in Piwnice. You just add the observatory which is already in BHTOM, process your data, and you have. What do you have to do if your telescope is not in this list? Then you go again to observatories and you add new observatory, but this time you are not choosing from the list because your observatory is not here. You need to go to create new observatory, and this is the thing that I would like to go through with some of you at least. Some of you already have your instruments here. Some of you did it yesterday and today, and if you still didn't do it and have a telescope which you think should be present in BHTOM, we can go over the whole form, and I will just go through it by field, okay? So basically you put any name you want.
the desired name will be the true name of the observatory, not the name of the telescope, just the name of the observatory. So in case of Piwnice, it would be, I think, Piwnice Astronomical Observatory. Longitude and latitude, of course, we need for the calculation of heliocentric correction. You put a approximate limit magnitude in band. It doesn't have to be really precise. You kind of know what are the faintest stars you can observe with your telescope. If we still check it somehow. If you put 19, we will probably increase it or decrease it by half a magnitude after checking what your telescope can do. But this is an information for us. What is the approximate reach of your telescope? Then you put filters that you have installed in your observatory, but this time you put what they are like in its headers. If you are writing your filter not by V, but by tree, just put in tree. We need to know what is inside your files, not what they are really like, but what's inside your files. If it is R/HAO3, as in case of Go Chile, then you put it here. Of course, altitude, telescope aperture, telescope focal length, and telescope's name. If it doesn't have a name, just put like size, 1.4 or 0.6, whatever you want.
You do not make any real check with the AM official list of telescope size. One can put a virtual telescope, let's say.
Yes.
Yeah,
We don't check.
We don't check that. Maybe we should, but we don't check that. Whatever you wish your telescope name is, you put it here. Sometimes we make little changes if there is a letter wrong. We just check that, but it doesn't really matter for us. And then you put and then you put comments. Sometimes these comments are the most valuable thing for us, because here you can put hyperlink to the documentation of your telescope, to the documentation of your filter system, to the documentation of your camera, to the the technical specification of instrument. And it's sometimes even it's much better to put some names. This telescope's admin is this guy, and here's the email, or some information like our filter wheel doesn't work. We have 5 filters, but it doesn't work. So all our observations will be in this filter for, let's say, 2 years. It is just a feedback for us, and it's very valuable. Okay, after you go through this very simple section for the telescope and for the observatory, you go to much more technical one concerning the cameras. And you can add as many cameras as you want, as many instruments as you want. So you put the camera name, and then you fill in the camera specification. So things like binning, things like gain, readout noise, saturation level, pixel scale in arcsecond per pixel, pixel size, readout speed, and this one we don't kind of require from you. So if you don't know, just put 4 nines, but if you can find it, please do. And we ask of you to attach as many FITS files as there are different filter bands used at your observatory. And for us, it's the easiest to get observations for one of our targets. But if you provide a different target, which is not in BHTOM, that's not a problem. We have the way of testing it out, of course. It takes just a little longer, but not a problem. So here you put all the characteristics, and then you can create your own observatory. After you do it, yeah?
If you are here,
Mhm.
there is also the only photometry.
Yeah. Instrumental photometry file. This means that if you click on it, look at this, the camera disappears. So we will not be able to process FITS files, but you can upload a DAT file, like an already reduced photometry, for exactly in Sextractor format, for us to standardize to standard magnitudes. You can do it, but
if you are capable of, you want to do it as a type of exercise of your students, you do the photometry yourself, then you can, well, you probably In the other case, we want to create two observatories, one for its one for non. We can use either, right? And then we will standardize it in the common way, but we will not process your fleet files. This is also an option.
So there was a question by Ricardo about this. Ricardo did this matching of the instrumental photometry file, right? And now we want to update the info about the camera. Yeah. So is it possible, or Ricardo needs to
create a new one?
To create a new one.
It's basically the same amount of work, so it's basically easier to create a new one. We will delete the other one. Yeah, this is a little bit confusing. This only instrumental photometry file, I guess, in the whole operation is not to avoid it, because we want to do all the reduction the same way. So if you have your own routines and you are confident that you can do it better than we can, then sure, leave it marked and upload on your photometry. For us, it's less computer time needed, server time needed for the calculations, but in essence, in general, we want to do it ourselves. All the calculations for all different observatories would like to do in the same way. Of course, we are not able to account for all the effects that we don't know about your files, about your data, but still the light could show that we do pretty decent job, I guess.
But it is always good to have all the information also about the camera. So without marking the only.
That's true. If you don't,
can upload either sites or.
Exactly. This is a good point.
This is a very good point.
If you create your camera, then you are allowed to submit both fixed files and extractor files.
So then we don't have a problem.
You don't have to create two observatories.
So the solution for you is to create the second, the same.
The same for files.
Observatory with some
create one
different name.
but you can still upload.
You can add. Yeah, you already the number two or something.
Yeah, we already solved something. Okay, so basically, so to summarize this, Pavel's great point. If you don't tick the only instrumental file, you will be you are always able to upload your instrumental photometry. You can upload your FITS files to let us process them, your own process instrumental photometry, your spectra. You can even upload your time series.
Which is not recommended.
Which is not recommended because
we don't have any influence on this.
Yes.
This is the way you process it, the way you add it. There is only like in your own filter. There is no other stars around it. You cannot. But some people do that. Some amateurs submit their own light.
I think about one case, please. When you have a source within a galaxy, and then you want to subtract the galaxy.
That's true. There are many cases in which it would come in handy, and this one we actually kind of hate this thing because we observe supernovas, and we have this background effect. For this, the difference image analysis would be the best. Or just the subtraction of the flux, even the flux.
If you do your own difference imaging,
then
obtain your own lighting, then you can upload the entire.
I was thinking, nobody else speak about the star less images, so we're wondering how we get a reasonable good result. But the higher top one is probably fixed inside is the best software, but we have to pay for it to do it.
Yeah,
so
we have we can do.
Or using tractor, if you use the tractor method.
We use the DIA package for different image analysis, which is perfect for sources within sources like supernova in galaxy, but it's not it's not our basic standard method. So for now, if you observe a supernova which it has some galactic component, then you can abstract the flux in the galaxy itself. But in many cases, supernova is in a large distance from the source.
Well, not always.
You cannot.
Not always. We have.
Yeah, so this is a caveat. When we observe supernova, we better observe these ones which are far from the source.
Okay, so maybe so if are any of you trying to create an observatory right now, or yeah, is anyone creating observatory? Okay, Damian is creating observatory, so we will wait. Yeah, it's okay. And then I'm asking you I'm asking you to go to the hyperlink which I provided for you in the email, where the test data is waiting for you. And we will try to, I think we will do it after lunch because it's 10 minutes left. So in this 10 minutes, I will help and maybe activate Damian's observatory as well.
Yeah,
And then
Ben is also creating.
Ben is creating his own. And then please, after lunch, have your test data downloaded, or your own data for that matter, and we will try to upload the files in two different ways. Once using the web interface, which is okay for observations done from time to time. But if you have a telescope that can have generally a large output, so a lot of files, it's much better to use API, to use or a script already prepared for you, or you can make your own, really. So I will show you how to do it. Many of you already use it, so I know it works very nicely. So after lunch, we will look at the web interface and we'll look at the API, and some of you will have first meeting of our documentation, and then we'll try to upload and look at the results. Okay, so I guess for now it's that will be it. You can now create your own observatories, and we will try to activate them as soon as possible.
Like not a very full, students upload their and how well they do. There is another that would be really, have it in there like big area.
And then the same observation is uploaded again as a subtracted file. Will the system yell?
Yeah, for every, okay.
What do you mean yell?
No flag, but then you can add a flag,
No, why?
Because we have a engine.
You mean this?
You basically have
It's the same, it's the very same image. But once, so the first one is uploaded as a fixed file, the other one is uploaded as a subtracted.
The whole idea is to let you have the opportunity to correct yourself.
Because now I have no way of
Calibrating the fixed images, upload them, I didn't track biases, and you do it again, you should be able to upload them, and they should be substituted. And we talked about that. I think for double question, right? That we fail to match with other service because MJD exists.
Yeah.
But we should be able to say we have a problem because we have 100.
That's on the title page. Okay, starting page. Okay, so yes, especially the main one. Because the main thing we check is that the MGD is there.
You were like me, this is the other thing. So if a student they often, because they're filtering for the telescope location and it's the same month, they tend to put the same objects normally on the same night. Right? So you get lovely domain. But one of the blurry image, I think might end up processing the data from another student. So it will be either say if it is processed by two different students, want to.
If it was the way that the system was not
Which is
yeah. Well, it would be required
So this time when we use a dry run, I think.
Yes, yes.
If they have a problem, if not going to use a dry run, see.
I think it's
whether
better.
Is there? Yeah, it's sorry, I still cannot environments. But that was yes, but that was my suggestion. Now already I think now our before. If that's everything is okay, just then to click one button to copy it. Because yes, because for example,
If they want to know what they think, see if it's reasonable, like their students, they don't. It looks reasonable, okay, submit it, or it's way off.
Yeah,
They just feel bad about it.
in my case, why I suggested that is because sometimes I observe a new person, just to be sure before I do the trial. Yes, but then I'm just consuming your resources lines. Just unnecessarily, because most of the time.
But then telling us some clear solution. We don't want to have too many things like already from us. If we start that, then we would need to go find another department. Then we will have zero find departments. So we have to. I think it's better to ask.
Yeah, but if you are planning in people get bigger, because sure, but sometimes when I'm in a dentist, it just takes half an hour to process the portrait, and then first of all, it's then. That's your point. So it doesn't make sense because you're doing the flags.
Well, the idea is that you do it here on the board. Then this is only to check whether once you are sure about this, then you don't go to happen and use your algorithm, including the one. Then you don't need to, okay, this one is that's it.
Yeah, but it's actually a nice idea of yours. Just to, when you are, yes, just because when the result of the dry run is a success, you can access basically those calibration points. So why just not to add maybe not even interacting blocks? That would not be super complicated.
Oh, how they know who I can beat that one?
No, but okay, I upload the data as a driver. So the only thing to add is when I open the detail of that observation, just show me my points in the already existing image. That it would not be in the photometry tab, only in the detail. The plotting will not take.
Well, yeah, okay, you're right. Because now you can see the number. 0.1 value. Well, it's cheaper every month, so you can just have all the diagrams. So just having.
Just somewhere below, when because okay, I can.
Okay, so it's 1 p.m. basically, so we will stop for now and come back in an hour or 90 minutes. Wiesz, co mam teraz zrobić z tym? Stop robimy?
So somewhere here. Because this is
Let's now,
Can we leave everything here?
yeah, I think so. Let's now break for lunch. So we'll be back in an hour. I will keep YouTube running. Enjoy your lunch or whatever time zone you're at.
Yes.
next time. But when you don't count, that's what we do. And that is not understood, right? It's not okay yet.
Okay. We are about to resume, just bear with us.
Okay, so we are back. Are we? There's nobody here. Okay, because it's only for us. Okay.
Yes.
The YouTube is transmitting, yes?
I think it is. Yes.
Great.
Sorry, we are back now. I hope.
Yeah. Okay, so everybody's here or somebody's out still? Yeah, some people are coming back. Yeah. Sorry. Sure. No, i to przez nich. Okay, so guys, did you download the test data, or for those who have their own files? Now we will see how to upload your observations to BHTOM. So first you go to the object desired target that you want to upload data for. And in this case, it's Gaia 23 BAY, which is one of the objects I prepared test data for. Łukasz already showed you what the page for a single target looks like. So I will go to the web page now. Okay, so here are some of the tabs that you can work with. Probably the blue color is not the best one here. You can click on photometry, and then you will see the light curve. This is interactive plot, so you can always zoom in and go back to the previous view, as Łukasz showed you. And here are other tabs that you can use you can use your navigation. So like models, microlensing model, you can upload spectroscopy, you can see spectroscopy, you can see how and when to.
This is not visible.
Sorry?
This is only for admins. So
is it? Okay, sorry. So you cannot see some of this, but you can see managed data. Yes?
Yes.
Managed data. And here is for you, it is should be the most used tab apart from just looking at the results in photometry. And you can upload in default, you can upload 4 different data products. First one is the photometry already reduced by you. So this would be the case for Ben, for example. You can upload photometry in CSV format, which basically is a time series. So you can upload many points at the same time, which is not recommended because it will not be standardized properly. And if you really have to do it, but we just recommend you to upload images, raw images. You can upload spectroscopy. So this should be the ASCII file, I guess. Yeah. ASCII file with wavelength flags and some kind of error. Yeah, and the most prominent data product that we want you to use is FITS file. When you click on it, then some options will appear. First one is the choice button, because this is always active because you can choose other things. The choice button for the file. Then is your observer's name. You can always upload as someone else. If it is your student and you don't want them to have a separate account, you can upload as them. But in default, you will upload as yourself. Then you choose one of the observatories which were added to your private list. In my case, these are all observatories because all of them are added to my private list. Let's say you choose observatory, then you choose the camera. If the camera is only one, if there's only one camera, it is being filled automatically, of course. And then there is something that is, I think, the most important thing here is the force filter field. You can force the filter for calibration. So if your observations, let's say, are in V filter, then you can force the filter and all the observations will be calibrated, should be calibrated to V filter. But if your observations are healthy, if they were done in a standard manner, if the calibration for bias, flags, darks were okay, it is okay to leave the Gaia SP, and then the standardization will be automatic and should be standardized to the right band. Of course, some the instruments do not use optical filters, like for example Remir from REM telescope, which is in J, A, and K bands. For this, standardization would have to be done with 2 mass bands, which probably is the most prominent sky survey in infrared. So if you have an infrared telescope, infrared instrument, then you would really have to use the force filter field. In default, we use Gaia SP, which is perfect for optical bands. Of course, for each observation, you can provide a comment. In any case, you're not sure about the calibration, or maybe it's your first observations of the targets. It's always good to put some kind of comment. People are not using it, but we would really appreciate if it was done from time to time at least. Okay, now I will stop sharing my screen and ask Krzysztof, Chris here, to share his, and he will show you how to upload a single file. Yes. Yes, all the files, all the photometry images have to be calibrated for bias correction, dark correction, and flat field correction. So these are not raw images. It's raw in a sense that they have not been processed, they have not been reduced, but they have been calibrated by you. Of course, we don't want to get involved in calibration for biases, darks, and flats, because it would be a huge task. And each telescope, each instrument has its own proprietary individual pipeline that takes into account effects that we cannot predict, like pre-scans, overscans, like some kind of strange vignetting, some kind of pixel masks, and so on and so on. Some of our telescopes, which are already in BHTOM, have really complicated procedures just for calibration. I guess maybe the REM is a good example, which provides us with data in infrared, but basically one observation is some kind of average or but median or average picture of 5 exposures. So we are not doing this. We just receive already prepared files and we upload them to our pipeline. So your data has to be corrected for instrumental effects, basically. Okay? Yes, and many other. If you have some other effects which should be taken into account, please do it prior to. At least flat fielding should be done, because darks and bias and flat fielding, because darks sometimes can be omitted, because if the temperature is low enough, there is no dark effect. So yeah. Okay. So after you add your your chosen observatory to your list, you can start uploading data. And now Krzysztof will show how to do it. He downloaded the files prepared by me, by him actually. And now what Chris did, he chose a single file. He chose a type of file he's uploading, so fits file. Now he also checked the box which says dry run. It means that it's just in test mode. It is normal reduction, but the photometric observation will not be stored in database. So it will go through all the process of doing the DAO-FOT, sextractor, astrometry, photometry, and so on and so on. But the point will not be stored, and it is a great practice for the first upload for that particular object. So if you start uploading data for Gaia 23 Bay from your telescope, it's always best to do a single file dry run. Just check if everything is okay. Okay? Of course, it is for the first time should be done. Then you can skip it because you already know how the system works. So Chris is now going to select the observatory which data is from. So in this case, it is ASB 1.4 meter Milankovitch telescope. And check, could you please show the list again of the observatories? Yeah. So this contains only the observatories which are added to Chris's private list. Okay, so in your case, it can be your observatory and other observatories which you have data for. Or maybe you have had proposal in LCO, and here are LCOs already added, and you can reduce your data with our pipeline. Okay, so now Chris is selecting observatory, which is right. Camera is automatically selected because there is only one. And now upload. And this is that easy. You don't have to do anything else. Everything else is being done automatically, and you will see the subsequent steps in a second. Okay. I hope your internet is working fine now for everybody. Okay.
Sorry, a question.
Yes.
At the moment, we have at least 3 or 4 new observatories, and they need to be approved.
We approved some of them.
Yeah, but
So
still we have a pilot, for example.
Yes.
Sicily and planetary missions.
Okay, so I will do it, guys. Please try to do the exercise using the test data, and after this session, when we go to next things, I will activate your observatories. So in the last session, you could try upload your own data, okay? Because now it's not possible for me to do these things simultaneously, and you can see in the top of the page. That is a green monitor here, successfully uploaded. And now when you go to data and go out downstairs to download the page, you will see, yeah, you can see your file uploaded and its status in progress. Okay? You are the owner. The photometry is empty because it's still being reduced. And you can click on details. As long as it's not reduced, when the moment it is reduced and it's done, all these fields will be filled in. So the proper modified Julian date, all the exposure times, the calibration filter that was used, everything will be here. And there were some questions on the Gaia Science Alert workshop. I think it was maybe from you, or from someone else who wanted to have feedback of the entire process. So something is happening in the background. You are waiting for your results and you don't know what's happening. So we added a other tab, which is called CC default. So this is the reduction software. And here you can see this is the part that is already coded. And here will be when the CC default Docker is ready, here will be displayed all the progress messages and feedback for you. So if something is broken, if there is no astrometry, you will have the message clouds, you have no astrometry, movement of stars, your star is not visible in the field of view, too short exposure, and so on and so on, just to kind of provide communication between the user and us. Because for now, sometimes I get emails from you and you are asking what was the error, and I understand perfectly that you want to have some feedback to make those observations better, to prolong the exposure times, and so on and so on. So this will be done automatically. And now when Chris refreshes, yeah, exactly, and this was finished. So now you can see two things. First, there is a photometry file, which is a DAT file. It is a reduction result. So basically, this is the list of stars which were found in the field of view, and for each there is a magnitude, there is a flux error or magnitude error, and there is a position in two coordinate systems, the XY coordinate system in the image, and in alpha delta equatorial coordinate system.
It's in the extractor format. So
yes, and this is the extractor format.
Again for uploading only this data file.
Exactly. So if you want to upload your reduced photometry, this is the format that your photometry should be in.
So
Okay.
you do it in dry run, but then you don't need to upload the feeds again. But
Exactly.
Just take the style, it will be very quick and easy.
And in the right panel, you have a picture of standardization process. So each of these little plots is instrumental magnitude against standard magnitude in this field of view. And each of these single plots contains different band. So in the top we have ultraviolet slope, then we have G, R, I, then we have Johnson-Cousin field, called Johnson-Cousin's Cron filters or Bessel filters. And one of these fits the best. The residual of the fit is the least. So this is the, this is the one, Johnson D. And you can see that there is a 0 point for the standardization. There is a sigma, so fit scatter, yes. And there is number of stars used for the process, and also something that we call little f, and this fraction of stars that were that was rejected from the process, because there were outliers from sometimes it happens that only half of a star is visible, or maybe a star is saturated. No, the variable will not give you this.
But it will be outliers.
The variables will be outliers because you observe them at different phases.
The variable stars.
Yes, that's true. If you have a large variability, yes, it will give you outliers, sure. So this is simple information for you. And if Chris, could you show the left table, the table on the left, and here are all the information you have in the plots. And exposure time is not here because it's not been read. It will be read while we implement the feedback for the user after the dockerization of the reduction software. But all the other things are here, like ultrarefraction, number of stars, the scatter, the 0 point, the final magnitude. So this magnitude that is presented here is the standard magnitude. So your star, Gaia 23b, observed with 1.4 meter Milankovitch telescope in B filter, at this particular moment it was 15.6 in B magnitude. So this is the measurement, standard measurement, and this one is displayed in the light curve. Okay?
The error bar is 0.00, but this is just this display. We store it with more precision.
Yeah, this means that the error bar is less than 100th of a magnitude, which is not true, but 100th of this particular unit. Yeah, and this error bar consists of two independent parts. One is the instrumental error, which comes from the reduction, and the other one is the standardization error. And together they make this displayed error here. So if the standardization is so great as here, you can see that the plot is perfectly fit, and the other ones are not. But you can see the upper one, the G, the Sloan G also fits quite nicely because the error is very low there as well, but it's still much bigger than the B. Okay, so that's why we don't need to know what bands are your images taken. We don't need to know that. We just want to have the list of them in order to plan future campaigns, to still to be able to say what was the original band of observation. Okay, somebody called to check in. Some additional questions, I guess somebody will call. Okay, yeah, and the scatter of the entire process is 0.026 magnitude. And this one should be displayed here because this is the scatter from the standardization. So Łukasz, here's the back, as you can see it.
Why?
Because yeah, it works. So this is not right. This is the scatter from standardization. There is an intrinsic scatter from instrumental photometry, and the sum of the squares, root sum of the squares should be shown here, and this is.
I think here we just show the original instrumental.
Yes, this is original.
But then what we store is
we store both.
Okay,
we store both.
I make a note.
Issue. We can make an issue. Okay, so this is how you upload. If you did it already, you can see exactly the same picture, or if you did it for another target, you can see different picture, but also calculations should be finished because we selected only the targets which give you results quickly. So short calculations. Okay, can we do another one? Okay, so now we will do the same, maybe for another telescope and for another target, just to show you that it actually works. Oh, yeah. Okay, we will get back to it. Mhm. Let's try for some other, maybe for the supernova. Okay, which should be ready in 10 seconds, so maybe yes. So this one is a supernova to SN2024 GY from Road Observatory in Chile, so 40-centimeter telescope. And now we can also upload it. Now we can also upload it via the web interface. Yes. Yes. Sure. So Chris has to add the road to his list. Yes. First you have to go to the observatories, add your observatory to the list, and now we can upload. Please, you are in the wrong target page.
Mm-hmm. What will happen then?
Yeah, you can do it. You can do it. Yeah, just do it. So now what Chris is doing, he selected a right file in the wrong target. Yes? No, it's not. You have to change to the photometry and to the feeds, and it will disappear. Yeah? Oh, yeah. Okay, now you go to the road telescope and upload. And so now this is the right file in the wrong target page, and it will give us an error because we are looking at the Gaia, we are looking at the supernova S2024 GY. We are uploading it in the Gaia 23 bay, which is completely different field of view. So the astrometry will not solve because the tolerance there is, let's say, 5 angular degrees. So we are looking to solve the field somewhere in this sky region. We are looking in the completely different place, so it will not work. And after a minute or two of trying and trying, we will get an error. Yes.
The question about the uploading feed files. Can we upload compressed zip files?
The processing software has capability to process feed files, FTS files, FTT files, feeds GZ files, feeds FZ files, and zipped files. We are only waiting for the implementation by the BHTOM. So in principle, yes, but for now you will get an error, but not from the processing software itself, not from BHTOM.
The answer is no.
The answer is by me is yes.
No.
Yes.
For the user is no.
Yeah.
For the user is
don't confuse
unpack your data. Always
people.
unpack your data. Yes. So now what Chris did, he uploaded the file and the astrometry is running now and it's going to run for a long time trying to solve the field because it's in the wrong place. Yes. Yeah.
Something you had hundreds of stars.
Yes.
Right? And also I had 1,000 stars.
Yes.
It's fine. I can see the straight line, so everything goes right. But our targets of the various parts,
Yeah.
which you have only these stars or which you can make a standardization, then you could pick the wrong.
Yeah, this is a great question. Maybe Chris, if you open in the other card and go to SN2024 and upload this file, this would show you this because in this supernova field there isn't a lot of stars, and this particular case, it's not that bad because we do the standardization, but there are some targets when you have 4, 5, 6, 8 stars, it's not enough to do the standardization. It would have to be perfect just to trust it. So in such case, we cannot really observe. We can do the observation, we do the reduction, but standardization is not possible. And if you cannot standardize such observations, the light curve will be useless. But it will be shifted between different observatories.
Yeah. Well, that's why it's advantageous to have wide field of view. Right?
Yes, and that's why we need those characteristics like pixel scale, field of view, because now we can say, now there is a very interesting event going on. It's T Corona Borealis, which is a recurrent nova, and it's going to explode sometime this or next year. And this is a really sparse field of view. So we ask you to observe T Corona Borealis, but if your field of view is like 6 by 6 arc minutes, you will have two stacks. So it's not possible to calibrate. So you have to have like half a degree to really extract many sources in order to be able to calibrate for the standardized process.
Yes, this is something what you should kind of keep in mind when you design your observations. If you set targets and you know that your field of view is small and you see this field is very, very sparse, keep that in mind. You can have a quick look at the finding chart and say, okay, there is it's probably a bright target, I could observe it, but then there is not enough stars for my telescope.
Because it was the filter without the standardization.
Yeah, you can force filter, but forcing the filter does not mean that it's always going to be standardized, because you still have to have the equation which is solved. If it's not standardized, if you have 2 points, you will not feed a line. If you have, let's say, 10 of them, the error will be 10 times bigger than the scattering of the variability, and the likelihood will be just useless. We have such an example.
Yeah, but in principle, you can do that. But it says it will be better than getting completely wrong.
Yes.
You can force filter.
Exactly.
If you know.
Yes.
Yeah, it will have less accuracy, but still it will be incorrect filter.
Is it possible to delete the data point that you uploaded by mistake, or you find that there's a problem?
For now, no. The answer for we can.
So at the moment, it's not allowed, not given to users because it's a bit complex.
But if you have a file for which you already uploaded and you have for which you already have the point, and you spotted that something is wrong with this, and you corrected the file, you can upload it again, and the observation, the system will tell you that observation with that modified Julian date already exists. So this is the bug. You cannot do this. So we have to delete it and you have to upload it again. But in principle, in the future, we want you to have the possibility to delete your own observations. Not only for the corrections, but if you upload something you don't want to share, you will be able to just get rid of it.
Or you see that you have just too noisy.
Yeah, exactly. We have a lot of data points which have this limit triangle, which basically means that the picture was perfectly healthy, the reduction was okay, but this particular study that you want to observe is not there because the exposure time was too low, and it calculated the 0 point for the image, the scatter of the process, but there is nothing to be moved. There is no magnitude for the star. That's why you have this limit. So for such observations, we have the special triangle displayed in the plot, but maybe it would be nice for people if they get limits to delete the points. So the plot would be nice in the first place.
Yeah, how do you compute the upper limit for this case?
We don't need upper limit.
When there is no detection.
When there is no detection.
Yeah, but again, upper limit is a generic definition.
So,
what is your definition?
Yeah, so the upper limit is, if I remember correctly, but I need to check, is because we derive the 0 point.
Yeah.
Right?
Oh, yeah.
So we know how to translate all the stars in the field to real magnitudes, and we see what's the faintest.
Yeah, okay, but you mean you do a sort of forced photometry and use 3 sigma, 5 sigma RMS, 10 sigma RMS. What is your estimate?
Well,
so must be the definition.
Well, this is the faintest star we were able to detect in that sense.
Again.
And then how
No,
RMS?
There is nothing. If your star has a measurement in our astrometry, it will be standardized. Even if the scatter is, let's say, 2 sigma, 5 sigma.
If it was detected by the
PSF method, not only by the PSF, maybe in the aperture from the PSF, then it is displayed. Even if the scatter is large, the limit means that it's not visible. So the picture is fine, but your target is not there.
Well, it's beyond the
or it's beyond
so
the detection. Exactly. If you have the plot of the faintest stars.
I understand if you have a field where you can compute this and you use a standard 5 sigma, let's say 5 sigma, okay, whatever.
I'm not using any sigma.
No, but you must use an approach that is physics, not just Well, you must, what? You're putting
No,
physics
I
upper
will-
limit. A magnitude is transformations of physical parameters. So
Oh, yeah,
either you have it or you don't have it.
Purely
You can
mathematical.
say, we don't know, you can put a question mark, but don't you put an upper limit. If you put an upper limit, you have some numbers behind. Otherwise, you don't put anything. So you can put upper. You just don't put that detection, nothing. It's like if that observation was never done. These are long term. Either you don't put that observation, or if you put an upper limit, you have to put the definition of that.
You are telling the part that it shouldn't be continued.
Exactly. So you put.
Yes.
Stop. No triangle, no, it doesn't exist.
Let us,
Stop.
let us make.
Unless you can put some physical parameters behind that triangle. Otherwise.
Okay, Krzysztof.
No.
And I make a note on this to explain it there, but I would still keep it because the limit is very useful.
Of course, it would be very,
Yes.
of course, for a lot of,
Okay, so getting back to processing data, we can see what Krzysztof done here. So you got an error for which for Gaia 23 BAY. Can you show the detail?
It's not guys, it's for now.
So you downloaded the data which was calibrated right, and then you didn't get why?
Why?
Okay, so now you have error live. 1 second, I check what's wrong. Ah. Okay, I think I know.
So that means that this, the magnitude we are reporting is not the detection, it's a non-detection. So as we just discussed, this is the faintest star we detected on your image, right? So normally for all the analysis, you want to get rid of these -1 error bars, unless you want to use it, because it might be useful for some cases, so science cases.
We call it limit.
You call it a limit, but this is this is a non-detection. Yeah.
I just need the coordinates of the master and the limit, and then the limit. The prediction or the
Who does get error? Yes, I will come back to you. Krzyk, you should be sharing your screen.
I'm sharing.
You are sharing your screen in Zoom, yes? Because I am okay. I am
connected, but it's his screen.
Yeah. Okay. So let me check the errors. I don't want to be showing the pages underlying the process.
Krzysiek, proszę się podłączyć.
Okej, nie podłączę się.
Teraz jak to?
Lipa. No, nic się nie spieprzyło. Krzysiek wybrał złą kamerę. To musisz dodać sobie kamerę.
Aha, czyli Rodzie wziął złą kamerę.
Tak? Tak.
Okay.
So,
powinno się spieprzy.
exactly. I'm checking on the errors you got, guys. 1 second. So, okay. Staszek is now loading something. And Luciano got an error for Ogle target. This one?
Yeah.
Okay. Krzysiek got an error, and we have TCR, which is in progress. Where? Where is Pablo? Ah, Skinakas, okay. Ah, yes, okay. Loyana 152. Oh, this one wasn't used for like a decade, yes. In our no, for here, for at least 4 years. Okay, I will now. Okay, I need another computer, so I will use
So you want to
Chris's.
go now and fix the errors, or?
Yeah, I want to look what are the errors come from, yeah. Maybe okay, maybe let's do this. Maybe let's continue, and then
Exactly.
during the coffee break, I will check on the all the possible errors and give you feedback, because that's what we have what we here for. Okay, so now at least you know how to upload a file via the web interface, yes? So this is good if you have 5 images per month, maybe, or you observe some long variable quasars. It's easy enough to do this. But if you have more data and more telescopes and more observations per night, it is completely unusable, because you would have to spend a lot of time each day to use it. And there is also something that I didn't tell you about, but it's written here. You can upload up to 5 files at once. So even if you have 50, you have to do this 10 times. It's not really usable. It's not nice for you to nice to operate with. Okay, but fortunately, you should stop.
Files, but can be different filters.
Yeah, for filters, as long as it's one object within one observatory, doesn't matter. Filters are detected automatically, yes, with the standardization process. Okay, so now let's look at how to use the second as important part of our portal, which API. Of course, every modern service should have some kind of scripting access. First, you should go to BHTOM documentation. Actually, the first thing you should do before you start uploading your data with API, before you start getting any information from our side with the API, you should go to the documentation. If you put BHTOM2 documentation in Google, you will find it. But of course, in principle, you can go to BHTOM and click on About. And in About, there is a link to go to this page. And we have a pretty decent documentation. I'm not saying it's the best, but it is there. And it's enough for you to be able to use it fluently within some margin of error.
I'll correct this. So the main documentation is still in progress, but we have some description on the data policy and then the archives.
Yeah.
But then for the API, we have a very extensive documentation, which is much better. We thought to invest time in documenting API instead of all this stuff, which is still evolving, and it's better to actually have a workshop like this instead of writing a complete documentation and then have to rewrite it. It takes time.
That's right. Yeah. So if you go there, then you can. This is just the documentation, but you can also go to documentation API, which shows you how to use the API properly, what Łukasz said. And the first step is to use a script which is in documentation scripts, which you can go into. And there's a bunch of examples for you to choose from, starting from getting your target list from BHTOM to uploading your data. But first, you have to start with getting your token. You have to have an access to our service. That is the way to do it is to get a token. So there is a script get token with shell, and it will work in Windows, it will work in Mac, it will work in any Linux. And if you launch it, and we can also use get token interactive, when you will be asked for your login, for your password, and after executing it, you will be given a token. This token is for you, for your individual use. This will get you access to all of the API capabilities, but you have to do it first. You cannot get it from the website. You can get it from us. If you ask me what's my token, I can send it to you, but I would like to not to do it because it's not very safe to send the password. You can get it yourself by launching the script. So first step to using our uploading service will be to get your token. So now everybody.
Permanent?
It is permanent. It's once you set up your account in BHTOM, a token is generated, and it is for the eternal use. Of course, it can be changed if you wish to, but only by us. It is your token, like the token to get to YouTube or Google services. This is kind of this authentication method, yes, to have this token. So everybody who want to use the API to upload data via terminal should now download the get token interactive.sh script, use it, and get the token on the screen, because it will be displayed once you enter your login and your password. Okay, I will get around and help.
The token has the advantage if you can share it with some people in class. You don't have to give them your password or anything, but so they cannot log in on their behalf to BHTOM, but they can use API on your behalf. So the script is same as code. Which one is it? And we talk them, you can delete things as well. We can
Credited.
That's why we did the interactive version.
So it requires the basic knowledge of, I think, a shell script. Okay, so if you don't, if you want to do it quickly, just download the interactive, get token interactive. It means asking for your login, for your password, and display token in the screen. And this token should be written somewhere saved somewhere in your computer for the future use. Okay, so this is a completely safe method for you to access our API. Of course. Działa, działa. Co? Ja w tym jak to zrobić. No właśnie, kursorem. Okay. Okay, does everybody have a token?
Yeah, please pay attention on the space in the names of the target. They are problematic for the reduction in pipeline. So it's better to avoid spaces in the name. Put the underscore.
I will show. Okay. Okay, so maybe it's best to just show it, how to do it for everybody. Okay, so here you go to the documentation scripts. If you click on the Get Token Interactive, you have a choice to download it with the arrow here. And after downloading the script, you just run it. If you just type bash and now the name of the script, and it should be okay. You are in the bash. Exactly. Now that's for you. Okay.
Then the one that thing
Exactly. Your login and your BHTOM file.
Okay.
Yes.
What is the does it mean?
There is no. If there is under. I think 7 is for 7 is for.
I think there is
no, there isn't. If you have over 10 stars, good stars, there is a dynamic
5 PSF, 10 PSF. 7, under 7, there is no way to do the PSF. Between 7 and 10, there is a constant PSF.
So this the fact that
No,
I got involved in the except for you.
that may be the case, yes.
Another example.
I will check it out, okay? Because we have some kind of. It's Pablo, it was in you, yes?
Yeah.
So guys, please get your token and we will continue. I will check the Pablo file. It was you, so I guess it was this one.
Most people have it, so you can move on.
No, there is a different reason. So please, can you listen, Pablo? What was your observation? Okay, we don't have you in our list. So it wasn't when you registered, you didn't put you in the list of filters.
Maybe yes.
And now adding this, and you can upload it again, just in the single file, and you will see that we should give you a success. Sorry, I will.
Yeah.
Yeah, it's simple bash. Doesn't it work?
Yeah.
Wiecie może o takich przypadkach, gdzie generujesz token na Windowsie, bo tak ma Paolo. Generuje token na Windowsie i kiedy chce wygenerować, znika mu cały termin. To jeszcze na Windowsowy może być.
Okay, so let's continue. Okay, so now there is a second script which I would like to show you. It's called send feeds to BHTOM. And this is a script. This is a script written based on our API. You can do it by yourself. You can use our API, use the commands that are available in the API, and build your own script. But this script was built just for you, that you don't have to do it. Okay, if you download the script, it's in pure Python, so you don't need anything else. And this one should work in Windows as long as you have Python. But
as long as you have
which you don't have, you can't get because you don't have Bash and because you have Windows. Well, what can I do? I didn't invent Windows.
If the token is in the cookies, you can retrieve it from your browser. Is it possible as a cookie?
I don't think it's possible.
Okay.
But I'm not sure because I'm not the guy responsible for the front end. So please now everybody downloads the script, and I will show you how to upload a single file. Okay. Za ile mamy przerwę kawową?
Za 8 minut.
Okej, so to żeby wszyscy mieli skrypt przygotowany.
Żeby wysłali oficjalnie dzisiaj. Mam podczas przerwy sprawdzić, co przeszło.
A kiedy kawę wypijesz? A czemu jest to na nim przynosi się? Jest moją parownicą. O. Okay, guys.
So we have 10 minutes before the coffee break. So everybody please download the script and I will show you how to understand what's in the script. So if you download it, you will get such a message when you run the script without any arguments. So this is the message in the upper message. Send feeds to BHTOM and possible arguments to be used. Just run it with Python 3 and name of the script. So the first argument is the name of the directory where you keep your files. So the files that you want to upload should be kept in a single directory. Okay. The second is your token. -t is your token. So you can you can create your own script based on this script and always have the token in the body of the script. So you don't have to give it every time.
Hard-coded.
Hard-coded, exactly. You can hard-code it into your own script and it's ready. The third argument is object, name of the object as seen in BHTOM. So if you have observations for Gaia23 BAY, it's -O Gaia23 BAY. If you make a mistake here, you will get an error. So fourth argument is observatory. And now you specify which observatory your files are from. And here is the main problem that we encountered so far, that name of the observatories are not really easy to construct, because sometimes it's Piwnica Observatory, 90-centimeter telescope, Moravian camera. So instead of this, we create something that's called O names, so the short names for each observatory. And you can see O name for your observatory in BHTOM. You just go to observatory, and here in your list of favorite observatories, you have O names. So for example, for this ASV 1.4 meter telescope, is just ASV 1.4 _ Andor.
This is your name. This is your name. Of the telescope.
This is everybody's name of this telescope. So if
visible for everyone.
This is the same for everyone. As this is the same for everyone, this one. So this is the same for everyone. Just to keep it much shorter.
This is like robot friendly.
This is robot friendly, exactly.
And script friendly.
And now if you want us to change or already existing O name of your telescope to something else, just let us know. We are really flexible on that matter, as long as it's not too many characters and it's easily remembered. Not every, as you can see, not.
You should be careful with that when more people are using the same telescope, right?
Exactly. That's
because
why.
Then, my script will
exactly. That's why it's
yeah.
Displayed here for you to always be able to check. But once we put something there, we don't change.
Try not to change.
Yes, we did it in maybe with some telescopes, but not for a long time. Okay. Yes. So this is the O name, and the last argument there, it's a filter, which you can still force, but this is only an optional argument. This is the same forcing filter as in the web page, but you just don't do it if you think that it can be automatically standardized by our pipeline. Just basically don't use it if you don't have to. For REM telescope, use it because we know that it cannot be Gaia synthetic photometry. It has to be TUMAS, right? For Remir instrument, yes. And the last one is this dry run.
What is the proper for filter name? Where should you take the names of filters?
From the web page.
From the web page.
Yes.
You should use the same name.
If you want to force a filter, they should be in the same filters as they are displayed in the list in the web page. So don't make things up. Just take the one from the web page. Of course, in principle, here in the let me show you which one is many of them. Okay, let me show you one of the objects, microlensing event. So here, when we go to manage data, to upload data, this is this filter. Yes?
Yeah.
Yes.
This is this filter.
This is the convention.
Yeah, the auto means that we will choose from all of these filters automatically.
No, you don't specify.
If or no, exactly. But yeah, this one means that we will choose any Gaia synthetic photometry filter, which is for most cases is the best. For most cases, this is the right choice. We have only four infrared telescopes, infrared instruments right now in BHTOM, and for them we have to do things differently. Yes, Aaron.
So if I will not specify that, it will be Gaia SPNE or
It will be Gaia SPN, yes, not auto. Auto, we need that it will also choose from TUMAS. And in the past, we had these problems that our light curves were like very noisy because we had such surveys as APAS, BFAS, IFAS, TUMAS, and all of them were a little bit different. And now Gaia SP is really standardized everything.
Yeah,
that's why
I found
exactly
works much better.
Yeah, and they even produced some of the some points for Hubble filters, just to be able to go back in the future to the past and to have the standardized observation there as well. Okay, so this is the proper way to run your script. The dry run flag means that the dry run box will be checked. So it will be processed, but no point will be stored in the database. So first time you upload something, just upload a single file via web interface, just to see how it works. Do the dry run. Next time you upload something for another object, use our script or use our API with your token, and also try to do a dry run, because can see the results in the web page. You can go through them, but just the first file, just to be sure that it's a success. Like Ricardo had here, that the U filter wasn't added to the full list of to Pablo had here, for the full list of filters, yes, and we had an error just for one filter, and now we have feedback that we have to add this filter to the list of all filters. So it is a good just to contact us if you see error, but in general, we have a special page seen only for the administrators of BHTOM, in which we have all errors for all processed files. And every day we go through this and correct our mapping system, correct some procedures, and process again this file. So if you have an error, it doesn't mean that it's going to be there forever. We will correct it for you. But now when we don't process, let's say 1,000 files a month, but 10,000, it became so much time consuming that we have to be able to do it automatically. So your feedback is very needed to us, but we are going to kind of do everything automatically right now. Okay, now we have the break, and after the break,
Show the command line at the end of the dry run option. It's not visible. See at the top?
sorry, this you mean this? Yes. So now we have a coffee break, and after coffee break, you will try to upload files via the terminal interface, and we will in the real time try to work out your problems. Yes, they will. Of course.
Yes.
And then be distinguished.
Yes. So then has its own file. Yeah.
It will work, like the process will work, but the point will be like
but for as an example for registration, for that you are not doing in the meantime so it's actually to understand it, right? The keywords.
Okay, I will now start. Małe makijato z tymi Espresso, panie, espresso. Ale dobrze, tak to było dobre, akurat z tego na koniec dało się tak powiedzieć. A zaraz a już mam, czekaj, już mam. Wystarczy. Ja to przeliczę. Zostaną tylko te paski, a gwiazd nie będzie.
No i te paski to jest jakiś tam odblask czegoś, to jeszcze na teleskopie nie ma szmaty. Dlatego ja tylko z nich to a szmat nie wiecie, czy prawda?
Tak, to łysą.
Nie, tą szmatę to inny będzie też.
Jasne, bo z tego
Mnóstwo się do człowieku podjął zaprosili, a powiedziała, że to jest świetnie. Dlatego się pytają, zmniejszali apertury szmatami, żeby się nie wieły, żeby to widać obserwacji. Myślę, że to dziadowskie oprogramowanie z tego, że pozwala wyzerować słońce. Myślałem, że będzie tak naprawdę, że trzeba wiesz, to jest para albo coś. No, czy to jest jako które gwiazd, to jak prowadzą musisz prowadzić tam miejsce obserwatorów, nie wyjdzie, to będzie pojawić. Bo zdjęcie za chwilę, czy tak się pojawi. Ale on zaglądał w teleskop. W sensie to była projekcja, która tak, ale on zaglądał tutaj mu przejechałem. Jak przejechał przez to zabolało, centralnie nie było teleskop. Przecież to był plastik, ktoś tak przyjechał, sama wyłączę i zamykam operator. Dlatego właśnie
Tak, to teraz to robimy. Już większość jest abstraktowane.
Sprawdzacie tak?
Ja tam będę widał czas i na taki gotowy. A co było z tymi filtrami?
Nie ma problemu. Tak, tak, oczywiście. Jasne.
Bo u nas lepiej wychodzi, można kupić na lepszy, dłuższy czas, takie filmy.
Macie, my wtedy mieli światło w tym, nie? Tego, macie jakąś linię, wybieracie. Znaczy wiesz, to się pewnie nie ustandaryzuje dobrze.
No, chyba tak.
Ale to nie są GASP, nie ma czegoś takiego. Tego nie przetransformujesz do dobrego systemu. Woskopasmowy.
Takie do własnych fotografii. No to wtedy się do czegoś tam dopisuje.
O, dobra, co to było tutaj? Krzychu, dodałeś to U? Dlaczego? No. Okej. Jeszcze jakieś jedno jest. Pirat, okej. Do pirata jest przykładowo ops-info zrobione w tych plikach, które ci dałem. Tam powinno być ops-info copy, w takim folderze pirat. Powinien być przygotowany już. No dobra.
Nie, to było... Właściwie bardzo... Jest a ten drugi jeszcze to powiem,
Can I say something?
Yes, sure, of course.
By the way, if we are not within the Conda environment, then we also need to install the request and etc. other libraries.
Ah, yeah, they are listed.
Windows, yeah.
They are listed in the dependencies. Yes,
Yeah,
yes.
yeah.
Thank you for that. Yeah. Ah, okay. Loiano. Okay, so we are back. Guys, so let me show you some of the progress we've made in this during this coffee break. So the Pirate observatory is working already. So Pirate is working, and Pirate provided us with a good, very nice fits. Here, I think this is the yes. This is Pirate.
Not bad.
Not bad, but some of the errors that we had. This is the error. So no stars. So no, it's object, but it's Klaus. The other one is from Adiaman. I don't remember who uploaded it. So it's a valid observation, but not really a lot of stars to do the proper astrometry. So this kind of observations can be processed if there is some kind of astrometry already provided from the telescope. This case, there is no astrometry. We are not able to solve this sufficiently. And I think there was one other, yeah. So these are two for the same object. So no stars in there. There is something here, I guess. That's it. I'm not sure if it's on the camera or if this is a real object. Maybe that's the moon, yeah. So most of the errors that we get are from the bad images. So let us wrap up here the section when we go through errors, because we will have to work it out still later. And now I will show you how to upload it through the script. So if you are in the dedicated folder, I downloaded some data here. So you can see these 4 files. Gaia 23 Bay have been downloaded from the test files catalog, and the README downloaded along with them. So README contains information about the source of the files. ESV 1.4 Andor is the prefix, so it's this O name that you saw. Object is the object name, and observatory is the full observatory name that this data comes from. So now the easiest way to upload this data is just to make a folder. I call it T. It's already there, so that's why it exists. And I copy one of the files there. Let's say I copy this file to the test catalog, T catalog, and now I use the command that I had before. So I put all of the arguments in the command line, and I get this message. So there is my authorization. This is like the test authorization, not for my user. There is object name, observatory, matching filter. As you can see, I didn't specify, so it says it's any, and I selected dry run. The bigger is the file, the longer it takes. And I have that one file was found, and it's been successful.
Your address for BHTOM is incorrect. BHTOM Master Labs.
Yeah, great for pointing that out.
To change it to BHTOM.spec.
Maybe yes. So okay, let me do another thing. I will change the object name, and I will go for something that doesn't exist. If it doesn't exist, yes, I will quickly. Okay, I will have to do that CP again. Okay, if there is no files in the specified folder, you will get an error. Program is terminating. If you do this, the file will try to be uploaded, and now it's uploading of the file, but in a second, if it works, we should get an error, because there is not such a object in BHTOM. So if the object doesn't exist in BHTOM and you try to upload it to this object, you will simply get an error. So this is a simple script to upload your files to BHTOM. So now it would be great for you, for every one of you, because we will need the token later, just to try to upload a single file. Just download it, make a folder which you can call, let's say, test directory. Copy a single file there. Yes. Yeah, if you run Windows, I'm not, I don't know what to tell you. Yeah, and now again, sorry, and now again we can use this, just changing the name of the directory our files are in. Yes, and we will get the same. So this is that easy. Of course, you don't have to. Oh, sorry, I didn't change the object name to bay again. Of course, you don't have to use my script. You can use the routines that are already present in the API and hard code everything you want. So if you want, you can hard code your observatory, this own name. You can hard code your token. You can hard code your matching filter if you are using infrared instrument, and so on and so on. So you can adjust it for your personal use. Some of our users did it, like for example, Michał Zejmo, and he has his own script uploading for his own telescopes every day, or almost every day. So that is very easy, and I would like to see that every one of you uploads a single file, maybe one of these files, so we get some kind of progress. Okay, so if you are running Windows, you cannot use your token, and there is a working script in Slack. Yes. Just for Windows users. So, yes, yeah, I think it's important process that being moved to your success. Yes. I will get because great. Okay. So the Windows script for properly works. Thank you very much. Thank you. Yes.
First of all, you don't have a prototype, I like to example would be zero. But if you don't need space, what's just without you will give an error. So it's just created by the yes. First one is wrong. Yeah, but
This is the API examples. Okay, examples in the API. Examples in the API contain errors.
Yeah,
Mistakes.
because we need to have that in our page.
So you are showing a fragments of code that contain mistakes.
And they cannot be wrong.
And they cannot what?
MJD, that's what MJD. He was mandatory MJD.
No, it shouldn't be like that.
Which one? Which one?
Okay, anyone?
No, yeah, it's now it's in your list. You will see that.
So, and apart from the observed dynamic that is based, another project shall be known, now
Excellent. Yeah.
Yeah, but again, I don't want exactly, so I should not put, actually, this is really normal. But I think what it is, because it says another time, it may not be like. But if it's not, it's just not providing it. So even though it's yeah, it's the new. Yeah.
It's reading from the arguments, it's not reading from
Observing these also like this. Oops. Something like
Now I can only see this.
okay, so
or you can just, yeah, or you just comment this line and it will not ask for the comment by the whole, you want, you can explain.
So everybody, if you upload your observations and everything is fine, and you get an error, that's why, because you didn't add this observatory to your list.
Oh, yeah.
In order for the script to work, it still has to be in your list of observatories. So you have to go to BHTOM, add this observatory to your list, private list, and then upload the file. And now it should be a success. Mówiłem, to jest mój, to jest najmocniej. Mówiłem. Ale tak nie zapowiedziałeś go.
No jest nieprzyjemne.
Jest, true.
Yeah, yeah.
Maybe about item 3. Item 3. I'm not saying, are you like that? No, it's not. This is not. Okay. I'm going to send you an email to fix that.
When you're typing the data, when you're typing password, what is impact? You can put the email here, so you will not need to type it. you can go after it.
But with the content, you can set up your own way.
No, okay. But inside just
So
make
give
it.
examples. Yeah, there, and give examples. And you can call it in and send it to us, and we will be.
Yeah, but probably even better if you so you put BHTOM, whatever, for example, camera, sorry, telescope camera, so BHTOM underscore telescope underscore cameras. And this is your config. And we need the various quality. So they can use that config to set up as many telescope cameras as you want. And then when you run it, not everywhere, you go to it that way.
Yeah, it is a word, no? Because some companies, I guess, you have to go over the save files. The navigation is the same. So it's like it's C downloads or something like this. Track run, actually use those. Yeah, I can maybe I can try. Yeah.
So now, yes, yes.
Did I use C-cell, but this is bus, right?
Yes.
So I will have to, by default, I have C-cell, so I have to go to bus and run.
Yeah, you have I will show you. It doesn't really matter because you have two programs here. This is Get Token Interactive, which is for getting the token interactively by using login and password. But you can always go here to the documentation scripts and go to Get Token. It's also shell, but you can basically copy paste this and then copy paste it and run it in the terminal, and it uses URL, and you just have to replace login and password with your own login and your own password, and it will work as well. I just created Get Token Interactive for everybody to use.
Why you run it is just
Copy paste.
I will create a file with this inside.
You-
Then in my terminal, I run how to run it.
You do it. You copy
Just
it.
dot slash and the name.
Uh,
For CSL, I use source and the name.
That's no, you for this you don't have to do it. You just copy paste it. You go to terminal. You go to terminal here. You copy paste this, and you can use it. You see, I didn't get any token because I didn't provide login and password. But if I type my login here, instead of login, you just copy paste.
Create a file with this inside, with the login and password.
No, you don't have to create file. You can copy paste it into your terminal. But in Windows, I'm not sure. Sorry?
Line by line.
No, altogether, as I did it.
Altogether.
Yes.
It will be the
I'll go this, and now I can replace. Sorry, I will do this. Yes, I copy pasted, and now I can replace login with my true login, which is Mikolajczyk, and password with my password. And if I click enter, I will get my token. So I'm not getting.
See that you see the prompt, you say bus. If by default I have C cell, I don't have bus. So I have to go to the bus first. I don't think so.
I don't think so as well. I think CURL will work. Yes, because CURL is just it should work. It should work. But Pablo, if you have, by any chance, if you have problems, I can generate the token and send it to you. That's not a problem. We are here for this. Yes, yes, of course.
W ogóle tutaj było też pomysł, żeby generować ten token nie tylko jako interaktywny w ten, tylko w plik.
Jeszcze to jeden i drugi pomysł jest.
Dobra, jedziemy dalej.
No dobra.
Bo już sklep kasuje pliki. Nie powinien, nigdy w życiu.
Ale tylko te, które poszły z sukcesem.
No, ale jak człowiek sobie wrzucił swój folder jeden z
Ale on nie kasuje ich, tak kasuje. One są przeniesione do folderu sukcesu.
No dobra, no ale w każdym razie. No dobra. Damian, no, on nie kasuje, on przenosi.
No w tym samym miejscu, gdzie masz error. Paweł ci pokaże. Okay, guys, so I can see that some of you uploaded files. Some of you uploaded some files that don't exist. For example, Justyna uploaded a .ds_store file. Yeah, you uploaded the file that it's not there. And one of you uploaded also something strange. I will show you. Maybe I shouldn't, but I will. So I think it's here. Yeah, Justyna uploaded something. Yeah, you can see it doesn't exist. And Cornell uploaded README file, but it's okay. It's an error, so it's okay. So I guess the script works, and you can upload that actually. So
It's not checking for the particular type of the file in that folder. So it will try to upload
anything you want.
naked photos from the folder.
Yes, I'm checking the files, and when they come to the pipeline, I'm checking whether they are images or not. But you can upload GT file. It's doesn't not. It's okay. If it's a naked picture of someone, so special points for that. Okay. Thank you very much. And now, if we should go to if every one of you has token, we should go to API capabilities with Łukasz. Yes. Yes.
Yes.
Great. Thank you for the response.
Nagrywa się. Polecam.
So that's strange. Then
Right.
Right. Yeah, apparently when you were here, it's just not communicating. Because here you were not able even to functionally type this one, right? So try to run that file from here. That should, right? Because that's a command line as well. So if you
Okay. As an example of API, I'm going to just show you 3 different notebooks. So this is not the extensive API course or anything. There are, of course, the scripts, which are in the documentation, but these you can explore and try to see. The scripts are more like an encouragement for you to some of them might need some fixing, but anyway, they do the job. I'm going to show you a little bit more sophisticated scripts, and they are stored on my drive, so now let's try to get there. I sent the link to this through Slack channel. This is the Slack channel in BHTOM.workspace, BHTOM-2024 Salerno. This is the Google Drive there. So I hope you can all find it. I encourage everyone to be on Slack. Then, yeah. So I'll go around and see if you have any problems accessing the drive. If you don't, then you can start with this very first one, BHTOM filter targets. You can open this one, and I'll see if everyone has access to the files on the Google Drive. What to do now?
Filter is not that fast.
Yeah, that's interesting. Ben, do you have access to the drive?
I'm still trying to.
Okay, work on this. Okay, you're joining Slack. Do you have access to Slack?
No, not from this computer.
Why not?
Main computer.
Try to change the direct
phones. But I can.
You can try.
I can do this. I can connect it. I have a link in my email.
But I can tell you the link.
Oh, okay.
If you go to the browser, here. So if you type in Slack,
Jest już zakodowane.
Jest.
Jest. I on jest czytany normalnie, zamieniony na obiekt. Ja nie wyskakuję, że jest...
A, no to jest Żejmowski, Żejmowy program.
A, nie, to jest
Yeah, so now you need to check your email because they send you a secret code.
That works. Okay, so I put my username, I put my password, and then it probably works, but if it closes too early, so I was
No właśnie nie.
No, it's not quite. This is
And you're there. Okay, so first thing is like token, make it then run.
I like working on Google Column notebooks because you don't have to come back. So yeah.
Ale to było same rozwiązania kolejne pokolenie. Macie do swojego słucha? Dobra, idę do Ricardo.
Yeah, you just go to the page. This is where it ends. This now is success, and the last one is processing. So now you can surface organization. You are all set to upload whatever files you want. And if you get an error, you can change the success after you just check what's wrong.
How do I submit more slides? I'm trying to find the tag that I...
List, yes, but you cannot see the target. You cannot see the target in the list.
No, how do I...
You just put in Gaia 16 AYE. No, sorry. Yeah, target slash Gaia 16 AYE.
How can I be sure that this has been successful? Because I tried with the photo.
Well, now I try to...
Oh, you want to try with the script, yes.
Oh, yeah, the end of
For you it works, right?
Yeah.
So this was the previous slide. You see the strange data here.
No, to potrzebnie pisać na Windowsie, nie?
Tak, ale nie może być tak super.
No sorry, wiesz co, ja to jest po prostu przykład tego samego potrzebu, że z blokami. To jest tylko przykładowy skrypt, a jest na tyle otwarte, że sobie samemu budować. To było już pisane...
Tak, ale nie, ale to będzie działało. Tak, to w dobrym stronę. Nie musi to działać, że możesz. Tak,
yeah, well, now is that to find a way out towards that. I don't think that works. Maybe that would be the argument will be reconciled.
Wysyłam argumenty. Co się dzieje później?
Nie, dobrze, tak, to powinien być. Ten akces...
Ja mam dostałem
30 to jest normalne, tylko pewnie zrobi tak.
No.
Okay, so
I was able to dobry ogień przecież, bo mi się wydaje, że sukces
Co to za piwnicę? A, piwnicę, no, czyli to jest najbardziej, to jest najbardziej podobne. Ale możemy zrobić.
No to nie 11, ale chyba tak wszystko nie zrobimy, bo jakiś update chyba na maksimum zrobiony. I nie wiem, czy to wszystko zrobimy. I...
No dobra, no to wrzuciliście.
Ale teraz mamy tylko 2 pola, jednak ile tych ja muszę sam A właśnie, chodź do pytania. Miałem też
Ktoś tutaj pojechał ostro, wrzucił skryptem, sam skrypt. To nie Alicja. No, na pewno
nie, to jest fix, fajnie.
Co tu się stało?
API przeszło? Z Accessem?
Macie nie dane jest CCR, tak? No. I just go to Slack, right? Yeah. If you go to Slack and te obserwacje są słabe, bo
no dobra, ale mieliśmy problem, że wszystko to, co wrzucane do error, a teraz przeszło.
Teraz jest sukces, teraz jesteśmy po tym zająć, jasne. To w zasadzie
problem był uznany.
Now you're creating.
A to nie wiedziałem, jak się tego zmienić. Jakoś automatycznie też nazwę w tym pliku.
Mogę zobaczyć, czym jest problem, że co musicie zmienić?
Nazwę w headerze, żeby
tego nie musicie zmienić.
To the Slack, so and then to the drive as well. So here you can go to add channels, browse channels, and you can select Salerno. Here, join channel. There you go. If you scroll up a little bit and click on this here, this will give you the notebook. Thank you. Okay, I hope people have access to the notebook, but I forgot about things. We are sharing this notebook, so all changes are visible to everyone, right? This is not what we want. So I suggest you all make copies of this notebook in the very same folder. Just rename the notebook with your name or something like this. Because otherwise we will be overwriting our own changes. Okay? That's a simple thing I forgot about. So, yeah, so you can go to this one, right click on this. Here. So right click on this. And then which one is making copy?
Na później nie ma znaczenia, on się może tak zupełnie inaczej. Dajemy znać API.
And then, yeah, you can work on this one. You double click.
No, zostało przeniesione do Success.
Success w folderze.
No.
A jak nie był error, to error.
Okay, so you need to change the token to the one you got from before, and then you can run it.
Dobra, to ja może
Yeah, we have somebody's token already in the script. Someone was generous. So make sure you change, if you copy this, then make sure to change the token to yours. It doesn't matter.
Czyli nie musicie łączyć. Możecie wrzucać jak leci z
To jest ten...
target jest.
No, Sara obserwator.
Albo czytając nazwę pliku, zapisując nazwę robiąc pętlę samą
It's not, it's displayed in the, it's not designed for this. Maybe it should store somewhere in the file. Sure. Of course, you should be able to direct it right to somewhere. Yes.
Okay.
I'll make a note and show you this.
Dlatego są rzeczywiście on zdaje sobie
Now it should be yes.
In your video, why your original doesn't have the drop down?
Okay. Just to be further, let me give you it's like a maiden Indian.
Yeah, and the photo description of
the title itself.
Interesting. But in your original, no? In photo.
Weird. It's not harmless. It's harmless. So if you are running the filtering targets, you can specify your own criteria for your telescope. Essentially, the very first parameters in the first cell the param declination, the range of declination, magnitude, importance, and some distance. These are the main parameters you can change, and then you can run it.
Super shitty.
Because when like
Because when I am doing photometry,
I'll delete this.
Photometry for our science case, then I just.
So the only parameters you need to modify apart from adding your token are these parameters here. So declination range, magnitude, importance, and sun distance.
The corners.
And then you can run it, and it does all the job for you, and it writes into a CSV file.
You can access only your
Yeah, this is written on your own collab disk space.
Considering my fail, both failed, I will get
But it's even worse here.
Yes, so for example, we have this is background corrected.
Yeah, I am the one year's list of stars from Gaia, so there are no stars anyway. If you saw images from REM, which are not collab sessions,
This is uncalibrated.
but this is only the visible sources will be reduced, all the other non-sources or blank.
Yeah, but for example, when it's calibrated, also in my case, when it's calibrated, there are like sources, you know. So if this is yes, but it's actually just adding things. When you are doing astrometry, there are some stars which are not matched or something.
No, I'm not, because I'm using downsampling. There is downsampling. So I am downsampling. I'm making 4 pixels into 1 pixel. So this noise just disappears. So I'm doing the astrometry very efficient. It has to be like a overwhelming lot of noise in the picture for the astrometry to fail.
You can rename this.
Because in general, when I'm doing photometry for our
You're running it here.
I just set to ignore.
So rename it so that there's no
200 pixels on each side. So then when it's matching the images, it just doesn't care about this shitty.
We don't even care about anything. First, we have this Gaia catalog,
then
which allows us to identify all the true sources. We kind of do a little bit different for non-sided.
So this is a ready script. Copy paste your application token, and then you can run it. You can modify the parameters, and it will just do the filtering for you. Something what you do on BHTOM. This is the Gaia catalog. You can download the file.
Yes.
And then we have another photometry run for just for this object. And in case of the noise, it doesn't matter.
But okay, but with Danish, I think, you know, the long enough exposure I can go to magnitude.
Have you tried it? So we tried it before.
So I will be probably, I will have more sources than Gaia 3.
So the token you need to...
Because Gaia 3
Yeah, this is for your...
Or Gaia in general is magnitude.
This is your own associated with your own account. So you need to run it, you're running Windows, I guess.
All the known sources
will be
So if you go to
extracted from the images from the Gaia DR3D,
and then go to
and then I check if there are a lot of probable stellar sources, then these are added to the list and the process repeats. It takes a long time anyway because the stellar field is very dense. But in principle, when you have a new source that's not in Gaia DR3, it will be added to the list and subtracted from the picture.
I'm just asking, especially if it is
run this,
the upper limit.
download this and run it
Where
in
this
your
can
system,
then
it should give you the
my upper limit
for
would be
your password.
fainter than Gaia.
So you need to download this file.
Yes, and in some cases,
run it in
that's what we see. Actually, in case of Danish, what I
You
do,
don't need to look at this, but just download this and run it.
your limit
Not exactly how you do it in Windows.
was initially
This
19.5,
which
it's 21 now. So basically,
no, don't use this anymore.
It depends on how clean the mirror is.
They were
Sure.
Now we changed the name.
This shouldn't be a problem, of course. We have
So
this
it's very
supernova. If the supernova is very.
So you go to the
Sometimes it happens that if the supernova is different, it's red and it's fainter, and I can see that in the picture, but I cannot fit a profile to it, and it's contaminated by the background. I will have that. We had such a supernova in 2017.
So this file you need to download
supernova very well visible in the infrared and then find it. So that was problematic because now there is no supernova and there is a galaxy, and I don't know if it's still a galaxy and supernova or just galaxy. So sometimes it doesn't work, and this is the problem for the image subtlety.
Now you need to log into your VH.
But for now we cannot solve it. But it's a rare problem, so we don't really care right now. We have much bigger fish to Thank you, because it is a valuable thing to discuss already. I will discuss with Łukasz how to deal with such things.
Przemek, Valerio próbuje forsować filtr w skrypcie, potem powiedziałem, że spróbował swój i znowu forsuje filtr, on robi swoje.
Czyli ja dobrze przekazuję parametry.
Ale ty jesteś strasznie defensywny. Ty się boisz, żebyśmy nie przyłapali ciebie na jakimś błędzie i chętnie wskażesz błąd akontu. Nie o to chodzi.
Tak, bo teraz
masz myśleć solidarnie. System nie działa. Z takiego punktu widzenia usera jego gówno chodzi.
Jak się zaczną ze mną solidaryzować pozostałe członkowie zespołu, tak będzie. Do tego momentu ja pracuję...
Ale w tym momencie my bierzemy za siebie odpowiedzialność za to, co pierwszy akont.
Dokładnie. Ja od początku byłem tym, który...
Wszystko się nagrywa, akont nas podsłuchuje.
Dobrze. Dobrze, w końcu może dotrze.
Pozdrawiamy.
Ale delikatnie. The forcing filter does the work?
Thank you. Even for the single image on the website, I tried with the B image and then forced the I filter and still it keeps it coming.
Did you try auto?
No, I don't know why.
No, we tried with auto, and it prefers G instead of B. And Valerio wants B. There is a tiny difference between them. G is slightly better.
So basically, forcing filter doesn't work because API is not
It's still assigning the automated.
the automatic.
Okay,
Yeah.
but also the web interface.
Yeah, this is scary. This is not.
Capability is broken. We have to.
Well, that will be another GitHub issue.
How do you do this standard calculation? So you don't have the measurements of magnitudes in many filters and all stuff.
The easiest if that's a Gaia name, usually they use the Gaia name as name. So basically what you can do is to use that address targets and actually put them there because it works like that.
Let's say that
It's there, but it's driving the chemical.
to another place.
So I can upload?
That's why we can.
But I think you need to use.
So that's why this B is actually very
closer to G.
I don't know really if it is common. And so, maybe this doesn't analyze the application from Gaia.
And then
So you know that Gaia is perfect because Gaia is the only instrument that can
something like
communication from space.
It's not a problem with directory because it's
zero voltage band because it's
files.
yes. Yeah, then you know you see
Exactly, because the quantum efficiency of system is
exactly. This is the difference. So basically, what we do,
So the observatory token is
we consider
private.
this again.
So you need to
take the
check
quantum efficiency into account.
in the
This
observatory.
is much more like a G field.
No,
yes.
So actually,
So an observatory doesn't exist.
Yes, that's quite wide. It's very close to the actually because the fit was almost the same. So
that's why we sometimes don't use force features, but sorry for.
So now I can see it in
Yeah, but you should see that there, your files.
That's why we use the Gaia N, because the observation you upload is in the best possible.
Depending on how dense the field is,
Yeah, we used to always have, because students, we didn't tell students that what to remove. So they would plate solve. And plate solve
okay, yeah, you have to do
yeah, but in the end, what you can do before uploading is that just one line.
I always cross my fingers that the student will work it out. They don't tend to work it out. It's not in the instructions.
Yeah, there is one now, 100.
Sure. But like this, like doing that, fixing that, no student would. Unless they knew how to code, right? This is good.
That's something else also.
Yes, and the answer to this.
You're not gonna crash the computer.
Yeah, but students do some calculations, so basically we had a paper okay, you need 10 minutes to write a code, and then 10 seconds to get the result. In comparison with like 10 hours.
Does not make it will not show you the error. It's still there. Yes, it should be.
But even like
what we should do,
I think that's like research management stuff. People that write code. So she comes to me and she says, I need to work out a budget. I'm like, well, give me an hour and Excel, and I'll come save you weeks of work.
The problem that we have here is
yeah, but that's actually what I found that's IT computer.
But if you project the quantum efficiency, they are changed. And the central way of being shifted.
You know how to Google if something's wrong. You know what to do with your Google result. That gets you through 99%. That's what I did.
No, Google. We actually discussed this. I think it was last week at Easter. Yeah. Most of the time is that you just need to know how to ask correct question. I don't remember. It was the same when
people don't know
discussing writing papers in LaTeX. It's much simpler than before. And like writing LaTeX is super easy because all the complicated things you because you will need that once per month. But all this basics are super simple and just save so much time.
Right? The same thing with Python. I don't know what's best right? I don't MATLAB.
From that.
Yeah, I also started using
because we use images. It's easy.
anomalies.
Python, I don't remember anything. I just Google it and then forget.
It's also my case. I now know do all my analysis, but
I've tried to model.
We're doing the same.
But then you have people doing this in C, not even C, but
Yeah, that's the problem. If you do this, I'm not.
I think that the future, the language of future is Python, especially in astronomy, it's a huge community. You don't need to code the things because someone already did that and it's working. So why you change that? You can see the code, so it's not a complete black box.
The only method that can get
it just throws something, you see the result and you don't know what happened.
And if you have to change the linear version, the polynomial version, it's going to be 99% of cases going to look like a linear version. And this version provides
translated to Java. Yeah, it's Java. We want to have everything in Java. So we don't want your file to keep us Java.
We did do a lot of work on data reduction before, guys.
We know
I'm glad I was just doing the analysis for the RDS. But yeah, we had a guy. I did this code Java for the data analysis.
No,
never again.
I think that they super nice codes for the microlens. Now they were told for the architecture, just need to have that in Java. It's easy. If you take that, the code is not published,
you just need them as they are.
that's just a code for consortium.
And you have to use all your Python cards, and you have many outputs. But then every output will be perfectly consistent in its own. And you have
So is that must be on the web translation?
No, it's not be because it's a
that would be, that's like the must-have.
Yeah, like
yeah, seeing it in the driver. And that's, you know, you can do that dynamically. Take these
yes,
well, at this point.
Just on top of what is done, we'll just create one more. And you don't need to create the plotting thing because you already don't have the main part.
If you're using a big
something I was actually asking the audience because sometimes when I'm observing something I even don't know which object. Because I don't care. I know that it is a data. I know from the brightness that I will have a signal from my experience with the telescope. I don't need to check the signal of that particular object because I know that it's a problem. But it would be nice to actually then see, for example, post stamp around the object. Also, for example, now your students will upload some data from my target. And I would like to use them, and some of them are just strange. So, for example, I can easily see that it's blended with the super because conditions were super nasty. So the seeing was blended. So something that like that would be also.
It's good for that would be really useful.
And also, and also for the student.
No, it's only
this.
Yeah, but anyway, I got the data even if
this thing.
So when did it get this?
It looks like that.
Yeah, but again,
because often it's, you know, it's near the limit of predictability. So often they're like, okay, so but you can use the Starfinder chart and like really think about it as much, right?
Yeah.
This is just it would be nice for them to be able to
still do all that, get the stuff and when they upload at the end, you get
Okay, who is still having problems running the filter?
I haven't tried that yet.
Successfully.
I don't think I'm ever going to do that. But it would be useful to download a database so they can filter it like that. Is this the easiest way to get from this? Without an error.
What do you need?
I think that this will be good for you. Just to adjust the filtering to importance 0.
That's sufficient. Yes.
Should in principle it should not die, right?
Yeah.
The parameters are on the top, so basically important 0 and basically if you set a binary limit to 40. Some distance 0.
The limit is. Okay, so it's
everything brighter than 17. So if you will put like 35 or something, you will get everything. The declination here, I think this is set for southern targets, right? Because it's maximum 0, minimum minus 1000. So it's taking everything negative, right? Declination. So if you set there 1000 and minus 1000, that's a few more times bigger than the sky. So it's okay. And the importance, if you want that, it's 0 and the sun distance should be 0 as well.
Because then if I can get the CSV, for example, this way.
It should be, because at the end it's saving the CSV.
So I can provide that to students. They can write their script to filter it, which is practicing Python. Yeah.
But I guess you are working on the live version.
I think oh yes.
Yeah, their version.
I've just changed it.
Czemu piwnica TS 90 jest tak nazywa taki online? Nie. Daj sobie obserwator. To jest obserwator.
Okej, dobra.
To jest nazwa obserwatora, to online to jest tutaj.
Someone else had it.
I think that I'm sure that's
Okay, so it's got a tick.
here I think you can see
Pierwsza kolumna powinna być
actually I used it just for myself. When I was a few amateur astronomers, I create such enough for them because they don't need to.
Czy to może nie działać nawet dobrze?
How many of the stars are there?
166, that's not right. It was greater than 0. So that was the default filter, greater than 0. So I want actually, so they have an no, 0 is the smallest.
Yeah, but do you have, just check the file if there are some with deeper than 0. So it's still probably.
Okay, guys. So most of you managed to run the simple filtering target notebook. So this allows you to do.
Question?
Just a second. Instead of going to BHTOM, clicking on the list, and then going to the filter here. So just instead of this, you can run your filter here, and you will get as an output CSV file.
If I say important 1,
yes,
then I'm not getting those with importance equal to 1, right?
You do get. No? Have you tried?
He tried with 0 because he wanted to download everything. And it's not. When you checked how it is computed at the bottom, that it's greater.
Yeah, it's greater than. Okay, sorry.
So then it's not taking that.
Yeah, no, it's not. Well, you just need
But now
to
you should
change
get
this.
when it was minus 1.
3,000.
Well, these are just the scripts you can edit. You can do whatever with them. So.
Because I tried to download them all from the website, but it doesn't parameter list is too long. Times out. Bad request.
Yeah. Well, especially if you do it in Google Colab.
Yeah, this is fine. It's worked now.
Yeah. Okay, so let's have a look at some other scripts. There is another one which is called photometry download. And again, make a copy of this notebook with your initials and play with it. So here there are essentially 2 parameters. Your authentication token, as usual, and then the target to download. And you can specify the name of your target here, and then you just run it. What it does, it downloads the photometry, saves this to a file. No, it does not save it to a file, but it just stores it in a data frame, and then you can actually quickly display it. There's even some pirate data there. Pirate data.
I just uploaded some.
This is the ancient pirate data.
Ah, okay. Meredith.
Yeah.
Very busy.
But has he finished?
Yeah, he's not at OU anymore.
No. But was he PhD or? Okay. Yeah, he was very involved. Yeah. He attended some of our meetings here. So that's why we have a lot of data labeled with his names. Okay, so try photometry download, and essentially the same. Add your tokens and add your target name and download.
Maybe
if you want to work on your file in your Python or whatever, this is the way to go. You want the network to observe. So you need to create a target. Because you can also create we assume that people go to the list when they like contents. We don't have a kind of targeted push. We only have requests.
Do you know?
There's all very automated things we sometimes use. So you can use that.
You worked on the camera.
Yeah, but it's
so you can send
from there.
And give you the link to each targets.
Yeah,
this is a very important target.
But he always he's the biggest author, the biggest paperlist of all of us. Because he had
I'm just involved in the checking, so I don't know much, many of the benches, worries with the We'll probably check.
Oh,
I have the...
Co będzie ci te 60 takiego? To przetworzenie. No, bo jak nie to przetworzymy, to już byli już tutaj na wyżej. Szkoda tego, że jest dnia już też. A my mamy nowym backline'em. Nie, to jest tą częścią backline'u.
Zrobić też. Było niektórych dużo takich odrzuconych, ale tego to zabrakło nie nocy, ale...
Someone stood on the plug. Are you using the same?
Yes.
Mm-hmm.
Okay.
Mine is.
No,
I have. Oh, you're on a different one here. So it's this. Yeah, we'll be okay.
This is
To jest wszystko złożone. No, nie jest łatwe.
Must be the strip. Yeah, there we go. Yep, it's working now. Magic hardware issues as well.
Probably someone just... It was a bit...
My next job is to
How?
It's been really, really, really good for 5 years.
Showing it's already more than 2. I guess most of these things are just made to survive years. Especially this is very good for laptops.
Yeah, I don't know why.
Nice. That's what we do at the conference.
Yeah, exactly. Yeah, get your filth.
Because I get it also, but it is not going another way.
Try.
But actually, what usually when I have external screen, I use this phrase. It works quite well then. Now I don't have
I did some processing similar files. Sometimes it works, sometimes it on the quality and the field of view, but there are a lot of stars visible here. So,
I really like the touch screen. So just for like holding it's not that great. When you are just
awful
reading or
my brain focus.
Because I often go to
Maybe it's better.
I don't have a second monitor.
if you will have only 1 or 2 targets,
So I was looking at like the yoga, two screens and a keyboard. I don't know if that's better for
before I had like 15.6 stiffest classical, but then when you're traveling it's not smooth as well. But then the screen is a code. But for me I need like 5. This one, the disadvantage of it is that this USB-C port, which is here, cannot be used. So you have just one HDMI port. So that means one external screen. So my wife actually has, now she has a new one. The one she had before was older, so that there was a VGA port as well, but HDMI. Basically, she was able to connect 2 screens, just because they were still keeping that old port there. This one, I would love to have. Maybe even not use this screen when I'm at home or in the office, just with big screens. But for traveling, this is the ideal. Like this one. Yeah, that is what I found that, you know, when you are at the airport, when you are in the train or in the plane, this is I saw people working on screen with this size, that's just 15 points. One of my colleagues has something like 17. Like this big. It has like 5 kilo. Super huge. Yes. I need to check what was the. Are you on Slack? Are you in the Slack? BHTOM Slack? So email.
Yeah. So basically, yeah, the same thing.
Gmail is okay.
Yeah, this is one video-wise, because the wise is the wise
issues on core network. Get my name on this paper that I'm going to work for. Finally.
Sending a request. Because, you know, until we have this one,
this example has some data from, but in general you find wise.
Yeah, actually, I wanted to pick up part of the consortium, but I was sad.
It should be on your side now.
That's not very
Satellite.
Yeah, it's the money.
If you're interested in.
Yeah, I'm not that much interested in
We can add on
no.
the
But I think that the survey, which is not even for me, but actually no one is working on that latency. Nice.
And then I can design my observing strategy. If I know it's
maybe
I do further observation.
But then this will be good if you want to try something that doesn't have ephemeris. Unfortunately, already the ephemeris they distribute are not very up to date. I update every 6 hours, but they don't do it. So if you are ESA or ASI, whatever, they have their own program, really narrow the error, and then it gets very precise. But here it depends, of course, on the speed and where you are pointing. Yeah, typically for let's say, well-monitored satellite, within your couple of 3 RT, you can catch it. So it's really...
Is REM observing?
Yeah, we are trying to observe something, especially in infrared. Yeah.
I suggest that benefit stop pretending. Just go for what you're best at.
Yeah.
If you're trying to try to without seeing for trying to add, that's I found that the second one that looked
Do you use?
Yes. MBRC. I just tried to. And I found that within the astronomical community, it's
only when I started getting involved with like space industry, space skills, and stuff, done research science.
But it's sometimes because there was I think that effort to make some kind of social networks. LinkedIn is also kind of social network for researchers, which is ResearchGate, but it was also and then sometimes it's really easy because you know that there are people who are doing great stuff. Doing your best, failing to find contact information. Some people just try to hide themselves. So I was when I attended some kind of like communication courses or something specifically like for astronomers. People said, please set up a website or something because we might want you to give a talk at our colloquium. We are not able to find information about you should contact you. In the paper, you know the current email address, which is not valid after half a year because you're not anymore at the institution. So sometimes even if it's like super hard to find some contact information, who I know. I'm organizing a conference right now.
Okay, I don't know how to solve this in Windows. Sorry, but I'll double check that the password is not visible.
Send them information. In some cases it was impossible. I was not able to find where they work.
Okay guys, the very last example of notebooks is filtering targets for specific telescope. It's very similar to the previous filtering as we were running before, but on top of that it also does another query. So here we query all targets which are now of interest. Let's say, okay, for tonight we want to have this list of targets observed. But now you would like to observe only the targets which you have already observed in the past, right? So that you want that for your observing strategy would be better to observe instead of observing new targets and then contribute 1 point here, 1 point there. You'd rather stay with the targets you have already observed. So this script, it does this. You specify, there's an extra parameter you see, camera name. This is the old name Przemek was showing. You need to find the name of your telescope in the system. How is it called? So there is additional query which essentially runs, asks the BHTOM, give me a list of all observations from that camera. And then there is a cross match between these two, and you'll get a list of targets which are, first of all, they are important for now, and you have already data for them. Okay? So, yeah, just try it if you have any data, or you can use Go Chile as an example if you don't have any data. But this could be helpful for some of you setting up the observations. If there is no data from your telescope, then you also get a list, essentially you get the same list as you had before in the previous filtering system. Yes, because it will also give you it will specify the criteria and it will give you the list of targets which satisfy the criteria. Okay? So try it again, just run it. It creates 2 files at the end which can be downloaded.
So if I wanted not to try and run, either submit this file or do it all over again. It'd be nice to just have yes, this program is okay.
To jest na poziomie oryginalnego.
Two of us.
That's my point. That's waste of resources. And for some really dense code, it takes 1 hour to use the files. So it makes sense to spend another 1 hour. But I didn't know that basically I can now download this photometry.
Yes.
You said that it would be nice to have a button there to say like the dry run is okay, so use that.
There's two of us now.
Still, too few.
So let's do it. Let's pull it the data. But I can't see it.
Yeah, but still, Łukasz, it would be great what we said, just below the calibration plots.
To show the light. Yeah, I made a note.
Your plot.
Yeah, I made a note that, yeah. It can
Because
be.
that should be very easy.
Because these are going to be non-astronomy people. They don't know if the dry run is good
Yes,
without
yes.
seeing it, right?
Well, you can train them, right? They can have a look at the light curve and see what is more or less range. They can learn from the light curve what to expect. Then they get an outcome, and you see, okay, the measurement is not with -1, so it was detected, first of all, and then you see that it is within the range. So instead of a plot, you can have them think.
What does it mean within the range?
Yeah.
Define that.
Well, then the error bar, and you can start talking about how you match things. Yeah, you can have a whole curriculum there.
We should go more into the direction of what Assassin does. So they have this, because this basically is a forced photometry, what we do. And we provide a lot of data products like profile photometry, aperture photometry, and for many events, different photometries will be better. And we always, we display only one of these. We should have many choices in the plots, as I mentioned to you.
Well, in the plot, it will be overwhelming. I would I would not do it.
You should have a switch.
Yes, switch that would be.
Have you ever programmed these plotting routines?
I'm
No.
not programmed for this. So
exactly.
I'm
So
not paying it
that's
for
I'm
this.
trying to minimize the effort here, but we can give it. We can push it to the users. We can allow this kind of download in API. If you want to use if you want to use more obscure photometries, then use API. Have way more functionalities in API than in GUI.
Not gonna happen.
But no, I don't think it's a bad idea. But then the good thing would be to provide some example scripts.
Sure. Yeah.
Because that's something.
Because we have a range of users. We have completely vanilla users. You don't want to complicate the GUI for them, right? Yet another switch. What is it doing? I don't know what aperture photometry is, right? I don't care. And then you have more experienced users who are actually looking to these details, but then they can probably also run scripts. So they can deal with that themselves. So we make the system both minimized and accessible for people not knowing too much, and then allow all the features under the hood, right?
Yeah.
That's the way to do it. It's the right way.
But it would require a change in our system anyway,
It is
because
already,
now we only
it's
store
already implemented
on your side,
No, on Icon site as well.
not in BHTOM side, because it was never
BHTOM site,
foreseen.
no, but in Icon site, yes.
Yes,
Because I asked Artur to provide.
It was never foreseen that there's going to be different types of photometry. But that's, I'll make a note, because it's a good idea.
Yeah, this is also.
That's annoying.
Another feature, please.
Make that a link. He's done with us. Done with our suggestions. He's finished. Okay.
Is that?
Make that a link so I can click it.
When we're here, we cannot get light, right? So we need to go to the targets.
True.
Okay.
Fairway.
A poczekaj, możesz się przetworzyć.
That would be nice.
Yeah.
Sure.
Yeah, but it is too much things to do.
True. I'm making a note.
That's simple thing. Yeah, just
all simple things to do.
Yeah, but he brought us here to
give them simple things. BHTOM is down. Maybe the internet is down. The internet is down.
The internet is down again?
Well, maybe BHTOM. I didn't want to suggest such a figure.
Don't you dare.
That's okay. BHTOM, I can't get
Tylko teraz nie można dołączować, dlatego że jest instalowany rower. I wszystko się...
So how does this interface with Cambridge Science Service? Does it pull across the existing data or not anymore?
Say it again.
How does this interface with the Cambridge Science Server?
It's dead.
Right, okay.
CCS is dead. And we switched it off last year completely. It was still in the intermediate stage because BHTOM was kind of built up on this.
So my students won't be able to upload to Cambridge Science Server?
No, not anymore. There used to be a case like this, but then we stopped this, and now the only way to upload is to BHTOM. Cambridge Photometric Server, it was only allowing instrumental photometry, which is now the functionality of BHTOM, right?
I'm just thinking because my students are doing it in a month, so I need to edit the material.
Sure.
Ale to też jest to jest
What I can do for the alert system. So they can do everything filter, but they need to upload it.
And basically, you said that gas sensors will stand in
December.
Yeah, but in principle, it's still this is a valuable resource. So still you can, because you're not observing just the recent targets from last week, right?
Well, no, that's nice for them, right?
So because then you still can go for years with this.
Yeah, sure.
To do the follow-up, because there are several things which are slow.
Okay.
Because then when you are just observing things which are currently in the brightening, it's nice, but
Przemek, Damian wysłał poprawiony skrypt, ten twój. Mam go, wrzucę go do...
Nie wrzucaj go.
Dlaczego?
Każdy skróci korzystam z API. Ten skrypt,
Nie będą.
Dobra, mówiłem ci, nie wrzucaj tego żelowskiego też.
Also, from a scientific point of view, I'm not working on microlensing. I just observe something.
Ale to właśnie mi to pokazuje, że musimy mieć dobre skrypty, bo ludzie po prostu jak małpki rzucają skryptami.
Że my powinniśmy po prostu udostępniać klasę. To się sami robią.
Większość userów jest, zobacz, nie da rady.
To przez
So another nice exercise.
Nie zgadzam się.
What students in previous years observed, and if it is not useful to re-observe that for with the help of like.
Well,
there you see.
It takes time.
I tried already twice, but on the restart.
Yes, those I'm not sure.
Yeah, this one is
because if the target is there, then the data are used. But there are targets which were not created in black hole that have all the data. Maybe they are not. Yeah, but definitely not every gas sensor is in black hole. But not every gas sensor has data.
we asked them to choose
But in Black Hole Tom 2, or maybe the first one.
just because, right? But if you're saying it's scientifically useful to get something that helps us, because what happens is if there are 50 students all observing exactly the same target on the same night,
Yes. I have it.
Sometimes, especially when the changes are quick, when you don't
my so I must. Yes, only one spectrum. Is this okay? So
but
yeah. Remind me, this we've made.
I'm reminding you.
Yeah. We have Sprat.
Because yes, it's going down, so it will be fainter.
Spectrum from Sprat, it's 300.
It's a very low res, but I am actually interested to see the evolution.
H alpha is visible.
Oh no, also other.
I have it. Because I didn't have time to do that.
But I think that, or I have not sent that spectrum to you because you can maybe not because you were asking for a higher resolution.
Anyway, anytime you have a new data, they are fetched, so we normally take a few megabytes.
It was here, so maybe it was in Black Hole Tom 1.
Yeah.
It was not migrated to the second gen because the photometric data was migrated, but not the spectroscopic data. So if you have it, you can upload as ASCII file, simple text file. And if you remind me about this target, if you remind me about this target, I will put the spectrum of Strat here. So if you want to see the
Otherwise, there's not public.
the new one.
And for each object, then you can.
Here you can. This one has.
Yeah, I will put this one. And after getting new one, I will put the second one.
You can follow your own plugins here, for example.
You can, you actually will see.
Okay, about it.
But also you can
network.
So
if you click into the plot, because that plot is interactive.
And what about the data for this blocks?
Here, it's sorted by filters. Here it's sorted by. So if you double click, you can double click just once. Then it's hidden. So you can double click.
Too much?
If you now click on this menu here, this one, so these are the remaining one. It was bigger. There are these two colors. First, each project is sorted by filters. You can for individual filters. Double click to select just that one. One click to add or choose.
This is the like the thing we use to talking about, but we show you the project you can give directly the link and then one thing the objects that are present we do that anyway because for the they use the uniform university token. So they use the same token on the campus, right?
Otherwise, you you grab this is that's the link to
And now they can see.
And so it was that phase there. Just next to that phase. Yeah, but this is just from the survey. I think it will be also for me that really see that, okay, but there is really that. But for me, when I am the user of the data, that's the object I work with. Some data are just and I would like to know why. I don't know something wrong with the server and I just worried about the guy. Just because, for example, the consumption so the objects are you are measuring the photometry is completely good, but it's just resolving the and for that like that would be useful. Also for not only to check my data, but also to check giving me for my
you can manage the price.
But this except the data. So it detected checks on so it wasn't detected.
So this value is actually which was the but with that condition, at that quality of data, you were able to detect the faintest one was 9.5. So anything fainter than that, you just don't see that.
So the object
Once
you can read the sky,
there is nothing brighter than that. That's usually useful when you can nicely cover that these data are very useful. They are very useful when you are, for example, looking at the pre-discovery images. And you, for example, consider all pre, you can constrain the time. And the other thing is because, okay, I have the image 3 days before yours. You don't see anything. Amazing, of course. It was below, but still in the average, it's magnitude 13. You know, I can see 500. The ID and so you can kind of precisely constrain the time. So that's when it's useful. Or constrain the amplitude. So, okay, I was not able to detect that from the pre-output data. So I cannot tell exactly what was the full amplitude of the band or outburst or anything. But I know from this data it was always better than 9.5, for example. So it has to be 700 or more. Being good, that's the point that's it's useful to also have.
Mine was one from me. If it is one,
this might come across together. Very similar.
Okay, this one should be a extract price, right? Okay, so on the just in the catalog also for larger
that should be basically the position of the image. That's yes, that's a good point. Anyway, I think it's sorting based on the brightness, and therefore this is the first numbers. It's a the number of the stars. It's aside, yeah, it's not sorted. It's sorted based on the prices. So that's an instrumental magnitude. Yes, because that's not a calculator. Yes, that would be the instrumental magnitude that needs error. And you have rectus tension declination.
Okay, fine.
And here you have the position of your image. So that's X and Y position. So that's a simple.
So, but the object.
The one closest to the correct coordinates. Because it's sorted, I think, from what I see here, it's sorted by the instrumental magnitude. So it doesn't necessarily need to be the brightest one in the field.
Because this is what students upload in the exercise. So they need to generate that.
Посмотрим, как
make it work in BHTOM. And normally it's not hopefully a bit more forgiving because every site's like there's a tab in the
That was the idea.
I know, but basically these are just comments. First line are comments. Then it shouldn't need to follow this format. So something
I hope so, yeah. Okay, so good. Thank you very much.
Okay, I say goodbye to everybody.
So let's thank Valerio and then the local organizer.
And if you need anything, you can also ask Paolo, who is the other local organizer. And so that's all. So it has been a pleasure for us to host you in Salerno, or get to Mali with the precise place, the precise village place. And I hope you will be back again for tourism or for other workshops. There will be opportunities. Also opportunities to collaborate in this BHTOM project, which has been very fruitful for today's workshop. So we learned a lot of things. Okay, goodbye to everybody.
Thank you.
Very nice, very nice. I definitely would like to get back. I need to make a note of what you told me, so that I forget.
Okay.
But I think, you know, we're getting to the close anyway. So I hope, well, some of you managed to run the notebooks, most of you I hope. There is going to be, you know, the recording of all what we've been saying here and showing, so we can always go back. It might be difficult with the audio sometimes, but still, that will be a recorded reference, so you can always try to retrieve what's there. I think the very last stage, we were supposed to spend like 2 last hours, like Q&A, feedback, discussions, and so on. I think we had it already a lot. Do you have any, I don't know, questions now, immediate questions you'd like to ask, or questions or feedback, or just say this is all rubbish or this is all useful? Just be honest. I'm making notes, and everything is recorded.
How honest can I be?
Well, we'll have dinner afterwards, so it's not the end, right? For all the honest feedback later on. Anyway, anyone?
Depends on the feedback if you are getting feedback.
Ciao. Anyone? Anything?
So I will start with the point that the version of the script for the Windows is not well tested. It must be tested.
We never worked.
It wasn't tested at all, that's the problem.
I think there were some tests by Yakov, but...
By Yakov, so probably...
Stop it. Stop it. Stop it. Yes, yes. So, and we had some discussions here between Ben and Yaro as well. So, you know, some people would like to have loads of features, like many buttons and many features in the GUI, so then that you can do multiple things. I'm kind of against this. Because my approach would be that we try to make the system, it's already complex, as you can see. We try to make it as simple as possible, assuming our users are, let's say, underground level students. Don't be offended, ladies there, right? We're just trying to adjust to that difficulty level, experience level, let's say. Okay, this is not offended, I hope. And then, because you can think of many more advanced features, we make them available through API. And that is probably the best way. And then people who would like to explore more, use the system more. For example, the example was there that we actually provide not only PSF photometry, but also aperture photometry. For some usage cases, that might be better than PSF photometry, which we by default provide. So it's a small action on us to make it available, but I wouldn't add it to the GUI because that will blur the picture, right? It's already complex.
I strongly disagree.
Now I'm speaking. But if we make it easily available through API, then people who know what it is, then they will make a good use of it. So that would be my approach. But I take feedback from anyone else but Przemek, because I know his
yeah, I will not say
his approach.
Okay,
I already have a lot of suggestions for all people. People online, you can also send us your suggestions through Slack, and we can all communicate through Slack, of course. You're most welcome to get in touch through that Slack. Remember, this is still free version of Slack, so old messages disappear, okay? Anyone, anything else? Everyone is tired. So now it's time for the beach and wine, I think. Okay.
Probably one thing is that if you will have a room for other collections, let's say, of data, just photometric data, that would be probably.
Oh yes. So we are already started working on spectroscopy, astrometry, polarimetry. These things we would like to add. Everything time domain is close to our heart, but photometry is the easiest. Yeah, someday. Cool. Okay. Still 7 minutes to go. So I'll be cruel and we'll do a round table. Okay? One or two words or sentences. Przemek starts. What did you learn? What was good? What was bad? Okay, next.
He's just
Please.
opening his list.
yeah.
He's just tired because he's done a lot, so we have to appreciate this. Please.
Okay, so since I'm new to the team, I learned a lot about a lot of new errors.
A lot of new errors.
So that's good. That was good for me. But also it's good that we had the opportunity to find out those errors and for you to report them to us, so we can try to repair them. Yeah.
Mm-hmm.
So that's the main advantage from this workshop for me.
Good, thank you. Luciano.
Yeah, well, and that was my first approach to this type of managing, and of course I was more and more, in part, interested in getting let's say the recipe for a reliable measurement. You know, that is one of our main issues with RAM. No, we don't have, unfortunately, very nice and uniform images. So as far as you have your object near the center, but that's not bad. But otherwise, we, after so many years, haven't been able to provide a standard pipeline to produce clean images in the optical bag. So perhaps, yeah, having something that can be tested or tuned or say critical or not easy instrumentations, that would be probably something, because you have built a lot of expertise now. So probably you could probably support people that have instruments cover that is not optimal, let's say. That would be something that would be. By the way, I mean, my two images are mid-level, they both got error in the processing, so I don't know why.
Well, you can
for example, just to show that it is not an easy instrument.
It is not.
And, you know, as somebody says, okay, you can find classical, typical, standard pipelines to get photometry online, or whatever. But in our case, no one worked in an easy way. So you have always some, you know, some points that don't go smoothly, basically. And so I repeat, being so expert in this type of things, one of the feedback would be, you know, how to build an appropriate pipeline for not simple image. That would be one. Another one, you didn't mention astrometry.net at all.
Well, we use it under the hood.
Okay.
We use it you use it in the worst cases. If we cannot, because we use Campus extractor, so basically the same thing as Nova Astrometry uses, but we use it with different parameters. And if our pipeline fails, then we send it to Nova Astrometry, which has a much broader set of parameters for use. But it's like maybe 2% of case.
So, but the main catalog that uses the 2 mass or what? For the astrometry, the first astrometry resolution
in the north, it's mostly URAT-1.
Europe. Okay.
In the south, the basic astrometry is mostly based on UCAC4, UCAC4. And then the final astrometry is based on Gaia.
Okay. Because I made a custom version of astrometry.net where I can use any catalog, basically, you know, that they have this index file. Unfortunately, they didn't use a database approach. They use a fixed file approach. That's why sometimes it's very slow because you have to read the whole feed stuff.
We know that.
So I made the version that instead uses the index from the database.
We have in our version we can use any catalog. So we browse through catalogs as long as we want to browse through them. And sometimes it happens that none of them work, and we send to astrometry.net. But you can actually specify catalog in Scala. Just say what catalog you want.
This is just only a matter of, let's say, performance improvement, not of solution.
We only want to speed it up.
Yes, only for
it worked hundreds of times faster than Nova Astrometry because we only take a little bit of the sky.
Guys, I'll let you continue this topic. We have the whole evening.
One corner of the room.
Yes, well, you make sure you sit together because this is a very important and interesting. So, thank you very much. Let's move on, Pavel.
I mentioned about the windows.
Okay.
I'm done.
Jaro.
Yeah, I wanted 2 words, so I think it's thank you. You brought us here. You know that I use Black Hole Tom from both sides as an observer and as a user of the data. So for me, it was a nice opportunity to pass some of my ideas, to repeat few of the ideas, but also to learn while repeating the whole process to see where I can tune my approach slightly to be more effective.
Thank you.
Yeah, this was really, really useful. I expected to find out if this was going to be workable for my students, and instead we have Pirate added to the database. I've submitted successfully old measurements by students. For my students, it's key that it's very, very, very simple because they will get confused easily. But also talking to you all about, what's the useful science case for them to be doing that might be added in papers later. So it's been probably a week's worth of work I've been able to get done today. And your time as well, probably emailing you things that I have problems with. So it's been really useful. Thank you so much.
We will. We are, of course, it applies to everyone. After the workshop, you might have more questions, so use Slack or emails. Don't be shy. Ira.
I had a lot of questions, and now I have the answers. It's very good.
Very good. Thank you. Imre.
Okay. So, again, I would like to thank you because a great job done during those years. I'm involved in a few other follow-up programs, and I would like, for example, Exofo. I would like to tell you that this system is perfect because the most sophisticated part is the calibration, and you took this on your side and automatically do this. Otherwise, you need to not also to process the images, but you need to analyze everything this. Imagine that you requested from us to analyze the microlensing curves and to provide the parameters. This will be crazy, of course. That's what is done in Exofo, for example, but there is a lot of documentation and so on and software. And you took this on your side, on your system, and this is done perfectly. So I think this is the most nice system at the moment for calibration and follow-up.
Yeah.
So thank you very much.
I will use it in the report.
From our side.
Happy user.
Yes.
Okay, thank you very much.
3 X's.
Thank you. Tanya.
Yeah, thanks also for organizing this and being able to come here. So for me, yeah, I learned about the general things, how importing targets and lists, and thanks Pavel for the details, so it was useful for me as well. But then I also got some ideas about this new project that we are starting, which with some Tashwa, which is basically to build front end for the Euclid transients. So yeah, a lot of new things learned and some things. Thanks a lot.
Thank you.
We will send you the place where we were talking about.
Yeah,
I mean,
yeah.
In the code where you can change the Gaia Allen's name for TNS name and use it for your own.
So thank you for today and for your work. For me, BHTOM is a great opportunity to search targets because I have a lot of gaps during my observations. So I'm working with this like more than 1 year. So still today was a good day with the chance to see how it's working with the code, of course. And yeah, and I agree that it's a good tool for students, and I'm having it right now in my university. So I am teaching also because of my PhD, and I have observation lectures, so I think I'm gonna use it.
Yeah. We can work together with some curriculum solutions. If we come up with something, and vice versa. Cool. Pablo.
Well, I learned a lot of things. I didn't know much this BHTOM, so it was very useful today. One positive thing is that you can gather all the photometric information from that just through the web interface, and you don't have to go to every archive. So that's very good. I need to check now, for example, whether the calibration that I get from here how compares to if I do it myself. That's
very good.
Compared uncertainties that I get. But I think I understood that you don't like this, but this is about time series. But the only thing we have is the light curves, right? So I was wondering if it would be useful to incorporate some kind of time series analysis tools, like that you get a periodogram, or you know the orbital solution, you can do epoch folding and have magnitude of flux, a function of orbital phase. I don't know.
Sure. There is a place for some analysis in the models. If you have any ideas, we can code it together and add it for you and for others. Okay. You can plot phase folded line pairs and find periods, stuff like this.
Can you do that now? Or?
Well, not now. I will need your help, right? I can give you the framework, and you give me the insight. Okay?
I'm not an expert in programming things.
Okay, we can work, but this is a good suggestion. So at least we can start from this. We need to find someone to code it.
folding what was suggested with the orbital phase is just a way how to plot the data.
Sure, but still you need to, well, I would rather
That's
put it
one.
in the modeling stuff.
Yeah, yes.
First you need to determine the
You
period.
can just put, you know, the field for some period, and then you will just
slider to.
Yes.
You will just follow the data with that period.
Still, I would add it to the modeling section.
Yes, yes, yes.
You know, phase folding, and then you can do both. Plot the phase folded light curve and also search for other periods, and then you can play with it. I've seen tools like this, they exist, but you need to code it and add it. Yeah, that's a very good solution. Good. Thank you. Paolo.
Well, first of all, thank you, because this is a great opportunity for me. Also, this is my first time as a local organizer for a workshop, so this is the best way to start. And I learned a lot of things. I need time to digest all this, but I can't wait to be operating with the new telescope in Salerno. So I hope that we can observe a lot of targets for the community and make science. Thank you.
Thank you.
So there is a telescope in Salerno?
We are waiting for the dome and the telescope. We are constructing.
In Salerno?
Pisciano, yes.
On the coast.
On the rooftop of the Department of Physics.
How big is this telescope?
It's a reciprocating of 0.6 meters.
And they have been observing until they got struck by a lightning or something like this?
Storm wind.
Storm wind, something like this.
A storm wind destroyed the dome 5 years ago. Unfortunately, without killing.
Yes, that's true. No astronomers were harmed. Thank you. Talent.
It was a great time. I learned a lot. I think that I'm ready to observe and send this data to BHTOM. Thank you.
Thanks. Great.
Yeah, so I was in the tooling workshop a couple of years ago, but then other things got in the way of I didn't really do much with BHTOM, but it was nice to come and see how it's changed, how it's evolved, and the improvements you've done, and get back up to speed. And hopefully, I'll be able to contribute data and maybe some other things as well. I'll talk about that later. Thank you.
Hola.
BHTOM is new thing for me. I'm glad that I learned a lot of things how to use it correctly. So thank you. And now I can see some data points and with my name on this photo in chat, so I'm proud.
Good. I'm glad to work.
So I think it was a great opportunity to be here. I would very much prefer not to have allergies. It gave me very hard time today. But yes, I think a lot smarter now.
Glad to hear. Ricardo.
Yeah, I think I learned a lot. I was able to follow your examples. I have an observatory and submitted data more graphically and automatically. So what I expected.
Good. Yes.
I think that BHTOM is absolutely a bomb, but I'm repeating what people are saying now. So the point is that I think that in this way we reduce the time that we have to observe and to reduce data. So this is the key of this BHTOM tool. I think that is good for a student, as Lucas said before, because you have the opportunity to handle with your data at the same time, but you can also have a sort of control, supervision from people which know what they are doing. So I guess that need to be promoted a little bit more. This is
After we fix all the bugs, then maybe yes. Yeah.
So thank you.
Yeah, thank you. Septa.
Big thanks for the organization and just in general, how kind all of you are in helping the small stuff out. So the big thing is that the user interface is very, very useful and it's so easy to query for the past data, which I think I was looking for, and it's just
really easy. The other thing also I checked for the gamma ray part is that it's a blazar that is very well studied. I took the coordinate from the Fermi-Length catalog and it gives me the light curve that looks like a blazar. So even if the gamma ray has relatively larger error bars, but still the well-studied one shows up in BHTOM. So it should be now, I have idea for assignment for the students. So big thanks, and also finally the notebook that you shared is the one with the different spectra, mass, neo-wise, etc., etc. This should be very useful for checking different light curves. So big thanks for organizing so well.
Thank you.
So BHTOM is very user-friendly, it's very simple, and I think it's the biggest advantage. And well, it's a lot of data ad hoc waiting to be uploaded.
Again.
Yeah, so I used BHTOM before, but I still found some useful things in these workshops. For example, these notebooks, I didn't use them before, so thank you very much.
Thank you for this workshop. I had some fun playing with Go, so welcome.
Found some bugs. Yeah. Very good.
Bugs. And since I think I'm the last, I suggest that we can go and prepare for the dinner.
Thank you very much. Thank you. And we have dinner at 7 somewhere downstairs, right?
The same place.
Same place or not, I think.
I think the same place.
Yeah. So a quick swim in the beach and then we can go for dinner.
Thank you.
Thank you.
Well, applause for
Many others as well. Thank you. Okay, let me stop this. So we are about to stop the streaming. Thank you for joining. Hope you enjoyed it. Where is it?
Nie, chyba nie zniknie. A jest, no.
Yes.